and welcome everyone. Welcome to my YouTube channel, and I am starting this Cisco ASA training on my YouTube channel. This is my first video on the Cisco ASA training. So we will have a series of lectures or videos for this ASA. So please be patient and continue stepwise, because this will build up after every video. So you need to go through the basics to understand the advanced topics of ASA. So this video will be just an overview of the ASA, and in the next consecutive videos we will be starting the labs as well. So I'll be using EVNG as my lab. To demonstrate the lab, you can use Cisco Packet Tracer or even use GNS3, right? Or if you're good with the workstation, VMware workstation, you can use that as well. You have Cisco ASA V virtual machines, and you can use them. So coming back to this video, right? So what will be the agenda of this video? So I'll be just going through the ASA overview, and then just the history, brief history, how ASA has evolved from last 2 decades or 3 decades. So let's start with the history. So what is a Cisco ASA? Basically, Cisco ASA is a hardware firewall from nowadays virtual as well. They have the Cisco ASA V, but they usually started this with the hardware appliance. So this is a firewall from Cisco, network firewall from Cisco. Okay, but before that, just to recap, what is a firewall basically? What is a firewall? Most of you would know firewall, but I just want to give you a brief definition, right? So what is a firewall? Firewall can be hardware or software, right? Or software, and it governs actually or you can say controls, right? It controls the traffic flow inbound and outbound through your organization, right? So that is the definition of basic definition, not the complete definition, but this is what you can understand. So it governs or controls the traffic flow of inbound and outbound of your organization, right? And firewalls, as I said, can be hardware and software. So this ASA is both. So you have ASA V, which is a virtual machine. This is just a software, right? You don't, and then you have these appliances, Cisco 5505 and 5520, 5540, like that. You have the boxes. So those are the hardware appliances, right? So that was a brief. You guys can have multiple definition for the firewall, but let's continue to the history. So basically, Cisco had their first firewall, which was known as PIX, Packet Internet Exchange, right? This was again, predecessor of ASA, but the limitation that it had was it used to do the controlling of through traffic, whatever. But the capability where it lacked was it used to do the side-to-side VPNs, IPsec and L2TP, PPTP, and also the where it lacked was the SSL VPNs, right? So SSL VPNs, it was not able to do the clientless or the client-based VPNs. So what are those? So you even call them remote access, right? Remote access VPNs, and client-based is nothing but using AnyConnect. Or you have, you have in Palo Alto, you have the global protect, right? So that is the remote client based, and client-less is the web based VPN. So this Cisco PICs lacked these features. Okay, so what Cisco did was, at that time there was another company by the name of Altiga, and they used to produce these VPN concentrators. Okay, so they used to produce these VPN concentrators which were doing the VPN part, I mean, excellently, whether it be the IPsec side-to-side VPNs or the remote access VPNs, right? They used to do the SSL VPNs based on, you can say, the client or clientless. Okay, client or clientless, both. So what Cisco did is they acquired this Altica VPN concentrator company, and this was in early 2000. Okay, they mixed these two boxes, so they had their own PICs, right? And then the VPN concentrator box, VPN box, and this was called as the ASA, right? So this was the generation of ASA. Before producing their own ASA box, they used to sell this solution separately. So they used to sell the PICs and the VPN box as a solution. Okay, so you have these two hardware separately. But later on, what they did is they combined these two, and where the ASA evolved. Okay, and that is how we know the ASA box as of now. So that was a brief history from the ASA point of view. So ASA can be so just basically think about this. What is the difference between a router and a firewall? Basically, a firewall can be a router as well. Yeah. So firewall. Okay. This can do routing as well. I mean, they can run BGP. They can run dynamic protocols, right? OSPF, everything. They can run static routes. They can run static routes as well. So I mean, firewalls can do the routing job as well, right? But the difference is where the flow comes, right? So just think about it. When you have a router, the default behavior of a router is, so you have a router like this. Sorry for the drawing. So this is a router, so just think about it. And then you have two interfaces of the router, right? And this side you say like 10.1.1.1 is the IP address. This is not working. Anyway, give me a second, guys. Okay, so this is the IP address of the client, say, and this interface should have, say, 10, and like this is, yeah, this side is 10, and this is, say, 11.11.11.1 for the client. So what happens is this router will have a routing table saying that this network, right, 10.1.1.1.0/24 is on my, say, this E00, and this is E01. So this is on E00, and likewise it will say 11.11.11.0/24 lies on E01. So this is the routing table that the router builds, right? It keeps the information of the networks that it knows through the interfaces, and every interface will have a different subnet. Likewise is the case with the Cisco ASA. So what happens with respect to a router when this 10.1.1.1 tries to reach 11.1.1.1? So what happens is the traffic reaches here, and the router will check the routing table, and if it knows the destination, it will forward it, right? So that is the behavior of router. But with respect to ASA will block this traffic until and unless there is an explicit rule that says to allow it. Okay, but there is certain limitations to that, but we will come to know about it. But in general, just think that ASA by default will not allow this traffic to go through, depending on the type of traffic, right? If let's say this is an ICMP ping, so this will be blocked. Okay, so that is the thing, and let's see what all components do you have in Cisco ASA. So basically, when you initialize a router, right, what components do you need for the router? Router needs okay, on this interface, say E00, you go to the interface and you say IP add and then an IP address 192.168.1.100, and then you specify the mask 255.255.255.0, right? So that is how we do it, and then you say no shut, correct? But with respect to the firewall, there are certain other parameters that are very important when initializing an interface on the firewall. So let's think that this is E0 of the firewall, and then you have, so you will go to the interface and you will obviously say IP address and something, some IP address, right, 192.168.1.100, and you can just press enter here. Okay, that is again a plus point of firewall. I'll tell it in detail, but apart from that, obviously you say no shut. But apart from that, you need two other parameters. One is the nameif parameter, and then the security level. So these two extra parameters are very important. Nameif is important because you name that interface, and later on when you apply an ACL or call that interface in a NATing policy, you have to call it by the name and not by the interface number, right? Not E0 or E1 or gigabit 0. It should be the name. So for example, if I specify this as an inside interface, so I have to say apply that, say I'm applying an ACL, I will say on the inside interface, not on the E0. So that is very important. And next is the security level that you define. So the range is from 0 to 100, and this security level is plays a very important role in the default traffic flow behavior of the firewall, default behavior. Okay, we will go through it once we start the labs. I will explain to you how it affects it. But so you can assign from 0 to 100, and 0 is the most trusted one. So basically you will assign it to the inside interface, 100, okay, and 0 is 100 is the most trusted one. I don't know, I said 0 or 100, but 100 is the most trusted one, and 0 is the least trusted interface. So this will basically be your internet. Sorry for the, I don't know why my pen is not working. Okay, so this is the 0 is the internet always, okay, and then you have, say, on the DMs you will put some number which is between 0 to 100, not 0, not 100, right? So that is how it is. And there is one more thing when you specify the name if. Okay, when you specify the name if as, okay, let me take the text. Let me clear this. Okay, when you specify the name if, okay, as 100, by default what happens, the interface will take the security level as 100. Doesn't matter if it's capital I inside, or if it's small inside, or if it's mixed case I, N, S, I, B, E, something like that. It doesn't matter. It will give that interface the security level of 100. Okay, it is not case sensitive, but it preserves the case in certain matters. For example, crypto maps, it is case sensitive, so you need in that sense when you're using crypto maps, you have to have the particular case of the name. Okay, so that is just one condition. Apart from that, I mean, it doesn't. It is not a case sensitive thing. Okay, so what if you specify any other name? So any other name, name apart from inside is assigned a value of 0, and then you have to go and assign the security level of that interface. Okay, so that is the story of security level, and it controls the default traffic flow. We will see how it does. Okay, so whenever you are going to configure a firewall, you have two additional parameters. That's what I said. The first one is what, the nameif, which is used to call the interface in other configurations, and then you have the nameif, right? Sorry, security level, which will control the default traffic flow. So the most trusted interface will get the higher this value, and the least will get the least trusted will get the least value. And also the thing is that, okay, let me just clear this. Okay, give me a second. Yeah, so let's move on to the next slide. Okay, so this is the firewalls, right? The firewalls can be in two modes: routed and transparent. Routed, this is the default mode when an ASA initializes. This is the default mode of ASA, so it will be in L3 mode, and you can use it as a router. You can have IP addresses assigned to an interface. You can have routing capabilities, and there is another mode, that is the transparent mode, which is basically the L2 mode. No, wait a second, guys. Let me take my pen again. Okay, this is the L2 mode, and in this case, the firewall will not be doing a routing. Okay, and we will see the design perspective as well, where we will use the L2 and L3 like that. But just keep in mind, L2 can have two interfaces in the same subnet, right? This is the point, and in L3 each interface is in different subnet. Okay, so that is the transparent, and we will do the deployment of transparent mode as well, and you will clearly understand what is the difference. So that is that, and let's move on to the next slide. Let's see what is the next slide that we have. Okay, that's what I was saying. The ASA firewall is an L3 router by default. It has all the routing functionalities that a normal router would have. It can run a RIP, it can run EIGRP, OSPF, and BGP routing. Apart from static routes, it can do default route. The difference between regular router and an ASA is that the router follows all traffic by default, whereas the ASA will allow traffic based on certain policies, which will be discussed in this video. So that's what I said. So you have the default behavior of the router is that it will by default allow any traffic to a destination that it knows, but in firewall it is not the case, and you need a separate rule to allow that traffic. Besides assigning the IP address to an interface, the ASA requires two additional parameters on the interface, and that will control the traffic. So that is what I said to you, right? So you need the nameif, commonly inside VM0 outside. The nameif of the interface is not case sensitive. So we are just going through the it's kind of recap, right? The name of the interface is not case sensitive. Although it is not case sensitive, it does preserve the case, as I said in the case of crypto map, right? And it is a required parameter. Obviously, it is a required parameter. All command references the interface using the name, not the physical ID. That is what I said when I was telling this to you, right? Okay, then you have the security level. It is a number between 0 to 100. It controls the default traffic flow through the firewall. Okay, there is something called to and through. So this security level will control the through traffic, not the to traffic. Through traffic is like the management traffic. Okay, so it is the control plane. Anyways, then you have the so this security level is going to govern the through traffic. Just keep in mind, when you configure brand interface with a name, it sets the security level automatically to 0, except if the name is inside. That's what I said in the previous explanation. define how trusted the interface. So this security level will define how trusted the interface is, and by default the higher the traffic coming from the high security level and going to the low security level will be allowed. We will go through this definition, I mean the sentence that I said, and I will explain it to you in the coming videos. IP address, you have to configure it just like you would on a router, but the plus point here is you okay, let me just take the pen. So in you need to keep in mind in ASA you have an option. You have an option. So the color is wrong. Let me take this. You have an option. For example, if you go in an interface and say IP address something like IP address interface. So its interface is 00, and you go in the next line say IP add 10.0.0.24, and then you hit enter. So this will be taken, while as in the router you have to specify the subnet mask, but here it will be taken, but the default subnet mask of the class will be taken, which will be /8, right? So you have that option. If you are configuring a class full subnet IP address, then you can hit enter. If it's a class less, then you have to specify the subnet mask, and Cisco doesn't understand the wildcard mask, so you will see subnet mask everywhere, even in case of ACLs and in case of your OSPF configuration, right? So that is the that is an information that I want to provide you. So next is you do the no shut command, right, after the configurations on the interface. Now let's talk about the traffic flow, default traffic flow of the Cisco ASA. So by default, as I said, and let me go back here. So we have the routed mode and the transfer mode. That's what I have already gone through. Now I want to talk about the default traffic flow of the Cisco ASA. So let me grab a pen. Okay, so as I said, by default you have the security level 100, and say so you have a firewall. This is my ASA firewall, okay, and then you have two interfaces. Just keep simple, okay. You have two interfaces. This is my inside interface, and this is my say outside, okay. And what I do is I assign a security level of 100 and 0. So 100 is my most trusted interface, okay, and basically it's my inside, and this is my internet, okay. So so the first point is that the any traffic that is initiated from the high security level and it is going to the low security level is allowed by default. Allowed by default by the Cisco ASA, and this security level concept is just for the ASA. Okay, so let me just elaborate this point. Allowed by the means again what happens is all traffic which is unicast is allowed by default. Okay, from inside or say from high to low, any traffic which is unicast is allowed by default, but only TCP and UDP will be inspected. And what does that mean? That means that Cisco ASA, this ASA, will create a connection table for the return entry. For the return entry, and that is done only when the traffic is TCP based or UDP based. So that means if from inside I generate a traffic, or from an interface that is having a high security level, I generate a traffic that is TCP based or UDP based, the return traffic will be allowed by default. Because of what? Because of the connection table that I have here. This connection table is a reverse ACL, you can say, of the traffic that was initiated from inside. Okay, what do I mean by that? So for example, I have a traffic. Well, let me change the color because it's not visible, and let's erase this. So let's take this purple. So for example, I have a traffic that was generated from inside, and say the source of that traffic was say 10.1.1.1, and it was going to the destination of 192.1.100.1. Okay, that was my inside traffic. So the return traffic, I mean return connection table, will be the return of this traffic. So on the outside, something like this will be there, that any traffic that is coming from 10.1.100.1 and going to the 10.1.1 should be allowed. So this will be the entry. Okay, and this is just I mean for TCP and UDP. So that is how it is. But what if the traffic is generated from outside? Let me clear this again. Let me take the eraser, and so I need to keep the ASA and all. So now this was from the high to low, right? But from low to high, let's see what happens. So let me just delete all of this. I actually need the firewall, this one. Okay, so now the traffic that is coming from low to high, what happens to this? So by default, any traffic that is coming from low to high is dropped. There's an implicit deny for this. Okay, so how do you allow these traffic? You allow these traffic by specifying explicit ACL. So explicitly you define an ACL saying this particular traffic from outside should be allowed to this interface or to this destination. So by default, what happens when the traffic is initiated from low to high? So first thing what is checked is the connection table. Okay, if no connection table is there, then the firewall looks for an ACL. If there is no ACL, it will go to the security level. Okay, and security level will deny it because it's low to high, right? So just imagine if a traffic is initiated from high to low, okay, so you have the initiator because this is from high to low, the ASA will allow it. But when the traffic comes back, what does the ASA look for at the first place? It will look for the connection table. And because it was, say it was TCP UDP, you have a connection table. And because of that connection table, this traffic will be allowed. Okay, so you need to understand this. But if the traffic is initiated from the outside, you don't have a you don't have a connection table, right? You don't have a con table. So what will happen is the traffic that is coming on outside will look for an ACL. If you don't have an ACL, it will be denied because of the security level. That's how the security level by default governs the traffic flow on the ASA. Okay, so let's wait a second. Let's go here, and I want to go to my slide here. So that is what I have mentioned in the slide. So the first thing is that this is the one, the highlight security level to high security level to low security level. By default, all traffic is allowed to flow from a high security level interface to a low security level interface as long as the routing information is in place. Obviously, after the check of the security level, it will look for the routing table, right? So that should be there in place, the routing. Okay, so then you have the although all traffic is allowed to flow from high security level to low security level, only TCP and UDP traffic is expected. So that's what I said, only TCP UDP traffic will have a connection table below, and we can change this. It's not like this is the default behavior that I'm talking about, but you can change this. You can inspect other traffic as well. Inspection creates a return entry in the connection table on the firewall. Wait a second. I'll clear this, and I need a dark pen. So I'll clear all the drawing. Okay, so inspection creates a return entry in the connection table. That's what I said, right? And because of that entry only, the traffic that is initiated from inside, if it's a TCP and UDP or any traffic that has been inspected, will be allowed to flow from the low to high, right? Inspection creates a return entry in the connection table on the firewall. This allows the return traffic to come back. This is known as stateful inspection to low security level to high security. Okay, so again here you need to clear this thing. So you might encounter this term as stateless and stateful firewall. So this is nothing but this concept of creation of the con table. The firewall that creates the con table is stateful, which doesn't is stateless. Okay, so this was actually invented by checkpoint firewalls. This stateful inspection. By default, all traffic is blocked from low to high security level interfaces, right? So that is the default behavior of the Cisco ASA, that all the traffic that is initiated from low security interface will be blocked. If you want this traffic to work, you would need to create an explicit policy on the low interface to allow this traffic. This is done by creating an ACL, right? So this can be overridden by creating an ACL, which allows that particular traffic. When a packet hits a low security level interface, going towards a high security interface, it will check the connection table first. If there is no entry in the connection table, it will check the ACL for a permit. If there is no permit in the ACL, it will check the default behavior, and that is your security level. And because it's low to high, that is denied. Okay, so that's why I was saying that the security level by default governs the flow of the traffic. Okay, so that is what I wanted to show you, and basically I wanted to show you how there are certain models of Cisco ASA, but this is the what do you say, a different one, 5505. How it's different is it has an inbuilt switch. Okay, so you cannot go and configure this interface with an IP address. No, you should create an SVI. Okay, you should have an SVI here, and you assign an IP address to that, and then you make that port part of that VLAN. Okay, so it likes as an works as an L3 switch with an SVI. Okay, so that's there's a slight difference on the. So you will have the interface configurations in the VLAN, right? And other models you will have directly on the interface. So I just wanted you to know about this this ASA. This is the smallest ASA, and this is just with this 5505. Okay, not with other ASAs. So okay, and then again, what about the security levels in same security level, right? So so for example, you have a Cisco ASA. This is my ASA, right? And you have one interface, you have two interface, and like this. So this is say inside, and this is say outside. I'll go a little bit slow because this is say DMZ and this is say DMZ2. Okay, so let's say this is security level 0, this is 100, and this is like 50 and 50. So what about the traffic? So low, this is high to low, allowed, low to high, denied. What about 50-50? What about the same security level, right? So that is what I was about to talk in the next slide. But so default behavior of this is blocked. Okay, so same security levels will be by default blocked, but you can override again this with a command that I'm going to show you in my next slide. So let me clear this again, and let's go to the next slide. Okay, and the next slide is saying that by default, any traffic going from an interface that has the same security level as the destination interface, it will be blocked, and it can be overridden by these two commands. You can see these two commands. So you have the intra interface and inter interface. So if the devices that are if the interfaces that are part of this, having same security level and different name ifs, you will use these commands, this command inter interface. And if the security level is same and also the name is same, then you will have this intra interface command. Okay, so that is the whole concept of your security levels. Okay, then we have the access list. And why do we use an access list? So you, as of now, you should be knowing that access list is nothing but a rule, and it works like it works in an router. So you will have a top-down order here. So the access list that will be on the top will be processed first, and it will come down one by one. So where it hits the rule, it's done. So for example, you have a deny for that traffic here, and the permit of that traffic here, it will be denied, and next line will not be checked. And likewise, if you have a deny and a permit and then deny will not be working. So you need to be very careful with the order of the ACL that you configure. Okay, and traffic filter, each traffic flow session is processed only once. Top down, that's what I said, and until hit it will be processed. All parameters must match. Result is permit or deny. So you have an extended ACL here on the Cisco ASA firewalls. Okay, ACL types that I was talking about, you have standard ACL on source address, but you will not be configuring this, right? You should have an extended ACL and match on source or destination address, ports, protocols, and more, right? So you want that type of ACL on the Cisco ASA. Recommendations: specify entry on top, generic entries to the bottom, apply access list inbound. So that is the recommendations. Okay, just an example of the ACL here on the ASA. So access list, ACL inside is the name. This is the name, and then extended keyword. This is not mandatory on the ASA. Then you have the permit IP object my PC any. So this is actually what permit IP means, permit anything, and then you are specifying my IP my PC. So you have created an object which in turn will be binded to an IP address. So instead of typing the IP address again and again, you can just use this object in every rule. Okay, so this is what you have as an object in ASA. You can create host objects, you can create subnet objects, right? You can create service objects. So this is using nothing but an object. So like that, you have ACL inside, extended, permit IP. So this is permitting everything. Object is now inside net, and then the remote net, right? So this is my source, this is my destination. Likewise, you are permitting only TCP based traffic, and this is my source and the so this is like ACL inside, right? So this is the source, this is the destination. This is actually identifying a particular port or protocol on that, right? SMTP in this case. So likewise, you have all these examples. You can go through one by one. And next is to traffic on the firewall and through traffic on the firewall. So I'll be taking this what do you say topic in the next video, where I will also demonstrate this in lab, because basically what happens is to traffic will always be like management traffic. You have telnet traffic coming to your firewall, you have ICMP traffic coming to your firewall. So those are the to traffic, and by default only service that is running on the firewall is the ICMP. So this is just an overview for this, but I'll demonstrate this in my lab. So to traffic will be basically destined to the firewall, to the interfaces of the firewall, whether it's the outbound, whether it's the inside interface, whether it's the DMZ interfaces. So by default you can ping on Cisco ASA, you can ping the interfaces because that service is running. So this two traffic is not controlled by your ACL. So I mean, you need to understand this. So if you want to telnet, you cannot have an ACL permitting telnet from any to firewall IP address. No, that will not work. I mean, you can have that ACL, but it will not work. Okay, and that is ACL governs the through traffic, not the true traffic. Okay, so we will see this in the upcoming videos. And enabling or disabling of a service on the firewall is per interface configuration. So this I'll be demonstrating. Not no other traffic is allowed to the firewall. Yeah. So that as I mentioned, that only ICMP services. That means you can ping any interface of the firewall from any any direction. Right. So yeah, so that's it for this video, guys, and I'll be seeing you in the next video, and I'll demonstrate all what we have covered in these two videos in the next video, and we'll do a lab, and I will demonstrate all these things to you in that. So what you need to do, you just need to open the browser and just type in Google, right, download VMware workstation, right, 16. So you will land up on the first one, or you can go for Workstation Pro, because they will give you around I think 60 days of evaluation period, right? So you don't need to install a license or something like that. So you just go here, Workstation Pro 16, download if you're on Windows, and it will download your workstation, which is around 630 MB. I already downloaded it. I just wanted to show you the procedure, right? I'll cancel this, close it, and I will go to the downloads. This is the workstation setup. Double click, run, and let's continue the usual wizard, right, to set up the software. And one more thing that I want to cover is the configurations that we require. I mean, minimum configuration that we require to run this lab. So what I need is a laptop with the minimum, I would say 16 gigs of RAM. If you have 8 gigs, it will run, but it will not be smooth. Okay, it may hang or something like that. And I need a processor with at least 8 cores. So let me show you. If you just right click on your taskbar and say task manager, and then you go to performance, you will see this, right? So I need a minimum of 8 cores. You can see logical processors 8 and 4 cores. Okay, and I have 16. If you have SSD, that is, I mean, more preferred, but it will make your laptop or the lab faster, right? And even if you don't have SSD, that is fine. So the minimum is 8 logical processors and 16 GB is the recommended. And then let's go and hit next here. I accept, next, and then next. I will not join the experience for improvement. I will not also check for updates. Next is the basics. So how to install the workstation, right? So you can use this workstation free. It has some evaluation of I think 60 days. Let's see. If you go on to the so it has a trial period of 30 days. Yeah, I think 30 days is more than enough. So you can go after 30 days, you can just uninstall and reinstall again, right? A new version to get more 30 days. Or you have some license keys that gives you unlimited access. Okay. So once this is done, you will have the VMware workstation on your machine, right? Just hit I want to try 16 for 30 days and finish. Right? So this is what you will end up. Your evaluation period ends in 30 days. So that counter goes starts the moment you start the workstation. First, we have to install EVNG. EVNG is again a network simulation software which runs on top of the VMware ESXi.
or your VMware workstation. So let me just shut down my Palo Alto here. And in the meantime, we can go here and download the EVNG software. EVNG is also available in a paid and a free version. So we will use free version. Free version is more than sufficient for the home lab setup. So you go to evng.net and go to download section. And here you need to download two softwares. Okay, you can see EVNG Professional. This is the paid version. Then you have EVNG Community Edition, which is free. And then you have the Windows client. So we need the EVNG Community Edition and Windows client side. So I will click on the Community Editions. It will take you to this section of the page. And then you have the option to download the OVF file, which is a template for your VMware ESXi or workstation, or you can go with the ISO file. ISO file is more of a manual installation of your EVNG, but I would recommend you to use the OVF file because this is a template and already all the settings are done there. So you can download it from Mega or Google. So if you click on the Google Mirror, because I feel like it's much more faster, you will have to log into your Gmail and then download the EVNG. I already have this downloaded in my system, so I will use that, but you can download this EVNG from here. I can also paste this in the chat if you like here, and I will also paste the EVNG download section in the chat, so you would have the links in your recordings as well. Okay, so that's one thing. Second is your client side, Windows client side. So Windows client side actually consists of lots of things, which is mentioned here. The Wireshark, which is look at to capture the traffic. Ultra VNC, which is again a remote session viewer for your virtual machines, which is like say Ubuntu or the Windows machines you use, right? Then you have P-Link for Wireshark and other softwares are included in this package. So you can just go to, again, you have two links. One is Google, one is Mega. So you can go here directly and download the pack. So I can also paste this link in the chat. And then you can just download it from the Google Drive. Okay, so I have both of this already actually in my system. So I'll just close this, close it. Now I will go here and request my Palo Alto to shut down. And now you have the, say you have the VMware workstation already installed. If not, I have shown in the first class how to install the VMware workstation, right? So now you go to the My Computer section and you just go and say new virtual machine here. And then you click next. And next, this is for the ISO file. Okay, so you have an ISO of the installation, then you can proceed this way. So I will cancel this because we have an OVF. So I can directly go to my folder, which is I think in the, wait a sec. EVNG, yeah. So I have the EVNG community edition. So you will get a zip file like this, just right click and extract, and you will get this folder. Go inside the folder and you will have these three files. You just click on the OVF file or right click if you have multiple virtualization softwares like me. So I will open this in the VMware workstation. If you have only workstation installed, you can just double click. Once you install this, it will pop up like this, and you can just name the machine as some name. I'll just give EVNG, and then this is the default location. It will save the files in C. If you want to change the this drive, you can just browse and change it, but I will keep as default, and then click on import. It'll take some time to for this to import, and till the time we can just go and install the client side software right here. And this is the client side package. I'll just click. I have this installed, but just to show you, I will again install this. This is normal wizard like any other software that you install in Windows. Yeah, so you can go here, next, 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 something like this. Okay, just follow the wizard. Okay, and keep the default settings, don't change anything. And as you can see on my back end, the EVNG has already been um, imported, right? I'll just install this. Let's continue with the client side setup. Finish. It's saying this is already, installed. So I will just click yes. It will uninstall the old version. Simple installation, follow the wizard. Next, finish, and finish. So that's said and done. I'm done with the client package installation. Now I am on the EVNG inside the VMware workstation. Now for this, you just need to change the adapter. By default, it should come as bridged. So you need to keep this as bridged. Okay, that's the only setting you need to check. Yeah, plus you if you want to increase the processor and the RAM, you can do it from here. And hard disk is fine, but you can add a new hard disk to it if you are planning to add more and more devices in the EVNG. But for the Palo Alto, 50 GB is more than enough. And then I'll keep 4 processors and 8 GB of RAM for the EVNG software. And then I can just start the software. Now, once this is started, one more thing that you need is called the WinSCP. So you need a WinSCP client. You can just go to Google and download WinSCP, or for that matter of fact, you can download any file transfer software like FileZilla or something. I prefer WinSCP, so I will download this. This has been downloaded, and actually I have this already installed. So it's the same installation steps. Install. And then just launch. Okay, this will look like something like this, right? For now, I will just close this and close this. Now you can see that your EVNG has taken an IP address from the DHCP. This is the default behavior, but if you want to change it for the IP to be static, you can do it, which I would recommend. And the login username is root, and password would be EVE, which is the default username and password. I'll just paste it in the chat as well. EVNG user name is equal to root and password is equal to EVE. This is for the CLI. Okay. Now here you can change the password. I will just enter the same EVE, enter EVE, enter. Hostname you can change it here, but I will keep it the same as EVNG. DNS domain you can just skip and just hit enter. Now here is the option to set up the static IP address. So for this to be a static, you just need to press the down arrow key and then press the space bar so that that asterisk sign comes beside the static. Okay, then hit enter. Now it will ask you for the IP address that you want to set it up as. So I'll keep an IP address from the local LAN 192.168.1 dot. You just need to check your LAN IP address ranger. Depends on the type of router you're using. The ISP that you're using, they might have a different range. So from the same range, you give some IP address which is not used. So for me, say I'm using 88. Yeah, 255.255.255.0 is the subnet mask, and then the default gateway will be your router IP address, which is I mean, in most cases, 1.1. Hit enter, and then the DNS 8.8.8 in case you want your EVNG to connect to the internet, and then 4.2.2.2, and then NTP, just hit enter as blank, and then at the last you should enter on the direct connection. Okay, now this will reboot your EVNG, and once the EVNG will reboot, it will have the static IP address of 88. And then we can just directly go to the web browser and HTTP to that IP address to access the EVNG virtual machine. Yeah, now I have the 192.168.1.88. I will go to the browser 192.168.1.88. Hit enter. Now this is the GUI login, right? This will not work as root Eve. This is username is admin, password is again EVE, and hit enter. Make sure you hit on the native console. HTML is basically all the consoles will open in the browser tab only. So that is what we don't want. Keep it as native console and sign in.
Password is admin, right? I mean
Admin
username.
Eve.
Okay, Eve.
I will just
All in small.
Yeah. So I'll just paste as GUI credentials. User name is equal to admin, and pass is same. Okay, just the username changes from the CLI to GUI. Now this is your workspace of EVNG. So you can add new lab here. You can edit, I mean, change any items that you have added, move your lab, delete your lab, import or export your lab, and you can just toggle the order and refresh. So to start with, I will just add a new lab and say this is my test lab, and then you can just enter some more details, like just the version, author, who is this. So these are optional things. Save it. Now this is basically a workspace. On the left side you have many options. Okay, and these options can be also, some of the options, not all, can be also accessed by right clicking in between in the screen. So you can have node, network, picture, custom shape, text. So these are like all the options, but to add a device you have to click on the node. Once you click here, a new template option will open, and all these devices are what you can use, install, use inside your EVNG. But for that you have to actually add the images first. By default you will see only you will have the virtual PC, which is in blue. Rest all are in gray state. You cannot use them, right? So I will show you how to add the devices inside this. Now you can use a virtual PC. This is just a CLI kind of stuff. You can use this for testing. And because of the reason that we have, let me just close it. Because of the reason that we have installed the Windows client side pack, you can just double click on this and it will open your PuTTY software as a telnet. So to set up an IP address for this, you just say IP address 10.1.1.1 like this, and the CIDR, enter. So now your VPC is ready to be connected to any other device and start pinging and all those stuff, right? For testing purpose. I'll just close this and I'll stop it. Yeah, so it's grayed out. That means stop. Now we can delete it.
Hello friends, this is Zubair Al-Zafrishi again with a new video. This time I will teach you how to add IOL devices in the EVNG virtual machine, right? So here you can see I've logged into my GUI of the EVNG, and in the nodes I don't have IOL, so Cisco IOL. So if you want to add IOL, because IOL is like iOS on Linux, and so the dynamics usually they are version 12 or below 15. So if you want to use iOS version 15 or whatever, you can use the IOL. for L2 as well as L3, and I found these iOS to be more stable than the Dynamics iOS. In order to add the IOL devices, first of all, what you need to do is you need to go to this link that I will have the description in my this description, right? I'll put this link in my description. So this is the link that you need to open. This one, I'll copy this in my file, and this would be this one, and okay, fine. I'll just put this in the description. Okay, so you have to download this whole folder. Okay, download the bin folder, right click download, and once you have downloaded this, then you need to open the WinSCP client, WinSCP, and log into your virtual machine. Mine is 192.168.1.1.1. Username is root, password is eve. And once you are inside, what you need to do is you need to go to OPT key unit lab add-ons, IOL device, and then bin. Inside bin you need to put all these files, right? The files that I showed you. This one, or either you can replace this with the replace the bin file folder itself, right? Whole bin folder. Okay, once okay, I have already downloaded this, guys. I will just see where it is. Okay, I think I have this in my folder where I have kept okay, I think this is the one, EVNG images IOL and then bin. Yeah, this is the, so I'll just copy this bin folder into my virtual machine directory, right? And I'll replace the bin with the new bin, right? Bin folder directory. And once this has been copied, you need to enter the command that is the fix permission command. So this has been copied. So now what I'll do is I'll run a putty session to my VM 192.168.1.1.1, and I'll log in as root, and password is eve, and once I'm inside I'll enter this command, this one, and I'll just right click here and enter this. So once this command is executed, I'll go to the GUI, right click node, and you can see IOL devices here. So you will have L2 or L3. Let's go for L3, and I'll just put it here, and I'll start the machine. And the machine has started. I'll just go to the console of the machine, and next what I'll do is I'll wait for the machine to start. Okay guys, once the copy has done, what you need to do is you need to go to the CLI and enter this command, fix permission command. Okay, and what you do is you add the IOL device. You can see the IOL device, this one, it's there, and you can go with the L3, right? I have added one and I've started one, and the console is here. See, no. And next I want to see is if it asks me for the license. It should ask me for the license. Okay guys, it's not asking me for the license because I had already pasted the license inside the folder, right? This one where SCP inside, if you can see, I have the IOURC, right? In case for sure, I think it will ask you for the license. For that, what you need to do is you need to first of all turn off the device. Okay, I'll delete this. So you need to create a license, and how to do that is I have already kept the file, this one, that is with you. For that, what you need to do is go to add-ons, bin, right? And here you need to copy this or copy path to clipboard, right? And then you need to go to this path. Once you are inside the path, you can see you have these files inside, like right? After this, you need to enter command python 2 and this one, and this file and hit enter. Once this is done, the license will be created. This one you need to copy this and then open this IOU file and replace this with this license. This see it's the same license, so that's why it's working. For you it should be different. And then save this and done. Refresh. Okay, and then you can just add the device here. Okay, I need to refresh my GUI, and then you can add the device here, L3, and it will work for you as well. Okay, start it, open, and yeah, this will work for you. So this is how you add the IOL device and create a license for the device to work, right? So guys, this was it, and thanks for watching my video. Please do subscribe to my channel, and if you like my videos, please hit the like button, and I would wait for your suggestions. You can comment in my videos. Thanks guys, bye bye.
Okay, so now that we have the routers installed, now let's go and install the Cisco ASA image in your EVE-NG. Now this time my EVE-NG is running on the address of 192.168.1.6. So I will go and basically open up a new browser, and I'll type in the address of my 1.6, and admin and Eve is the default username and login password. Now I basically should have something here, and I will close this lab. Now I want to have a test URL, say for example a new lab, say ASA, and now if I right click and click the node, so I have the ASA here. Now how I have it here, that is the thing that I want to show you. Now I would recommend you to use the ASA 9.15 because this has the license included in it. So what you need to do is I will be pasting a link in the description to download all the images from. So you can copy and paste this in your browser. This is basically a mega link, and you should be able to download the Cisco ASA image and as well as the IOL image. So if you go here inside, you have the 9.15, this one. So you can just go here, right click and download this like this. This will basically do what? This will download the images in your PC like this. Now, once you have this, this is not like a huge file. This is like only 150 MB file. So once this is downloaded, then you can go to your WinSCP, the software, WinSCP software. You should have this on your system already. And then once you are inside WinSCP, you just go and SCP to your client, EVE-NG client, and username should be root and password is by default Eve, and login. Now once you, when you are inside the EVE-NG, you should go to your OPT folder inside the home, this folder, go to the OPT, then go to unit lab, then go to add-ons, then go to QEMU. Then here you should have a folder created by the name ASA 915, and that's it. I mean, you don't need all these strings. You just need ASA-915, and then go to your downloads where you have basically these do files like these two, copy them, or you can just bring the so I can go here. So for example, I'll just show you how to do it. So I renamed it, and I will basically drag and drop these two here, and I say yes. Let's just overwrite these, right? So now that this is inside, now you have to basically remove this. It should be hda.qcow2 and this can be hdb qcow2. The file which is 150 MB should be hda.qcow2. Okay, now that is done, and now you can say yes, and you have to basically go into EVE-NG website, EVE-NG how to website, and there you can download one command which is basically used to fix the permission, and you can go to any one. Say I go to any say a Thunder, and you should have the fix permission command. This one you should copy this, and you can go to the CLI, which is here, and I think you can do edit and paste. No, that is not working. Root EVE, and if I do a paste, Control V, not working. So that you need a putty. Edit paste is also not working. So I can do a putty here. That way I can basically, or if I can do the VMware tools, no, that's not fine. So I'll just open a putty in my system, or you can have any SSH client. And now I have putty here 192.168.1.6, 192.168.1.6, and enter. And now it should basically prompt me for the username. This is going to be root and EVE. Now once I'm here, I'll just right click and paste that command once, and I'll do it twice to be on the safer side, and that's it, right? Now we can just close this and also minimize this, and now I can go to my EVNG topology here, refresh this once, right click node, and now ASA, not ASAV, ASA. If you're basically installing 2030 like that, you can go for ACV, but 9.15 is normal ASA. Now I'm just going to save it, and now let's run this ASA and see if this is working fine. Now if I go and double click, it should open up my telnet. And yeah, as you can see, this is ASA, a Cisco ASA 9.1.5. Yeah, now this will boot up, and now that you have your ASA and you have your Cisco routers and switch, now you can go and build up the topology and follow up in my lab and basically learn the Cisco ASA. Now let's wait for this to completely boot up so that I can show you that it has a license already. So you can do the clustering, and you can also do the context. And yeah, and this is pretty much a very useful tool, EVNG, right, to learn networking. Now I'll just wait for this to complete, and then we can move forward. Now it's saying starting network. Almost there. Same module license. Now this is booted up. I'll say enable and say show version just to see the license. Now if I just press space, you can see cluster is enabled for 365 days, and also you have the security context enabled, and also you can have failover active standby is also already there, but you can have also active. So yeah, that's it. And now I will see you in the classes.
In the past two lessons, we have discussed about the basic default flow of the of the ASA and basic configuration of the interface. What is the difference between the interfaces configured on a router and on the Cisco ASA? So basically, we came to know that we have two additional parameters which are mandatory on the Cisco ASA interfaces that you need to do. One is the name if, and the second is the security level, and security level is what governs the default traffic flow on the Cisco ASA, right? And the name if you can have inside, outside, anything, DMZ, anything, but the inside keyword, right? Inside keyword has a special preference, because when you say inside on any interface, whether it's capped, small, or mixed letters, the security level would be by default assigned as 100. So we will see that in action in the lab that we are going to perform, and also see the the default traffic flow, how it works. And I also told you that the ICMP services are by default running, so that means I can ping any interface on the Cisco ASA from outside, inside, DMZ, whatever I want. So for this, I have the lab, that is this one. So let's go and configure all the routers and the Cisco ASA on this, right? So I have the config already prepared for the routers. So for example, for router R1, so that I save some time, so I just prepared this. So on R1, I have the interface IP address. So let me just wipe this quickly. No, let's just go and wipe it here. Okay, wipe this. So this is like clearing all the default previous configurations, and I will start this. Okay, so basically what I have done is on a config key, and then the host name is R1, and on the gig 00 interface, this one, I have added an IP address from this range 10.11.11.0, and the router's number will define the last octet. So this is .1 and no shut, and I should have interface loopbacks, right? Loopback 0, IP address is say 10.1.1.1.255.255.255.0, and then I should have again an interface loopback 1. IP address is what? IP add or address is 1.10.10.10.1. Again the 255.255.0. So as I said, we don't have any concept of wildcard mask on the ASA, right? So I can say 2 and IP address. You will see that also in action 10.2.20.20.21 255.255.255.0. So that is what I need to do. No shut on this interface 01, which is going to the Windows PC here, which I'll use in the later videos to do the ASDM. ASDM is nothing but the graphical version of the management console, and you will configure the ASA through graphical user interface as well as CLI, which we will be doing the most in this series, CLI, and then I go and configure a default route for this router to reach anywhere outside or in the DMZ, whatever, right? So I'll just copy this on the R1, and let's go to R1. And what about, yeah, so I'll say no here, and R2 I'll show you. Okay, this is R3, R4. Okay, it's all R3. So I'll just disconnect this and disconnect this as well. So this is R3 is already there. This one I need R4. This is 3772. I go to the session option, and the port needs to be changed to 2. So this is R4. Now I need R2, which is 3771. I'll go here and I'll change the port to 3771. Okay, this one. Right, so I have R4, which I'll say no. I have R3. This should be what? This R3 only. I have R2. I should have R1 now, right? I need R1. So I'll disconnect this. And what is on R1 is 3770. I'll go to the session properties and do L3770, enter, and I should hit no here as well. So I'll just track this here to and I'll say no here on R2. Report R3. R3 is up. R4 will be also up in a while. So R1 is coming up. R2, R3, R4. Okay, so let's move on quickly, guys. So I'll configure the routers 1, 2, 3, and 4. 1 is inside, 2 is outside, 3 and 4 are the DMZs. So let's wait for this. And then I have the ASA. Let me show you the ASA. So this is the console of the ASA, and in the ASA, basically you will end up here. This is your user exec mode, and as in a router, to go from the user exec mode to the privilege mode, you will enter enable and hit enter. Now Cisco will prompt you for a password which nobody knows because there is no password. So you just need to hit enter here and you will be in the privilege mode. Now from here, if you want to go to the configuration mode, just type the same config terminal command, enter, you are in the configuration mode. Now if from here, if you want to go to any interface configuration mode, so just hit and go to the interface and you are inside the interface configuration mode. And like anything, any other router and all, you will specify the IP address and all, but you have two additional parameters that I said. You have the security level and the name of which needs to be configured here on the ASA. Okay, and for the other commands, you have the for example, you have the show IP interface brief in the Cisco routers, right? But here the command has been slightly changed, so you don't have any command starting with show IP, so you have this command as show IP interface brief. Okay, and likewise, if you want to check the routing table, so you had in the router as show IP interface, show IP route, but here it's only show route, so no IP keyword is there. Okay, likewise, show NAT, NAT. If you want to do, you can see the NAT rules. Show xlate, again the translations that has been done, and show. So you can just hit a question mark here and see what you want to see, right? Every command is there. So these are the show configuration command. Then you have another one, that is the show name if, right? So that is again an important command for the verification, because by typing in show interface IP brief, you will see the interface and the IP address, but you will not see the name if and the security level, right? So just to check what version I am running on the Cisco ASA, show version, hit enter and space, and you will see what things you can do on the ASA. You can run maximum 50 VLANs, you can have inside host unlimited, you can have active failover as well, and right, and you have security context too. We will see in the future videos what are context, and then you have the cluster disable. But to show cluster and VPNs, I'll use a different version of Cisco ASA. Okay, but this is Cisco 9.10. Yeah, 9.10. This is basically Cisco ASA V. So yeah, so let's go to our routers R1 and paste the config. So this is my router R1 here. I'm pasting the config and done. And to verify the configuration, the famous Cisco command, show IP interface brief. So I have my interfaces up. Let's move on to R2, which is our outside router. Okay, so this is R4, R3, R2. Enable config IP address is nothing fancy here, just the default configurations. Okay, so R2 is done, and let's check again, verify the show IP interface brief to see the status is up or not. Yeah, up. Now let's move on to R3 quickly and go to R3 here and copy the R3. I think I did a cut there. So this is R3 basically. So I'll go to R3 and paste it here. Yeah, I'm right. And then I have R4, which is here. And again copy and here paste. Right. So basically this is the bare minimum configuration on the routers. Show IP interface brief. If I do, you can see all the. Now let's move on to the ASA. Okay, so first of all, what we need to do is we need to configure the okay, let me just minimize this. I have a table created, but I mean, so what you need to do is you need to configure the inside, outside, and the DMZ interfaces, and you can see the subnet that is associated with the link. But the interfaces on ASA would be .10. So every interface, whether it be inside, outside, DMZ, should end with .10. So that is the logic in my lab. So I have a table here somewhere which can help you. So these are the configuration commands. I showed you IP interface, IP brief, and all. And then this is the one. So gig01, this is the IP address, name if outside, and the security level is 0. And inside, security level 100, and IP address this one. Right? Like that you can do. But I will just do this watching on the lab, right? So I have my lab here, and I'll go here, and I have the Cisco ASA. So gig00 is my internal interface. So I'll go to the config terminal, then interface gigabit 0/0, and the IP address here is 10.11.11.10. But as I said, you can hit enter here, but it will take the default mask, that is /8 for 10, right? If I enter here and do a show or run interface gigabit 00. So this is again, if you want to see specifically the running configuration of an interface, you can do this. And the best part is you don't need to add the do keyword here. So right, you can see the mask has been taken as /8, right, which you don't want. So I'll go here and specify the /24 mask. But if you had a class C IP address, hit enter, done. You don't need the mask here. Next, what I said is we need a nameif command, nameif, and what I said was when you specify nameif inside any case, the security level will be set to 100, right? So just watch when I hit enter. So you can see the info on the screen. Security level for inside set to 100 by default because of the keyword inside. Okay, next what I need to do is I don't need to do the security level, but sometimes maybe some bug or what. So you can just do it for your comfort, right? So next, okay, I've done. I need the no shut command now. That's it. So now let's move on to the outside interface. That is my G01. Okay, interface gigabit 0/1, and I will say IP address. This is basically public, so 192.120.10 is my IP address. 192.120.10. So here, if I hit enter, this is a class C, so I don't need. It will by default take the /24, right? So if I go gigabit 01, you can see it has taken the /24, right? So next is the nameif. So as I said, whenever I configure any nameif apart from the inside, right, it takes the security level as 0. Now check this when I hit the enter. So it has set the security level to 0. So now here it's mandatory. You can, I mean, we have to keep it as 0, so no issues, right? And then the no shut command. Right now, next move on to let's check the show interface IP brief command. Right, you can see the IP address status of L2 and L3, L1, sorry, and also the interface number. But if you check show name if, it will show the security level as well as the name if of that interface, right? So next, let's move on to the third interface, that is gig 0/3. This is my interface gigabit 0/3. This is actually the name of is DMZ4. DMZ4 as, just to confirm, yeah, DMZ4, and the IP address 192.168.4.10.255. I don't need, but I can do this as well, just to show you. So if you check show run interface gig 0/3, you will see the, and also the security level is 0, right? So, but we have to change the security level to 50, right? And then move on to the next interface, that is gigabit 0/3, 4 now, I think, yeah, 4, no, 2, that is 2, sorry, that is 2. This is my IP address should be 192.168.3.10 and enter, and name if is actually DMZ3. Yeah, DMZ3, and security level is 50. Done. And you can save by write command or write memory command. Okay, so that is done now. Let's check the show name if command, and you can see we have the inside, we have the outside DMZ all set with the sorry, not the this interface brief, with the IP addresses that we wanted, right? So now from here, as I said, I should be able to ping all the routers on these segments, right? So on this segment I have R1, on this segment I have R2, R3 and R4. So if I go and ping, say let's 10.1.1.11.1, this should be pingable, right? And likewise, if I ping 192.120.2, that should be pingable. And if I ping 168.3.3, that should be pingable. 192.168.3. Okay, that's down, so I need to go. You can see these two interfaces. I think I missed the no shut command. So if I go here, config t interface g0 bar 2 no shut and 3 no shut, right? So, and also you can check the show route command. Instead of show IP route, you have the show route command, right? You can see all the interfaces now are up. So now if I do the earlier ping, which was not working, 3.3, and also 4.4, which is on the DMZ4 part, that is working. So that is one thing. You saw the basic configuration. Now, if I go on the router R4 and try to ping this interface on G0, what do you say? So this one. So from R4, if I try and ping this interface, which is actually .10, will that be reachable? Will that be, allowed? So let's see and confirm, right? So on R4, I'm going to my router and I'm going to ping 192.168.4.10. That is the IP address of the ASA, and this will work because, as I said, the two traffic is governed by the services, and by default ICMP service is running on the ASA. So how can you see that is if I go to ASA and exit and say show run say policy. Okay, now let's check the whole running config, and at the last you can see inspect. Here, this is the policy map, global policy, class inspection default. And you can see these are the ones where you inspect the traffic, right? You have the you have the TCP and these traffic inspected here. Okay, so this is the one. Okay, and if you check, you have this here, show run service, nothing is there like that. But as I said, if you want to configure any telnet or something, then you can go and turn the service on, right? So this is where you specify the default inspection. This by default the TCP and UDP is inspected. All these protocols you can see, ESMTP, email, then you have FTP, then you have TFTP, then you have RTSP, net BIOS, IP options. These are all inspected, and it will create the connection table, right? So because of the ICMP being allowed, that's why we are able to ping the outside interface of the ASA. So if you go to any file router here and try to ping any interface, not through interface, but to on the same segment, okay? For example, 10, 11, 11, 10, this will work. But if I try to ping this one, right? Say DMZ 3.10, this again the same firewall, right? So what I'm doing is I'm pinging from here to I think 3. Yeah, so that means I'm pinging the firewall interface, but that will not work because that is again a through traffic. Okay, So let's clear this. And also, if I try to ping from here to this guy R3, that will not work. For that, we need an ACL, and we'll be seeing this in the consecutive videos where I'll be explaining you to the configuration of the ACLs, right? So that is the basic initialization of the ASA, and some commands that you can use to verify. Show name if, like that. Show run interface. All the interface running configuration you'll be able to see, and etc. etc. So you have the CLI. You can go on and hit question mark and try all the configuration commands that you want to test. Okay, so that's it for this video. In this video, we will be discussing about the configuration and working of static routes and default routes on the Cisco ASA, and we'll be verifying this on the lab that I have. And before that, actually, I want to talk about the design considerations related to Cisco ASA. Where do we place the firewall? Whether it should be facing the ISP router, whether it should be behind our corporate router, or what are other deployment methods and options that we have. So for that, I will just take out a white screen and my pen. So there are multiple considerations related to the deployment of the Cisco ASA or any firewall, which actually comes down to one of the reasons, that is, are we going to run BGP or not? So are we going to run BGP or not? So if you are going to run BGP, the company has decided that on the ASA you are going to run BGP. That means your ASA is going to face the public internet, and this IP is going to be the public IP, right? Provided by your service provider. And that means that you are going to have a BGP relationship with your ISP, right? And as you know that BGP consumes a lot of resource, so this ASA needs to be hardware-wise the superior products from ASA. Okay, and plus, you know, the ASA is going to do the inspection, handle the inspection, NATing, and all those stuff, right? On top of doing BGP. So that can be done, and what you do is then you have the corporate router here, and then you can have your distribution switches. Let's say we have a redundant connection. So we have HA setup of our distribution switches. So this is our distribution layer. And then below the distribution layer, we have the access layer. So we can have multiple access switches there, right? So this is one of the designs that we can have. Okay, this is our access layer. And below that, you will have your end devices. And the connectivity could be something like this, right? So these are the connections that are between the. So here, so this means the L3. ASA is in the L3 mode, which is also called the routed mode. In this case, you will have a public IP here and a private IP here, and you may be running, say, OSPF here, and between them, and you will be distributing the BGP routes in the OSPF or OSPF to BGP, something like that, right? So you will not actually redistribute BGP into OSPF. Rather, you might redistribute a default route, right? Default route. So that is the thing. And next can be based on your deployment mode. So as in Cisco ASA, you have two modes. You have the L3 mode and you have the L2 mode. Now now before that, one was from the L3 you have a consideration that it will be facing ISP, and another deployment mode for the L3 can be that it's not facing the ISP and you're not running the BGP here, not running BGP. That means the ASA is going to sit behind the company's router that is going to form BGP pairing with the ISP. So this is going to be basically, if we think about a Cisco, these are going to be the high-end ISR, ASR, or the iOS XE devices that are going to be forming BGP pairing with the ISP, right? So that means here is the public IP, and here you have a private IP, and then you have the L3 device here, the distribution layer, and then the access layer, right? Core, distribution, access, like that. So that is one case where you can run. Now this is an L3 again, so this is a private subnet, this is a private subnet, and then you are going to run OSPF here or OSPF here, depending on the choice of routing protocol. Then BGP between the this router and the ISP. So that is one second case, and the third case can be that you are actually going to implement this ASA in L2 mode. Let me take the pen again. So now what you are going to do is you are going to place this ASA in L2 mode. What is that? What does that mean? That is also called the transparent mode. So in this case, you will not be having two subnets here. You will be having only one subnet. Say kind of this. Say let's have this /28. Okay, and then you will have an IP here and then an IP here /28. Okay, or /29, depending. You don't need actually /29. You can go with /29. You will have 6 usable IPs there. And what you do is you assign say .1 here and .2 here. And what you need here, as we have SPIs in the switches, you have same concept of BVI. We will see this when we will do the transparent mode, but you need to assign IP from the same subnet here. So you have an IP here, and then you can place this AC in between and do the inspection here. So again, you can have ACLs here which governs the traffic to and from the corporate network. So this is one aspect where you deploy this in the L2 mode. And there is another design consideration or design strategy that I have seen, is you have the data center. This is with respect to all the vendors. So you have the data center somewhere around the globe, and in the data center you have the firewall, and under the firewall you again have your distribution, your access layer core switches for the DC infrastructure, and then this is connected to the ISP cloud, ISP MPLS cloud, and then from here you have your branch 1 connectivity, you have your branch 2 connectivity, BR2 connectivity, and likewise you can have multiple branches, and they are connected through the MPLS cloud. And what happens is you don't have a local firewall here or here in these branches. So what usually happens when you want to go to the internet or the resources in the data center, what you do is you actually go via this MPLS cloud and go to the firewall, and there the traffic is inspected, and this firewall is actually connected to the internet, and then the forwarding happens. Okay, so all the traffic goes through this firewall and the DC. So this is also a case of design. Okay, so that's said and done. Let's clear this, and now let's focus on the routing part of the ASA. So like all the Cisco ASA, Cisco products, routers, and Cisco switches, L3 switches. Cisco ASA also can do routing. And what is static routing? Just to have a brief overview, static routes are user-defined, manually created routes. As the ASA has full routing capabilities, by default you can configure static routing on it. The administrator creates static routes on a Cisco ASA using the route command. The administrator is responsible for creating routes for each network that is in your topology. This is all the lines and the points that I'm going through is generic to any L3 device, right? If a new route is added in your network, you would need to go and add the route manually on each and every device. That's why we have the dynamic routings, right? It is not suitable for a large dynamic route network. In case a route goes down, that route is going to be always there, and the traffic will be forwarded to the ASA, and that's why we have the dynamic routing protocols, right? And the syntax, right? So syntax is quite similar with a slight change. So usually in the routers, what you do is you say IP route and the destination network, say 10.1.1.1.0 and the subnet mask, and then the next hop, right? So in this case, say 11.11.1. Here what you do is you have the next hop, or you can say the exit interface here. Okay, instead of the IP, you don't have the IP. As I said, multiple commands on the Cisco ASA omits IP because ASA as a device doesn't support any protocol other than IP. It doesn't support AppleTalk, IPX like that. So you have the route command, and then you have the exit interface from where this network can be reachable. Okay, and then the subnet mask, and as is the next hop. So let's do this on the Cisco ASA that we have, and I'll tell you the topology. So what we will do is we will have a static route pointing to this router R1 for all these three networks, and then we will try with a ping from here. Okay, so we'll do the ping and we'll see is it reachable or not. Okay, so let's go to the ASA and see what is the routes that we have, and by default we will not be able to reach. So I'll try the command show route. Like, I have some static routes. Okay, so let me clear these routes. So to clear the routes, it's easy. Clear, configure, and you say route static. Okay, it should be static. Okay, it's not there. So show run route static. If you do, you should see the show run route, and then I want to see with this S, include S. Let's say small s. Yeah, so I can see this. So I will add just no to these commands. Okay, and it will go away. And the third one, I'll configure these route again. These were there from the last lab that I was doing, so that's why. So if I think that is CLS or CLR, clear screen, something like that. Anyways, so let's go, and now if I check the route, I don't have the route, and if I try to ping the subnet behind my inside router R1, I'll not be able to reach it. So how do I configure a route to reach the inside LAN? So the command is like route, and then I should know from where I can reach this network. So the interface that I should take is the inside, and then I will specify the subnet with the mask and the next hop. That is going to be my R1 in this case. Okay, so that is done. Now if I do ping the same IP, it should be reachable. Likewise, I want to configure the other two. So the other one will be 2.2, and the third one will be 20 and okay. So here, if I go, this should be 20, this should be 20, and that's done. Now let's validate all three. 10 what is this? 10 1 1 1. I have 10 1 1 1, and I have 10 20 20 20 and 2 2 2. So let's do this on the ASA. Ping 10 20 2 2 2 1. I think that is 2 2 1. Yeah, I have. Okay, there's no 2 2. There is 10 10 10 1. So this will not work. But see, even if you don't have this network, right, the static route will be there. So that's the drawback of your static route. So I'll say no to this, and the static route will go. So now if I have to reach the 10 route inside 10 10 10 0 255 255 255 0 10 11 11 1, that is the route. So now if I ping 10 10 10 1, should be reachable, and also the 20 network 20 21. So that is how to reach. So that is the static route. Now we will configure say a default route to reach any network out to the internet. So this assume that R2 is the internet, and we have these networks on the internet. So just a single route to reach anything on the outside. So the command again is the same route, but the interface will be outside this time. And then, as we will do in the router, like this, and the next hop 192.120.2 is the next one. I can also do, instead of all zeros in a 32-bit, I can also say 0 0. And if you see the route here command, it will automatically change this to your 32-bit format. Okay, so now if I try to ping 199.1.1.1, which is sitting behind my internet router R2, it's reachable, as well as any other network that is present there, it is reachable. Or even if I don't have a network that is not reachable behind R2, but ASA is anyways going to send the traffic to R2. So even so these are the networks that are present, right? So for example, I can ping 8888. It will be sending this unknown subnet traffic to the R2. So that is how it is, and that is how you do the static route and the default route on the Cisco ASA. I hope you liked this session of Cisco ASA and you understood these concepts clearly. But you need to practice these on your own, and you will grasp the concept more clearly after practicing. So that's it for this video. This video is basically going to be all about the default traffic flow, understanding the to versus through traffic, and some troubleshooting commands as well. So we'll see all this in action today, and it's going to be a really good session. So you guys practice it so that you understand it more. Okay, and check this video a couple of times so that you understand more of it. Okay, so just to summarize what we did in the last video. So we have the interfaces configured, and I can see that the interface geek 0, 2, and 3 are still down. So I'll bring them up, and we did a basic default route and a static router, right? Show route. If I do, I can see I don't have the statics. Okay, so that's great. So I have removed that which I did in the last video. Nice. So that means that from ASA I can ping all the routers. So let's see the outside router. I can ping that, but I should not be able to ping the loopbacks on router 2, right? So that there's no route. Okay, so that's what I need. Now let's see. So there is a general idea of to versus through traffic that you need to understand. And let me grab my pen quickly and start discussing about it. So the traffic that we initiated as of now, the ping that we did was from the firewall to this interface, right? So there was no issue with the routing because this is the directly connected interface, and this is a traffic that was initiated by the firewall. And also, if I initiated traffic from this to the interface, that will work, right? Because as I said, that is not controlled by the ACL, right? Those are the services that control these two traffics. So if I go here on my ASA and on the R2 actually, and say enable and say show IP interface brief, just to check the interface configuration. Yeah, so if I ping from here 192.1.20.10, which is the interface, outside interface of my firewall, this should be reachable. Reason being is that ICMP is only one service that is allowed by default, and that is a through traffic. Now if I see, for example, we will test a through traffic, and I'll try to make you understand how it's going through the firewall and what is denying it, right? So let's go on the R2 and try to ping the R1 and try to ping the R2 interface, this one. So for that, what do I need? First of all, I need a route here, right? I need a route here on R1. Let's check. I think I have a default route, and then I need a reverse route here, right? Route back to that 10.11.11 network. If I do a default, without the source, right? Because the source would be this one. So I need a route back from R2 to this. But in general, this will not be like this, because this ASA will be NATing. So that thing will be covered in future lessons, okay? The NATing and all. But for now, let's do a routing on this router for the return traffic. Okay, so let's what do? I'll just clear this first of all and close it. So by default, okay, let's check this. Let's go to R2 and check the route here. Show IP route. Okay, so I don't see any route that says 10.11.11 or any default route. So let's configure a route, a static route that points to 10.11.11.11 0 255 255 2550, and the next hop should be my interface of the firewall. Okay, so that's done. And if I check now, so I should be okay, wait, show IP interface. No, not show IP interface. I'll check the show IP route to see the route is there or not. So I should have a static route that points to that particular network. Fine. Now let's check on R1 from where I'm going to ping, right? Enable show IP interface brief. I have the interfaces. Nice. Show IP route. I have the route. That's a default route. So no issues from there. So now if I go and ping from here to 10, not to 10, to 192.1.20.2, will that ping? Will that be successful? Just now you have to understand this flow. Okay, so what I'm doing right now here is, let me draw. Okay, so from here I am specifying source as 10.11.11, and this would be 1, and destination is 192.1.20.2, and the traffic is actually the ICMP. So on the firewall, what will be happening is, because this is traffic from a high interface to a low interface, this will be allowed, because all traffic which is unicast is allowed by default from high to low. So that is no issues. So R2 receives this route. R2 checks its routing table and sees it has a static route to reach this 10.11.11 network. So he replies to this as 10.11. No, source will be now the destination, and destination will be now the source. So I'll take an eraser here. So now the source would be, in this case, it would be R2 192.1.20.2, and destination would be 10.11.11 and 1, and the source and destination port would be again reverse, right? So here the source will become now the destination, and the destination here will become the source. Okay, so that is like this. And what will happen on the firewall when this traffic comes back to firewall? What will happen is, first of all, it will check the connection table, and because this is ICMP, that connection table is not built up by default, because only TCP and UDP based traffic will have a connection table. So next comes which one is the security level, and because this traffic is coming from low to high, so this will be denied. So that means this will be denied here. Okay, so let's check this in action and clear our doubts in this. Okay, so I'm on R2, and before that, what I'll do is I'll enable logging on the firewall. So how do you do it? You say logging console 7, but you don't do this on an corporate network, because it becomes very noisy. So you basically go and use other methods like the packet tracer. I'll show you, and then you logging console 7 and logging enable, I think. Yeah, so that is done. Now let's go to R2 and now ping this. Okay, so let's now I had to do a debug IP packets here as well. Let's do a detail. Okay, and let's do this again once again. I know I would have some logs here, so I'll just take it like this, clear the screen. On R1, I'll again do the same ping. So now let's go to R2 and see if R2 has received this packet. Yeah, it has received this packet, and that is the, so we have the packets here coming on to R2. Now let's go to ASA and see the packets. So ASA says, okay, let's go to here first on R2 and see packet routed succeed. And you can see the source was 10.1.11.11.1, that is R1, and destination was 192.121, and routed via RIP, routing information base. And you can see the return traffic was source R2, destination 10. So that means the packet has reached to R1, and the idea of high to low security is valid, right? Now let's go to ASA and see what's happening there, because I cannot see on R1 the pings getting successful. So on ASA you can see that you can see this outbound ICMP connection for forward address. This is the destination, and this is the source. And this is a type 840 with an echo, and you can see that it's getting denied on the outside interface with the source as R2 and the destination is R1. So type 040, which is ICMP, replies, right? So that, I mean, clearly clarifies the whole concept of high to low and the ICMP not getting inspected, right? There are two ways to get around this. One is that you configure inbound ICMP this ACL here. So how do you do that? Let's do that first. Access list says out permit ICMP any. Okay, that is the or what ICMP. Then you can say the source IP. Let's be specific. Okay, and then it will ask for the net mask, or I can say host if it's just a one single node, and again host that is going to 11.11.1. So that is like specific, and also I can go for the echo. Is it echo only or echo? In my case, it's echo reply. All right, so that is the very granular access list that I want. Okay, and then I will apply this access list out in. So this is like not access list, actually access group to apply. then I'll specify the name. So here you go and specify the name of the ACL that is out that I configured here, right? This one. And then after that, you have the direction, okay, for input and for output. So this is coming inverse on the interface. Now the direction is inside. Now what interface it is actually outside, right? So in interface like that, and then you specify the interface, so outside, right? So what I'm doing is on this outside interface, I've applied an ACL that permits ICMP echo replies sourced from 20.2 going to 10.11.1. So that is the reply that was getting denied. Okay, hit enter. And now let's try the same ICMP, the ping. Now this time it will be successful. Why? If you see here, you will see the ICMP. And why it's getting teared down is it's like so you have two options, show con. I don't think you will have a connection table here, but if you try to do it very fast, I hope I can see. So let's see 10,000. Oh, okay, count. I said time or what? Repeat, sorry. There you have repeat like this. And if I go on the ASA and see, yeah, I can see this this connection table. This is how you see the connection table. So you have a ICMP. It actually lasts for only 2 seconds. So this is from outside to inside like that, right? You can see the connection is teared down. And after some time, you will not see anything. I mean, till this ping is going on, let's just wait for the, it'll take some time, right? So Control Shift X6, Control X, no, not. So let's wait for this. So this is how the through packet is going on. And also you have another thing that you can do for this traffic is without the ACL, right? So let's wait. Okay, I will go and view all here and look at all if that works. I mean, this has become too noisy. I think I did view all somewhere. So we have to wait for this to complete. And if I see here, okay, let's keep it like that. Let's move on to the next one. That is the so I've shown you the access list, right? Now what I'll do is I'll say okay, show run interface outside. If I see interface, show run interface, I should see outside, right? Okay, gigabit. Which one is that? 0, 0, 0, 1, yeah, 0, 1. Okay, so I have this name if and all show. So I can do and say clear configure access list. Which one? Out. Yeah, that is done now. So my ACL should be, I mean, the ping should drop, right? So, and also I'll do a not logging console, no logging console 7, no logging enabled. So I'll disable the logging. Okay. Now there's one more thing that I want to show you is show running configuration. All if you do, you will see the inspection, right? As I said, only TCP UDP is inspected and some other things are inspected. Basically, what happens is okay. So this is show run all, and then you have another command show run only. Okay, but show run all will show you extra things that show run will not show. What I want to do is I want to show you the policy map actually, not the policy inspection. I want to show you the inspection that happens by default. Okay, and in that you don't have ICMP. You have TCP UDP, TFTP. So basically, what happens? I'll show you. Wait a second. Okay, go. Too many. I think I saw it here. Yeah, so this is what I want. Policy map global, and then class inspection default, and then you don't have ICMP here. You have FTP here. You have TFTP. So these are the. I mean, the problem will be where? The problem will be when you have some traffic that is not using the standard ports. Okay, so for example, you have the FTP, right? So from inside, now let me take my pen, annotate. Okay, and let me take a different. Okay, from so for example, you have this firewall here, ASA, and you have a client on the, say, here a client, and then you have a server here which is using FTP. So what happens? FTP is sending this destination port as 21 and source port as some random number, right? And here it replies with a source port of 22 or 20, like that, right? So that is that creates a problem, because the firewall now has a return entry with port 22, and that is not matching the connection table. So there you have to do the HTTP when you do the inspection, right? Deep packet inspection. So there you do all these manual tweaking of the access list and the flow, right? But when you have a standard port that like HTTP port 80, okay, so you know that the destination will be 80 and the return traffic will be as the source 80. So there you don't have any problems. Okay, we will see this in the deep packet inspection classes in future, and that is what I wanted to show you. So so the next thing that we can do to allow this traffic is you can do what? Okay, this dot is there, so I'll go and clear my screen and close this. Okay, so now what you can do, instead of doing an ACL, what you can do is you can inspect this ICMP. So that will be allowed by default. So how do you do that? You go to that this one. You go to the policy map and the class map. Okay, you do this. You go inside this and then say inspect what? ICMP. So the connection table will be formed. So now if I go, I will show access list, and there will be no access list. Show access group, show access list, IP access list also. If I do, there is, I don't see, okay, show run access list, let's see. Okay, so I don't see any access list. Okay, so now if I do this ping, need to stop this. Wait a second, guys. Control C, Control V, not happening. Control Shift X, 6. Okay, this is continuously happening now. What I need to do is right now I need to stop this. Okay, I'll pause my video and try to stop this. Oh, now that I have breaked the pings. So now let's try that this. Okay, let's check the show con, and I don't see any connections. There's another this localhost command, something, yeah, localhost all. This way also you can see the connections, right, that are going on. So now let's do the ping again, not with. So let's do 100 ping. Now the ping is happening, and I can see the connection table. I think the connection is over. So I need to be really quick on this. So let's do 1,000, and then I'll go here. Yeah, I can see the. Okay, now nice. So I can see the connection table here, right? So you have the local host as 22. That is the return traffic. That has to be. And the inside is the destination. So you can see, right? And ICMP is using protocol 7. So that's why. That is the thing, right? So that is the return traffic that should be there. ICMP outside. Going to inside, so destination this. So that is what you have the connection flows, and that's how you inspect non-default traffic that is not inspected by no ASA. Okay, so that's there, right? So I think you understood this very well, the default inspection and how you inspect a non-default traffic. And another problem is. Okay, so let's just think about the trace route. Okay, so how does trace route work? Trace route usually, so you just think of a firewall here, and a router here, and a router here, right? So how does trace route work? When you trace out from this to this, what happens is UDP is initially used, and the unreachable messages, right? ICMP unreachable messages, that will be, unreachable messages will be transmitted back. So just think, UDP is inspected by default by the firewall, but what about the return traffic? It will be blocked because this is not UDP return traffic, this is ICMP. So these are the traffics you need to manually do the tweaking, right? So for example, just let's see, I'm not inspecting, I'm inspecting UDP and ICMP from inside, but that will not affect the return, right? Because that is again low to high. So let's do a ping, trace route from here. Trace route 192.120.2. This will fail because let's see here what happens. Logging console 7. So I think I need to go into the config mode. Yeah, logging console 7, logging enable, right? So let's see the trace route here. Okay, yeah, so you can see building TCP UDP connection, right? So the initial is UDP, but it should be denying. Yeah, you will see the denying inbound here only. Because it's a type 3 code 3. Anybody knows what's type 3 code? I think it's unreachable, right? Type 3 code 3 ICMP, if we search, should be the it should be unreachable. I should see it somewhere. Yeah, ICMP unreachable. You can see here, right? So that is what I was talking about. So how do you enable this trace route? You can have an access list that permits this thing. So what I can do is, let's go here and what can say, no logging on, no logging console 7. So what I can do is access list out permit ICMP any just for testing purpose, access group out in interface outside. Okay, now let's do the trace route and it should succeed by this. Control Shift 6X, Control C. Yeah. So now let's do the trace route this time and it should succeed now. If I see a logging here again, logging enable, logging console 7, and yeah, now I can see inside this. Okay, there's some issue here now, but I can see my trace route is working, right? I can see the next one. This is also working because of the ICMP the access list. So that is how you do the. So clear configure access list. I should do. I think access list. Or I can say out as well, or all the access list. Show run access list. It should not be there. Yeah. Show run access list. Yeah. No logging enable and no logging console 7. So that is that, right? So the next thing that I want to talk about is the this was the through traffic. Now I want to talk about the to traffic. So for example, from R1, if I ping 192.1.20.10, right? 20.10. That is the external interface, and that is from R1, not from R1. From R1 it should be 10. So this is from R2. 11, and 10. So this is enabled because this is enabled by default, the ICMP service, right? So how do we enable or disable these services? So for example, there is a command for every service to enable. For ICMP, it's like ICMP deny any. So what I'm doing is I'm denying any ICMP on any interface. So this is the interface, right? So I can say any. No, I cannot say any. I have to specify the. So let's say outside. Deny, I'll say inside. Deny, I would say like that, right? So now if I go on to the inside or the outside, this ping that was working earlier will now fail. And also from the R2 outside, if I go here, and say ping 192.120.10, the outside network, that is going to fail. But on R3, if I go and ping show IP interface brief, I just it's 90. Okay, so ping 192.168.3.10, that will work because on that interface I have not set a deny. Okay, so that is how you control the two traffic, and in two traffic cannot be controlled by an access list. Okay, ACL. So and one more example would be, so I can say clear. Let's try this. Configure ICMP. Yeah. So that's done. That will take care of all the configurations. So if I do this, again, this should work. Okay, that's great. Now let's move on to the next thing. So how do I 10, 11, 11, 0, 255, 255, 2550, and what? And the interface, it should be inside. Okay, that's done. Now go to R1 and telnet 10.11.11.10. So here I can see it's I mean, you don't have any username and password, right? So username should be Cisco. Password is, I think, Cisco 123. That's what I said. No, let's try that again. Cisco 123. Cisco 123. Cisco 123. But I don't have a password actually. Control Shift 6. So the translation is going on. Anyways, leave it. That is the no logging console 7. No logging enable. And also, if you want to enable HTTP, you can do that, right? This we will see in the future videos where we'll configure the ASDM and access the GUI of the Cisco ASA. From there also you can configure lots of things. I mean, everything. So let's say HTTP. You want to enable HTTP from say 10.0.0, any network that starts from 10. Okay, and like this you do this and then you say inside. That's it, done. Now what you do here is, I think you have something else here. Either it's server. No, you don't have anything. So let's do a telnet on port 80 from here. Telnet 10, 11, 11, 10, and then I can use the port 80, right? Okay, wait a second. Let me see. www, if I do. Connection refused by remote. HTTP, and then you have the host IP address of the host or network authorized to access the HTTP server. And okay, you have to enable the server. Yeah, forgot it. Okay. Right, anything else? No, that's done. Now it's listening on port 80. Now let's see the same thing. Oh, again it's, so if I say port 80, no, port 443. Yeah, okay. So when you say HTTP, that is 443. Okay, so that's 443. That's working. That's it. Okay, guys. So I think you pretty well understood the concept of through and to traffic and how to control and manipulate all this stuff. Right? So yeah, in my next video we will talk about the ASDM and how to configure the Cisco ASA using ASD. But this is very important to understand the flow of the ASA and how to troubleshoot. And there is one more command that is very, very important for you. That is the packet tracer command on the ASA. So for example, you can say a packet tracer and then the input. I mean, it's like simulating. Also, you have this same in the GUI ASDM, but in the CLI it's like this. So you say input, which interface is it? Outside, and then what you have the traffic as. So I say ICMP, and then what is the source that is coming. I say 192.120.2. That means on R2, I'm generating this type. Type is okay, not like this. Type 0 code 0. So it's an ICMP reply. Okay, and into the destination 10, 11, 11, 1. Right? It's my R1 and detailed. If you say like that and enter, you will see why this is getting dropped, and you will see all flows. So for on number 1, okay, it's checking for an access list. You see here, phase 1 is checking for an access list. Phase 2 is doing the route lookup. Phase 3 is checking for the NAT. Phase 4 is it's dropping, and this is because of an implicit rule, and that is because from low level to high level. That is the default thing. Okay, so let's do another thing. Let's check that would be permitted. I think no. Okay, let's check a TCP. Why not TCP? From this guide, which is 20.2, going to what? TCP what? TCP say anything, HTTP, yeah, HTTP going to 10, 11, 11, 1, right? And let's what is this? This is the port number. Okay, port number. Let's say 80, 80, and that's it, right? That's it. So this will be actually dropped again. But see, this is not looking for the connection label, but this is looking for the route first. So do I know this route? Yeah, I know this. This is directly connected, and I found the next hop as my this, and NAT. It's allowing because I know the what do you say, the networks, and then it's dropping again because of the because you don't have any ECS, and by default the what do you say, the low to high is dropped, right? So you I mean need these tools. You need to understand. You need to practice how to solve these issues. I mean, this was pretty basic, right? Because this is a known fact, an easy thing, right? Because I don't have traffic that is from low to high, so I knew that is going to drop. But there are many complex situations in your day-to-day life in ASA that you need to, troubleshoot using these tools. So yeah, you need to be pretty, clear with these CLI commands and all, and practice well to understand these things, right? So yeah, so that would be all for this video. In my next video, we'll be going through the ASDM. I will be explaining to you how to access the Cisco ASDM and all other stuff that we can go through the ASDM. Okay, so in this video, we will be discussing mainly about the device administration. So in the last video, we discussed a little bit about the two traffic, and mostly the two traffic are based on the services, and one of the major service that consists of this is the administration. So you have protocols like SSH, Telnet, and you have ASDM, the GUI of the ASA, to manage the ASA box. So we'll be going through that as well in this video. And before that, I just want to show you one example of enabling a service called DHCP. DHCP as a server. Okay, so we'll be enabling ASA as the DHCP server, and then we'll see how to configure this thing on ASA, and then we'll be moving on to the other SSH and Telnet options that we have here. Okay, so on the ASA, let's see what all interfaces I have here that I've configured. Okay, so that is there. So let's do one thing on R1. Let's see what is the gig01 interface, show IP interface brief. If I do, so gig01 is gig02 is 11.11.1. So I'll keep this interface as DHCP. So I'll go to interface gig02, okay, and I say IP address DHCP like this, and no IP address, and again IP address DHCP. So I'll go to ASA, and how it starts it is with the keyword of DHCPD all the commands that are related to DHCP server is DHCP-D. And then you first thing you need to do is to specify the pool. That is done by the address command, and then you specify the range. So I'm going to do this on the inside this interface. So I'll keep an range from say 100 to 200, something like that, and you specify the name of the interface. That's it, done. Now you have to enable this service by saying DHCP-D enable, or I think server enable. I think so. Yeah. Or let's see. Okay. Oh, not. So on which interface you want to enable that service, right? That's done. So next thing is, let's see what all options you have. You should have a DNS, right? So DNS can be done by this, and you can hand out multiple DNS servers. And one option that you do not have here is the default gateway. So if you hit question mark, we'll see DNS that we did, address we did, enable we have done, and then you have the options. So if you have any other options apart from these to hand out, you can hand out those options. And for the for the next hop or the default gateway, what happens is on the interface that you have configured this DHCP server, right? So it will take by default that IP address. So for me, inside is on each 01. So if I do interface run Ethernet 1, show run actually, show run interface Ethernet 1. If I do, so it will go into the interface like this and hand out not the 1. So inside is 0. So it will go out and hand out this IP address as the default gateway by default. Okay, so that is done. Now let's see if R1 has received any IP address. Yeah, it has received an IP address, as you can see. So it has got the first IP address, that is 100.1. So if I see do show IP interface brief on the router 1, and I can see that I have this IP address. So you have some show commands. So DHCP D, and then you have the I think statistics is there. State is also there. State is also there. So you can see which interface has the DHCP services running. So you can see inside is there, which is shown here, right? And then you have what binding should be there, right? So you can see that 100 has been handed out. So this is the MAC address like that, and then you have the statistics. So you will have the statistics here, which will specify some of the messages. So these are basically the client messages. These are basically the server messages that are sent from the server, and this is what it has received. So it has received a discover and a request. It has sent offer, and that is what you have. Then you have the pools, you have automatic bindings, how many you have done? One only as of now, right? So that is how you configure the DHCP ASA as a DHCP server. So let's remove this and move on to the, so how do you remove clear configure, and then you say DHCP-D, and it will remove everything that is associated with the DHCP. So now if you go here, I should be, I'm on the interface, I think, yeah. So I'll say no IP address, and I'll apply the static IP address back, that is 10.11.1 on this interface. So I'll say IP address 10.11.11.1 with the default with the subnet mask of /24, and I'll say no shut. And if I exit and say to show IP interface brief, I should see my this IP, and let's try a ping so that the reachability is there. 11.11.10 is my firewall interface, and I should be reachable. Yeah. So that is how you enable the DHCP, ASA as the DHCP server, and some of the troubleshooting commands that are associated with the verification troubleshooting. So next is what? Next we will see how to enable Telnet and SSH, because in my last video I didn't show you completely. I just showed that is a true traffic, but there are some extra configurations that you need to do in order to log into the system. So first thing is a username, password. Then you have to have a authentication server. In my case, I will do create some users on the box, ASA box, and tell it to authenticate locally on the local database. But you can have in your organization an AD server, LDAP server, TACX radius, whatever. So you have that option as well here with the Cisco ASA, and also we will do the ASDM part. Okay, so let's start with the telnet. So one major thing that you need to know about the telnet is that if I will show you that this thing in practical as well. If you have an interface, or in my case, I have this interface as 0 security level. This is on 50, this is on 50, and this is on 100, right? So if I configure telnet here on this interface, even though I'll be configuring the commands in the interface, but I'll not be able to telnet on the outside. That is a default security on the ASA. That the interface that is kind of untrusted, you will not be allowed. They will not be allowing the telnet service on that. It's kind of a security measure, right? Because this is clear text and it's not secure, but you can enable SSH. So you have that option of SSH on there. So let's try. Let me clear this and close it. Okay. So first of all, what I'll do is, so you need a username first of all. Username. Let's go with the telnet. Okay, I'll enable telnet on the outer interface and as well as the inside, and you will see that I'll not be able to telnet from the outside, but from the inside, I will be able to telnet. So a username, let's say Cisco. Okay. Password, let's say capital C, small ISCON123, and then you have to specify the privilege level 15, the top level. Then you have to specify AAA authentication method for what? For that particular protocol, telnet application, right? Then you have the keyword of console, and then you say local in capital, that is case sensitive, or right, or you can go for the TACX word, right? You have the TACX console, you say local in my case. That is it. Now you have to enable telnet by specifying the telnet command, and then you specify the range or the whole address or a host who will be able to telnet into this box. Okay, so on the outside I have actually 20.0. This is the whole subnet that I'll be enabling. I can go granular with the host itself, but let's keep it like this, and I'll say outside. And same I will say for the inside, 10 11 11 0 255 255 2550 inside. So I'm doing same, and also authentication will be based on the this AAA local database that I created. So that is what I want, and what all options you have, telnet, and then the timeout you have. So no, I don't need that. Okay, let's exit and see show run telnet. So like there you will see the two commands are there. So let's do it from inside first. Okay, exit and telnet. Let's see if it's working first of all. Telnet 10 11 11 10. So it's open and it's asking me for the username, that is Cisco, and the password is capital C ISCO123. And yeah, well, I'm in and enable, and that's done. How do you check? So for the ASDM and SSH, you have show SSH sessions. Like that, you have show ASDM sessions, right? And but for telnet, you don't have anything like show telnet something. It's not there. But there is one command which will work for all. But you can say like who, and that will specify who is logged in, right, as an admin. So 10 11 11 1, that is my router R1. So that is done, right? So I'll exit on R1. Let's go to R2 now. So let's see if it's allowing me to come on the interface that is with the security level of 0. So if I do the same command telnet, but with the IP address that is on the outside, see, this will not be allowing me. And if I go into my ASA and say if I enable logging console 7, logging enable if I do. Okay, so I can see on R2 it's still trying, right? It should have UDP discarded, yeah. From, no, that is not the one. It's from the DMZ. Let's wait for R2. No, it's not still on the. So let's try once again and now check on ASA. So I have, yeah. So you can see from 2 on port 23, right? That is 10. Yeah. So that is getting discarded. So that is the default. I mean, you can see security measure that has been kept there. So yeah, so that is one thing to remember. And Control Shift 6X, Control C, something like that. Control Shift. Okay. Okay, leave it like that. The next thing I need is, so let's clear this telnet thing. Clear configure telnet. And likewise, let's do the SSH and so SSH again same. So you do SSH and then the address. So I'll specify the whole inside address for this. Okay. 00. So because what I want to do, I will just show you, and this is my inside interface. Okay, and no login enable first. No login console 7. Okay, so I've enabled SSH. Then I need the. Let's see what. Okay, I need the version. By default, it's 2 anyways, and I need to create a crypto key generate RSA modulus 1024. Yes, I think I already have one, so I replace it. So I need the key for that, and I've specified the SSH. Then SSH. Let's see again what I need here. It's very tricky because you tend to forget these things. Oh, about the AAA, right? I need the AAA. So let's go here. So for AAA itself, I'll say authentication, then specify SSH. Then you have the console, then you have the local. Okay, and that is done for SSH. Now let's do for HTTP. HTTP also, this is for the ASGM HTTP. Then again, you will specify the subnet from where you will, I mean, allow the, or you, this is server is okay. So for that, I think you have to say server enable, and then this this command will be accepted. Yeah. Then also you have the authentication for here, but you will specify the HTTP here. Again, console and local with the capital caps. I mean all caps. So now you have the username, you have the authentication specified, you have the, I mean the subnet specified, and you have user everything, right? So that is fine. If I check show run HTTP, let's once again. You have the server enable and this, and authentication was already there. You have the username, so this should work. Now I need a route, show a route, because I'll be doing this from this PC, which is I think on .100. If I go here and say ipconfig, I think it's 10.20.20.100. Okay, let me just check like this. It's taking time. Okay, yeah, this is on .100, 2020. So on router, I don't have any issues. So ASA should know about 2020 subnet. So I'll go to the ASA route, create a route. Now you should know how to create a route inside 10.20.20.255.255.255.0, and the next hop is what, 2.11.11.1 R1. So that is done. Now if I go from, so I have to test the connectivity, so I should be able to ping this interface of the ASA. Great. So now let's try two things. One is SSH and one is ASDM. So let's try the SSH first. So I need to go to 10.11.11.10 422, and yes, I accept, and yeah, I'm in. So the same Cisco with the capital CISCO123 is my password, and yes. So the command that is used for verifying the SSH is show SSH sessions, and should be able to see your IP address here. So that is great. So that is done. Now let's move on to what? Move on to the ASDM part. So for ASDM, what you need to do is you need to go here and in the browser, you open the HTTPS and do the 10, 11, 11, 10, and it should, there is a problem. I'm able to reach, I've enabled this. Let's try the, sometimes happens with the browser, HTTPS. I have the 10, 11, 11 here. Let's try this one. Yeah. So this is the page that you will get. So here you have to install an ASDM, or you can run via the web application as well. But I'll just download this. It will prompt me for the username and password with the Cisco capital CISCO 123 is the password, and this ASDM setup will be downloaded. Now you have to install this setup. I'll close this window. I don't need it. Okay, I'll run this. I don't need it. I'll close it. I'll close it, and I'll complete this installation. So what did I do? I should have the ASDM here. Yeah, I have the Cisco ASDM here. So I'll click on this. It's an application. It will ask you for the device IP address, then the username, that is Cisco, and then the password capital CISCO 123, and you hit OK. It will take some time. It has compatibility issues with the Java. You should know version of Java. You can go to the Cisco website and check for that. And before that, also one more important thing is you should have this ASDM file on your Cisco ASA. How you check that? You check the flash, show flash, and you should see this thing here, this one. Until and unless you don't have this file here, you will not be able to do the ASDM. Okay. So you need this file. If not, just check. If you don't have, you need to TFTP this file inside the Cisco ASA box. Okay. Okay, great. So we have the dashboard. So you can see for the first time the dashboard of Cisco ASA. This is quite similar to all other next gen firewalls, right? So you have dashboards like this, but this is like quite outdated. You can say looks old. Comparatively to the new boxes, but yeah, you can do a lot of things here. So for example, let's go for configuration. So device management, as we did the ASDM part, you can do it from here. So you can see ASDM and SSH that I configured from the CLI. You can do it from the GUI as well. So this is the ICMP. So for example, I'll just show you how to do it. So for example, from the outside, as of now, I can ping that's the default settings that is there. I can ping the outside interface. So if I go here and I add echo and say outside action, say deny and any IP address and say OK and then apply. So apply is what pushes the config to the ASA. Now when I do this, it will not be happening, because if I go here and say show run access list, there should be an access list created for the show run ICMP. It should be there, not with the access list. Okay, so you can see ICMP deny any echo outside is configured there because of the this settings that I did here. If I delete and apply, this will go away. If I do the same thing again, there is no command like that, right? So yeah, that is how you do it. So you can see a lot of things here. You can configure the DHCP that I did from the GUI from here, right? You have the monitoring. You can monitor all these traffic. You can check the routing. You can go to the routing table. You can check the routing table here. You can see the routing tables. You have a static route, and if you're running EIG, RB, SPF, everything you can see from here as well. And the VPN also from here, you can check the settings. And then you have the interface configuration. You can check from here. And also there is one thing that I did in a couple of videos back. The packet tracer, you can do it from here. This is really cool. So for example, I want to simulate a traffic that goes from inside. Okay, let's try this. goes from inside to a source is my which one? It's a bit lagging, so hang with me. This should be 10. No, it's not working. It takes time. That's the issue with the SDM. So I need to close this. Again, let's try Cisco and CISE 123. That's why people don't prefer this. Let's wait for the SDM to come back again. You can do all the things from the ASDM, but what people prefer this for is the remote access VPN. While configuring the remote access VPN, we would use the wizard option that you have here. You can see the VPN wizard, right? You can use that to configure the any kind of VPN client list, right? So let's do the packet tracer command. Packet capture is something different. Packet tracer command. So let's say from inside with an IP address of 10.11.11.1 R1, right, is using ICMP, or 10.11.11.1 is using ICMP to go to 192.1.2.2. 20.2, that is R2. So you know it will go, R2 will reply, and then ASA will block it because of the security level. So let's see what happens here. You have the echo. So I'm sending the echo from inside. Should be allowed by the high to low, right? And let's see what happens. So I'll just start this, and the code is empty. Okay. Type 0 code 0, I think is okay. Let's start. So you can see graphically the access list is looking up. Nothing is there. Route lookup. You have the route. Yeah. NAT. No NAT. Option IP options. Nothing is there. Inspection is done. Flow creation is done. Now, from inside to outside, it's permitted. So that is what it's saying, right? Result is allowed. So now, if I try doing the same thing, but from outside to inside, it will not be allowed because it's again low to high, from 2 to 1 and start. So again, see, this will be denied. So this is a nice graphical tool to see the packet flow and learn how things work. Packet is dropped. You can see that ACL. But this is because of the so router couple is done first, then check the access list. There's no access list that is permitting this, and by default you have the logic of security level that is denying it. But if you had an access list, it will be permanent. For example, let's create an access list, okay? And let's check this the same thing, and it will be allowed. So access list out permit ICMP from host 192.1.20.2 to host 10.11.11.1 and should be echo access group out in interface outside. That is done. Now let's do the same thing again, and now see, you can see the ACL drop. Now it will be permitted. Route lookup access list is there, so that has allowed. No NAT policies, IP options checked, inspect check, and then flow creation and done. So you can see packet is allowed. So this is a nice tool. Just try it once and explore this. You have lots and lots of options to check it out. You have the this is the dashboard. Actually, you can see the interfaces, all the interfaces which are configured, and status as well, right? You can see the version, you can see the type of device. All this is here only. Licensing also, you can see license of VPNs you have failovers, you have security context, SSL VPN peers and all those stuff. You can go to the firewall dashboard to check the current status, how many connections are there. Yeah, SYN attacks, those are there, right? So you go and try this once and be familiar with this, because this is a tool that you will be working a lot with when you are working with Cisco ASA. Okay, so I think that is it for this video, and we covered a lot. And do practice this. and that will make things more clear to you. In this video, we will be talking about dynamic routings, and basically we will, the Cisco ASA supports all the dynamic routings almost, like it supports the RIP, it supports EIGRP, it supports OSPF, it supports BGP. But as an example, we will be doing RIP and OSPF, both of them. RIP version 2 basically, and OSPF, and also we will be doing the authentication part of it. Okay, so yeah, that is the whole agenda of this video. Okay, so let me just clear this drawing, and let's see. Let's start with the routing information protocol, right? RIP version 2. Okay, what we'll be doing is the configuration commands and the authentication. So basically, just let me tell you what we'll be doing is we will be running a RIP on this, and RIP over here, and RIP over here, and over here, and then we'll be checking connectivity from here to here, here to here, here to here, here to here, like that. Okay, and then you will also see that you have all the routing updates here on R1. So that is how it is, and how you enable routing on these Cisco ASA is quite similar to the routers. There are, a little bit of changes I'll be telling you. There is changes with respect to the authentication. While as configuring the RIP, as you do in your routers, how you do it is router RIP, right? Likewise, you will be doing the same here on the ASA, same command. This is how you enable the routing protocol here. Okay, then by default it does auto summary, or you have to specify the version. You can specify the version 2, and also you can say no auto summary, because by default it does the auto summary, which we don't want, right? So that is how it is, no auto summary, and that is how you do it on the routers as well, right? Okay, and network command is used to enable a routing protocol on an interface. As you know, in routers, how do you enable? For example, this router, I have to enable routing protocol here in all these interfaces. So I'll specify network, and then we'll specify the. So here on the in the RIP, you cannot specify the classless. So you have to specify 192.1.20.0/24, or you can say 255. And .255.255 like that, or not required, because this is /.4 and class full. And for the 10 subnet, you have to do as network 10.0.0.0. There is no option. And then for 199, this is your class C. So you have network 192.110 like this, right? And then for 200, likewise. So that is how you do here. But what about this ASA? So again, you cannot have classless subnet. So for example, you cannot have a 10 subnet here and also a 10 subnet here, and you cannot run RIP here and not here. You can do it by specifying the passive interface command. That is something different, but by the network command you have to always go for the class full subnet there. Okay, fine. So let's do this, and after that we will go for the authentication. So by default, let me just clear this. Okay, and you have the RIP, right? It supports version 2. It supports your both clear text as well as MD5 authentication. So clear text will have the password sent in the updates every 30 seconds that you the RIP speaker sends. Okay, it will have the password which will be in clear text. So anybody sniffing packets on this link or on this link, they can see the password that is being set up on the devices. MD5, you will have it hashed, so that you will not be able to see the password if you sniff the packet. And authentication is actually enabled on per interface basis. So you can do it globally, but again, you have to put the a single command on the interface. We'll see that. Okay, so that is the whole idea of this RIP lab, and then I'll discuss the OSPF after this RIP is set up, and then we'll just remove the configs and do OSPF. Okay, so let's begin. So first of all, what I need to do is I need to go to the routers. Okay, I need to go to the routers, and let me go to the router. Wait a second. I have the So what I'll do is on R1, okay, this LAN side. So I'll go see when I go to R1 config T and I say router RIP, then I have to say the version. This is 2 that I'm running by default. Version 1 is running, and then I have to say no auto summary. Okay. Next is the network command. So here I have all the interface on 10, so I can do this, and that's it. If you exit and do show IP protocols, if you do, you will see that I have this RIP running on all the interfaces that begins with 10, right? Because OSPF is sorry, not OSPF. This is RIP, right? So while specifying the network command, it doesn't take the class less. So you can do this. But if you do the same thing, so if I say, you should know this, but just to no router RIP, if I say, and then the router process is gone. Now let's again do the router RIP command and say version 2. Okay, and say no auto summary. Yes, and then if I specify 10 dot, say just 11 10.11.11.0, and what, you cannot do the subnet mask here, right? Not allowed. Subnet mask is not allowed there, right? So you can see no option is there. If I hit enter here, and if I go again to the IP protocols, and you can see again it has taken it as the classful 10.0.0.0 subnet. So that is the limitation of your RIP. Now let's do the same on all other routers. I have R2. I want the loopbacks also running this show. So I'll just do IP interface brief, and I'll see what. Okay, so I'll do the config T. Sorry, config T, and then I'll do router RIP and no auto version 2, and then the network command. Network, I need 192.120.0. Then I need another one is 10.0.0.0, and I need the 199.1.1.0. Yeah, and I need the network 200.1.1.0. Okay, so that is done. If I check show IP, do show IP protocols, I'll be able to see what all interfaces are part of the RIP routing process. Okay, so you can see the 3 loopbacks and 1 gigabit 00. Next is the R3 show IP interface brief and config T. Only I have 2 interfaces, router RIP version 2 and no auto summary, and then the network. I'll say 0, and then I'll say network 192.168.3.3. Yeah, so that's R3 and R4 then again. Config and do show IP protocols and to show IP interface brief, and then I'll say router RIP version 2, no auto summary, and then I need the network. I need 10. I need network 192.168.4.0. So that is done. Now I will go to the ASA now. I need on the 192.192.120 and the 10.11. Okay, so let's go to the router, config T. First of all, I need to check if I can ping the routers 4.4, yeah, and I want to ping 10.11.11.1 R1. Likewise, I can ping 192.120.2 R2, and I have 192.168.3.3 R3. Fine. Now I'll specify router RIP same like we do in the routers, and then you have the version that you have to specify, version 2, and you do the no auto summary command. Yeah, and then the network command. So you have how many networks here? You have the 10. See, no, mask option gone, and then you have the network 192.120.0. You have the network 192.168.3.0, and then you have the 4.0 network. And so now just let me name this as ASA. Okay, now if I check show IP route, okay, show route only on the ASA, got it. So I should see all the rips out. Okay, I can also do rip like this. So now I should be able to ping all the next hops because I did no auto summary, so that's why I'm getting the subnets. Okay, or else if I had not done no auto summary, then I would get all the 10s from R1, from R4, right? Then the AC would be confused from where to send the routes. Okay, so that's said and done. Let's configure the authentication. So we'll configure authentication between R1 and ASA, and likewise you would know how to configure on other interfaces. Just for the lab purpose, I will do between the R1 and the ASA, and you will know how to do it on the other. So how do you specify on the routers? On the routers, it is different from the OSPF. So you do the keychain first. You create a keychain first of all, any name, say key, okay, and then you specify the key ID. Okay, any number, fine, 2, and then you say the actual key string, that is your password. So let's say Cisco 123, simple password. Then now you need to apply this keychain on the interface that you want to run authentication with. Authentication on that side of the device. Okay, before sending the RIP updates. So for our lab, we have gig 00 where I want to apply this keychain. So I'll go to that interface G00. Then I will say IP authentication. Sorry, but you will specify the protocol. Then you specify the keychain. What was the name of the keychain? Key. That's it. Then you specify the mode. IP RIP authentication. Is it clear text or what? MD5. So you have two options. You can do clear text, you can do MD5. Okay, so let's do MD5 here. By default, if you don't specify MD5, it will be clear text like this. If you do, it doesn't take, okay, text, and then yeah. So you have to specify this. And if you do MD5, so it takes. Okay, let's do clear text, and then I'll sniff the packet. Sorry, so that you can see the password being sent in the updates. Okay, and that is done. Now the RIP updates will be gone for 10.11, 10.10, and 10.20. See, 10.11, these will be gone. As you can see here, the timings would go up for these 10 10 10 20. You can see it's 117. After some time this will be cleared from the route. This will be increasing. Others will be resetted every 30 seconds. As you can see, the second route is on 23 seconds, 25 seconds. You see it's again because it received another update for 10.22, but for these routes there is no update because that authentication has failed. So on the SA, how you do the authentication is a bit different because you don't specify a keychain and the key ID and the key key string outside. Okay, you just go to the interface and just specify that in the command. So for me, I'm running this on gig 00 on the firewall as well. So I need to go to that interface gig 00, not interface inside. Okay, here you go to the gigabit 00 and then you say IP command is not there, so you specify IP authentication and the key, and then the key should match obviously 1 2 3, and then you specify the key ID. I'm not quite sure they should match or not. Let's see if we keep it as different. Okay, I think it should match. Just let's try mode, and then you specify the mode. So on the other side I kept text, so here also I have to keep text. Let's see, does this side take the command like this? No, it doesn't, right? So yeah, so text. Now let's see if we receive the route from 10 to 2. Oh yeah, you can see. So that is very nice thing. So the key ID doesn't need to match. Okay, let's check the sniffer, capture the gig 00 here and see the text. See the password that is sent in clear text. Okay, so just a lab here. Okay, let's wait for this version 2. So yeah, I will get the response here. Let's check if we have any. So all the metrics are sent. Authentication, you can see simple password and you can see the password. Simple, right? So that is how you do the RIP. Now let's quickly go and remove all the configurations from here. So on the firewall, I'll say clear configure router, not route. Okay, route will remove. Then you can say the RIP only if you want to do, but I'm not running any other route, so I'll just say route. That's it. So if you see now, anything, okay, I can say router. So like that, I can see the routing configs that I have done. So there is nothing there. On the routers, I have to say no router RIP. That will do the take off the router RIP configurations. Okay, and on R3 also I'll say no router RIP, and on R4 also I'll say no router RIP. Go to the config mode, no router RIP. That should do. Okay, so now the idea is to run OSPF between the ASA here and then the routers, all 4 of them, and then we'll see the connectivity. Okay, that is the thing. And as you know that the OSPF actually has the concept of areas, but in this case we will go in a single area. Will not be doing multi-area configs. So this all will be in area 0 or any area. If your design is having only one area, it is not necessary you do it as area 0. You can have area 100, whatever. Okay, so let's do a quick recap. So for running a router, I mean OSPF on routers, you specify again with the router command, right? Router and then OSPF and then the process ID that need not to be same on all the routers. Okay, because it's locally significant and need not match the remote router. OSPF router are grouped into a logical entity known as area. Yeah, in our example, we are going to use a single area 0. Okay, so OSPF routers are actually identified by IP addresses that you call as a router ID. Again, the router ID concept is that if you have, I mean, priority will be given for the static entry that you do in the router config command. You can say router ID and it is denoted in a 32-bit format. That is the first priority. Second is the loopback. Highest loopback IP address will be taken, and third is the highest, interface IP address will be taken. Okay, not the interface number, the IP address that is highest configured on any of the interfaces that will be taken as a router ID. So, but we will be configuring the router IDs. This will be 4.4.4.4 like that. This will be 2.2.2.2 so that we can verify, right, which updates are being received from which router, and this will be our 10.10.10.10 router ID. Okay, so that is the idea here, and also we'll be doing the authentication here. But once you say router OSPF, then you can specify the router ID. We'll be doing that, and then the router ID in a 32-bit format. Then you again do the network statement on the routers. Just a bit different is that, for example, if I go on this router, I will say 192.1.20.say0 if I want to do on the whole network, or if just that I host IP, then .2, and then you go for the wildcard mask if it's /24 like this. But in case of ASA, there is no concept of wildcard mask, so the network command would be just with the subnet mask 120.0. It will be like this 255.0. Okay, so that is the catch there, and then obviously the area of it. Okay, so I forgot, I've not specified the area here, but area has to be there on the router as well as on the AC. Okay, so that's that, and then we'll do the authentication. OSPF again, supports both the MD5 as well as the clear text, but OSPF has neighborships, and if the authentication is not matched, the neighborship will go down, or even the modes, if it doesn't match, neighborship will go down. And the authentication is done on the interface of a router as well as on the AC. But I will show you that you can specify the enable the authentication globally, but then you have to go onto the interfaces one by one to enable the authentication there. Okay, that is a option there. So first of all, let's go and configure the OSPF neighborship, and then we will do the authentication part. Okay, so let's go on the routers first. On R1, let's start with R1. I'll say router OSPF process ID 1. Then I will say router ID 1.1.1.1. Then I will specify the network. So I want to run this on the the interface that is going to the AC, and then I want to run this on the 10. I think I have 10 there or 20 there. I have 1, 10, 1, 1 and 10, 10 and 10, 20. So I want to run that on all the interfaces there. So you can also say like this, like a host, only that interface will be running with OSPF. And then you have the 20.0 and then dot 255. And I think that is it, right? I have 10, 11, 10, 10, 10, 20. I didn't specify 10, 10, right? So let's do 10, 10, 10. Okay, that is none. So our router is up with OSPF. If you go and do the protocols command just to check the process. Okay, I said run, so I can say only this. So you can see that these interfaces are part of area 0. Okay, and this is OSPF 1. You can also say the command show IP OSPF to check the other details like the router ID. Again, here you can check the process and also the other configs like the LSAs you have not received. So these are there, but you can also have the intervals here and what, and you can check the what I want to see is supports only single task. Okay, LSAs. Okay, these are advanced OSPF concepts. Oh, I want to see this actually. Number of interfaces that are in this area is 4. But if you want to see those interfaces, you have to do show IP protocols. Yeah, you can see those 4 areas. And also you can do show IP OSPF interfaces in case you want to check the interface itself. You can have the brief command to have a slightly less information over there like that. Process ID 1 is running on those. It's part of area 0. These are the addresses with the mask and the cost and all the other configurations. Okay, let's do this on ASA. So here also you do the same router command, right? Router OSPF and 1 to whatever 1. Okay, but the idea is you should have process 1 on all the only one process running. You can have multiple processes, but then you have to do advertise routes. You have to do redistribution. That is a different topic. So here you specify the router ID. Yeah, this is actually the ASA, so this will be 10. Then you have the network command. So in my case, I have the 10, 11, 11, 0, and then you specify the subnet mask, not the wildcard mask, with the area 0. And let's see show OSPF neighbors. You can see directly. Yeah. So if you go and you can see that you have a neighbor on the inside interface, and if you check the show route with OSPF only, you'll see 10 and 1, 10, 10 and 10, 20. So you can go and now ping the ASA can now reach the loopbacks on R1. Yeah? So that is how you do the OSPF on the ASA. Now let's go to R2 and do the OSPF here again. Enable a router, okay, config, and then you have the router OSPF 1. Yeah, and then you do the router ID. This is R2, so 222, and then I have the network 192.120.0, and then the wildcard mask, and then you specify the area. Done. And also I have the 10. I think what is the 10.2.2? Yeah. Then I have the 10.2.2.0. Here I want to run that 255 area 0, and also the 200 1, and then you have the all zeros. I'll match that, and also I'll match 199.1.1.1 and all zeros area 0. Yeah, and if I see OSPF neighbors, I should have neighborship with my route. Okay, I'm not actually configured the ASA on that interface, right? But here you can see all these are there, and if I see IP OSPF interface brief, I should see all the 4 interface, 3 loopbacks and 1 physical interface. Okay, I'll go to ASA and I will say again, I have the config T. I am running router OSPF already there with the process ID 1. I just have to specify the network, that is 192.120.10, and I can do a specific interface like this, or even you can go to the interface and do the interface configuration. Okay, so that's it. And now let's go to R2 and see the, you can see that the neighbor is up. If I say show IP OSPF neighbors, I should see 10 10 10. That is my ASA have neighborship with this. Now if I check the route here, I should have 10 11 10 10 and 10 20 here. As you can see, I have all those routes here. Show IP route and then OSPF. If I do only, you can see that, but I will not be able to ping these interfaces because again on the ASA, this is high to low. I need a ACL to allow that. Okay, and also from inside, if I check show IP route OSPF, I should see 200 199 all those here, but again I'll not be able to reach that loopback. Again, the reverse traffic is blocked by ASA because it doesn't inspect ICMP. But there is a command on ASA which many people don't know. As I said in the beginning videos, that we can inspect ICMP, right? Going to the policy and specifying. Just let me show run. I don't need the do command here on the ASA. All the time you do this mistake of doing do. Okay, anyways, so what I was talking about was the inspection of ICMP. Yeah, you can see I don't have inspect ICMP here. I can go to this policy map, class, and then inspection default, and then I can say inspect ICMP, right? That is one thing. And there is another one. I think this is fix up ICMP command. Yeah. So when you do this, fix up protocol, and then you can say any of this, and it will be inspected. So here you also have ICMP, and if you do ICMP, now you will see in the run that the ICMP is inspected there. If you go here now, now you can see that ICMP has been added here. So this is a kind of shortcut. Okay, so now if you go to your inside, okay, that ping that was not working earlier is going to work now. Okay, but from R2 again, it will not work. Again, the same logic of low security to high security. Okay, so that is again an information there. So now let's do I'll not be doing R3 and R4. Okay, you can do it by yourself. Now let's do the authentication part. So on routers, you don't have the concept of keychain and all on ASA. You go to the interface, on the routers as well, you go to the interface and directly do the authentication mode and the key. Okay, so let's start with R2. Okay, and you will see once I configure on R2, and the neighborship is going to go down. So on R2, my interface that is going to the ASA is gig 00. So I'll go config T interface gigabit 0/0, and then I will say IP OSPF and then authentication. You have the option here, right? Message digest means MD5, which is hashed again. You can do that. Okay, but if you just press enter here, it will be clear text by default. Okay, so I'll do message digest here. Done. After that, nothing there. Okay, then you have to specify the key. Again, IP OSPF, then you have the authentication, then -key. Then you have you specify the key. As you can see, after I do this, the neighbor should ship should go down because you have the flag of authentication set in the OSPF hellos, and the neighborship should go down. Okay, if I see show IP OSPF neighbors, okay, let's wait. 3, 2, 1, 0, and gone. Yeah, so that is what I was talking about. And also if I exit here and if I see the route, obviously that will be gone. Yeah, no OSPF routes. Okay, now you have to do the same on the ASA side, and on ASA also you do the same thing apart from the IP keyword. So here also you go to the router, not the router, sorry, the interface, that is gig01 towards R2. So you go to the interface, gigabit 0/1, and instead of IP OSPF, we do OSPF authentication message digest. That's it. And then you again do OSPF authentication key. Okay, then the key you specify. Authentication, yeah, authentication hyphen key, and then Cisco 123. That's it. This should actually match. Yeah, the keys should match. That is very important, right? Once you do this, you'll go to R2 and you can see that the routes are back. Yeah, and from R1, if you try to ping the same subnet, it is going to be reachable. Okay, so that is how you do the authentication, and hope you understood the concepts. I mean, you can go on and do the labs as I'm doing side by side, so that you get more clarity on this. Yeah, and also, I mean, if you have any doubts, kindly reach me, comment, and you can reach me. And please don't forget to like, share, and subscribe to my channel. So in our earlier videos, we have done the basics. Basics of ASA. We have covered the basics of ASA, how ASA works, the flow, and the management, and also the routing. Right, we have covered that routing, whether it be static routing or the dynamic. So we have covered static and dynamic. So now in this video, what I want to cover is the NATing. Okay, NAT stands for network address translation, right? Address. And for the people who don't know, let me just explain what this does. So this helps us to convert the public IP, or you can say the private IP to public IP. Private IP to public IP masking, you can say, or translation. Masking, or you can say translation. And this translation actually helps us in a couple of ways. One of the way is it helps us conserving the usage of the public IP address of public IPs, because I mean in a way it helps us in cutting down the cost as well, because these public IP addresses will cost you money, right? So this will cost you money, and also this will provide you security in a sense when your internal IP is masked with external IP address, and then the public public cloud that we have, where you have billions and billions of people, they don't get to know the addressing scheme that you're using inside your LAN, right? So that is again a kind of security that you get when you use NATing. Now, what is the concept of NAT? Let me clear this. So basically what happens, you use the private IP address range, whether it's from the 10 range or whether it's from the 172.16 range, right? Or whether it's from the what 192 range, right? Whether it's from the 192 range. So you have these options, right, to use the private IP address scheme inside your LAN, right? So you can use any of these, but you cannot, use this IP address to access the internet, because these addresses are blocked on the internet. Using different methods, you can have simplest would be you can have an ACL on the ISP side saying block these ranges, right? So short story, that this is blocked, and you cannot use this IP address to reach it. So now, in order to use the private IPs inside and use the same IPs to get to the internet, what we do is we take advantage of the NAT. And how it helps is you basically translate the IP addresses of the private range to the public IP, and on the public side you are represented with that public IP that you have been translated to. For example, let's take a scenario here. R1 is actually 10.11.11.1, right? So this is the IP of the R1. Now imagine it wants to go to any IP address on this range. So just think this is a telnet packet. Okay. Let's see, telnet source is R1 and destination is, let's say, 192.1.20.2, which is R2's address. So what happens on the ASA is it checks the the policy, but as now we are going from the higher security level to the low security level, and this is a TCP based packet, and this will be allowed. Once you go out, so these two networks are directly connected, and it knows to go to 192.120.2, I have to go through the Ether 1 interface. Once the packet reaches R2 checks its own routing table, and it sees that, first of all, it sees that this packet is destined to me. It will open up and see I have to send the reply back, right? So now it will flip the source and destination. Now the source and destination will be different. Now the source would be R2, this time 1.20.2, and the destination is 10.11.11.1. Now there the problem lies, because in the real time you will not expect your ISP routers or devices to know your internal IP address or have any routes, static routes to those addresses. So what will it do? It will drop the packet there. Okay. In our earlier cases, what we had a static route here defined, which said if you want to go to 10.11.11.11.0 with /24, go to the IP address of the AC. But that was for the lab purpose. But in real world, this is not the case. So how you solve this issue? Okay, what you do is you configure NAT on the ASA. But specifically, we are going to talk about the auto NAT, and that too is actually dynamic NAT. Okay, this is part of the dynamic NAT. Comes in the category of auto NAT, but it's again subcategory of dynamic NAT. And then this can also be called as object NAT, because we will be using objects, and you will see how this is called object NAT. So now in this case, what we will do? Okay, let's imagine the same traffic. Okay, R1 sending telnet traffic to, again, R1 is 10.11.11.1 as the source, and destination 192.1.20.2, right? So now in this case, you have the source and the destination as it was in the earlier case, but now the ASA will be doing something called NAT. Okay, now in NAT, what it will do is it will create a pool of the public IP. So I have say a range. I will show you how to define this. Just try to understand. So I'll have a range of public IP address. So for example, we have this 20.0 range, right? So imagine I have the addresses belonging from 11 to 50. Okay, 192.120.11 to 20.50. So that is the range. That again I'll create another pool which will specify the internal this subnet. So I can say subnet. So this is my 11.11, which I want to actually translate. Okay, so I'll specify the whole subnet. I can also specify this subnet. So we'll see if I do only this subnet NAT, this will be able to go to this address, but this will not be able to go. Okay, so that is the subnet. Then you define a NAT statement. How you do it? You need to understand this. So you say NAT. First, you create the pool, and inside that internal pool, you define the NAT statement. So you say inside NAT, and then you have to specify two interfaces. So it's always, 99% will be doing the source NAT, and you will see this as the high level interface and high security level, and then the low security level interface. So in this case, this will be my inside, and this will be my outside, like that. So you have the inside and outside, and then here you define the dynamic or the static nature. So dynamic, and then you define the pool that you have here. You have to name this pool, say my pool. Okay, so you say my pool here also. So you point this NAT to this pool. So anybody from this pool when going outside will have a IP address from this pool dynamically assigned. So now what happens? So for example, now let me take another. Now this is the packet from the ASA. So now on the ASA you have a statement saying any IP address going for this pool will be translated to any IP address from this public pool dynamically. So what happens here is now the packet will be changed by the ASA. So now the source and destination will change. So it will be the ASA will be changing the source here. In this case, you have the 10.11.11.1. Now it will go as 192.1.20. something. So we have 11, let's say 12, and then it is going to the same destination, which is 192.1.20.2. So this is the packet that reaches the R2. Imagine our R2 sees that, okay, this packet belongs to me, let's open it, and the source is 12, so I have to send a packet back to 12. Now source is me, 192.1.20.2, going to destination 192.1.20.12. So in his routing table, he knows that to reach to 192.20.0, I have to go on the gig 01 interface. So it sends the traffic back to the ASA. Now ASA has a translation table, right? So now it will do the untranslation. Now it will do the untranslation. So now the packet looks like this, which is ASA. ASA looks at the translation table and says, okay, so the source remains the same in this case. Now the destination that was 12 has to be changed to 10.11.11.1. Now this packet 192.1.20.2, right? This is the packet that was after the untranslation will reach to the R1. So now just check the the initial packet and the reply packet. It is matching, right? So he sent the packet to 20.2 and the 20.2 is replying to him. This should be one here. Okay, so that is the whole concept of NATing, and that too is the dynamic NATing, because this is not in your control. You could define a pool and dynamically the IP address is assigned to that device that is trying to reach outside, right? So I have some points that I want to share with you. So this is for the NAT. Okay, translates private IP address to public IPs to conserve public internet IP address space. This is generally why we use NAT for private to public, but you can translate any IP to any IP. In dynamic NAT, so we are talking about dynamic NAT in this video, which is also called object NAT or the auto NAT. But in dynamic NAT, you create a pool of public IPs, as I said. So this creation of pool of public IPs is called creating an object. So that's why we call this as an object NAT, because we are using objects for these things. And then you link it to an internal address that can use the pool of public IPs. So internal address can again be a subnet, a range, or a host IP address. Likewise, the pool that you create as for the public IP can also be a host IP, a subnet, a range. When the internal device tries to go out, it picks an unused IP address from the pool and translates it. So it's like dynamic, right? The next available public IP will be used. It keeps the translation in table known as the translation table. I'll show that. You can see it by show run xlate or show xlate command, show NAT details command. When the packet returns, the destination gets again untranslated back to the original IP and is sent back to the original device. That's what I showed it to you, right? So when you go from inside to outside, it translates the source. When coming back, it translates the destination. But that is not the case. So when you just, when you're working with the ASA, you just need to understand this concept of ASA. So for ASA, what subnet is local? For him, this side is local or the outside is local. For him, this side is local, right? So whenever you translate the local side, it's called as source NAT. So when the IP address came from outside, when it came from 192.1.20.2 as the source and destination was 192.1.20.12, he translated to the destination, right, in this packet. But for the ASA, this was actually the local side of the LAN, right? But this is not local. This is the outside. So again, this is source NAT. I mean, while as the initial packet, this is obvious. This is the local side. So that's why the source NAT. Okay, so it's a bit confusing, but you have to understand this with respect to ASA. Okay, so let me clear this and let's go and do this on the ASA. So if I go here on R1, enable and show IP route, if I see, I should have a default route pointing towards the ASA. I have that. And on R2, if I see show IP route, I have a static route that is saying this thing, right? So I need to remove this on the enable config do show run include route. So I should have this, yeah. So I say no to this whole statement and this should be removed. Do right if I do, that is fine. Now on ASA, I should have a default route pointing towards the internet router. So I have that for any packet that has to be reachable, right? Okay, so what I'll do is I'll generate a telnet from R1 to R2. Let's do that. Let's do that before we do the NAT, and we'll see the difference. So on R1, as I have a default route, so this will be sending the packet to ASA. ASA again being a TCP high to low, it is going to send to R2. R2, is going to drop. Reason being is it does not have the route. Do show route. Okay, do show IP route. If I see, yeah. So I see that for 10.11.11.0, I don't have any route, right? So let's do that. Exit debug IP packet details, and on R1 I will do the telnet to 192.1.20.2. That is R2. Now on R2 I should see some packets, yeah. And let's do this all quickly, and yeah. So this should be you can see the source is 10.11.11. This is R1. That means the ASA has a connection table which says going to 23 on port 23, right? Reverse packet, reverse traffic is actually mentioned in the connection table, as I said. So the source was this one with the random port of this, and the destination port was this, right? So on R2, if you see, I have a source that is from 1 and destination is R2. You should see, I mean, destination is 23, that means it's a telnet packet. You should see a RIP failure, packet routed and okay, yeah, you can see. So routed via RIP, but it is failed, right? So because I don't have a routing, right? So let's keep it like this, and let's do the natting, and then we'll see the difference. Okay, so let me just explain to you how do you do the natting. Okay, so the configuration part, configuration of dynamic NAT on AC. So first thing first, what you do is you create a pool that defines the range of public IP addresses, right? That you have IP addresses. So just imagine my company is a rich company, and we have this whole range of public IP addresses. So you define this by object command network, object network, and then you define the pool, say my pool, and then here you have 3 options. You can say host, or you can say subnet, or you can say range. Okay, so if you have a single host, just say host, single IP of the pool, say host. If you have a whole subnet, say subnet, or in my case I have a range, so I'll say range 192.120.11 to 192.1.20.50. So I have this range. Next, step number 2 is you define the internal pool that will be translated to the public IP. Okay, so and then also you define the then define the NAT statement. I'll show you. So first you again do the same thing, object network, and then you say internal. This is my internal, and then you can also say a description here. Let's put a description as internal LAN. Okay, then you can do after that you have to again 3 options: host, subnet, range. So here I have the whole subnet, so I'll say 10.11.11.0, then the subnet mask /24, right? Now after that you have the NAT statement. How do you do the NAT statement? Just let me tell you the whole this, as I said, right? So this is the way you do it, right? High and comma low, and then you say dynamic, right? And then dynamic, and then the pool name, right? So how do you do that? So in our case we have the NAT, and then you have the inside high, and then the low is outside, then you say dynamic and my pool. So that is the case, and that's it. We don't need a security policy, because I will be trying from inside to outside, I mean low to high to low, and that to TCP, so the return traffic will be allowed because of the connection table. So let's do it on the ASA. ASA, first thing first, what I'm going to do is object network, and then I say my pool, right? And then I say range. So range, yeah, you can see all the options here. We have the range, you have the subnet, you have the host. So I'll be doing range 192.1.20.11 and 192.1.20.50. So that is the object. Now again I'll go object network, then I say internal. This is the name. Once done, you say again the subnet, this time 10.11.11.0.255.255.255.0. So that is the subnet. Now inside that you define the NAT. So you do inside and then comma outside, and here you have the option of static and dynamic. We are doing the dynamic first, so let's do the dynamic, and then hit question mark. You will see that you have to the pool or the group name, whatever you have. In my case I have pool, so you have to write this down like this, okay? So now that you have this already configured. How to check this? So you can do a couple of things. Show xlate. You will not be able to see. I think this is the earlier clear xlate. If I do so, show xlate in the dynamic, it should not be like this, because what happens is only when you initiate the traffic you should see the xlate there. So, okay, so this was there because of the earlier configurations maybe, and now what you do is you have another command, show NAT details. That will tell you the whole detail, okay, about the original subnet and the translated address here and the hits. So you can see we have not done any translations till now. You can see the hits are not there. So for example, you want to see the running configuration, you say show a NAT, you will see the NAT, and also if you want to see the object, you can see the object. Okay, show NAT is also a command. You can see only the translations, and the detail will show the source and the translated address as well. So now enough of talking, let's do the same testing again. It will take some time for the translation. I think if you check the NAT details, you have a hit, you can see, but I think that will not be successful because the first packet gets stopped. Okay, so now I have the, I think it's Cisco 123. Let me check Cisco 123. Yeah, so I'm inside R2. So if I go here, if I check the show xlate now, I should have the translation. So I can see inside my R1, when going to outside, was translated to .18. Now if I go to R1, I'm telneted to R2, and if I say show user, this should show .18 logged in. Okay, let's see. Let's wait for some time, and I should see that the device that is logged in is .18. Yeah. So if I check again, I can check show con because I have the the telnet going on. So you can see that this is the connection. I'm not bothered about that. I'm bothered about this one. So I need the NAT that has happened is this one. Show NAT details also I can do. You can see the hits here, or even if you should see the NAT only, it will show the hits. So two commands, show NAT will show the hits, show xlate will show you the binding of that. Yeah, so that is how your internal private IP address devices are able to reach to the internet. And this is one part of it, which is called the dynamic NAT, or you can say auto NAT. Sub category of auto NAT is dynamic NAT. You have inside auto NAT, you have a couple of more NATs. You have the static NAT. So that we will see in the next videos. But for this video, this is it. And I hope you liked my video. You understood the concept. If not, you can go again and again, watch this video again and again until you understand. Best thing is to go on and practice this lab. Follow with me and do the things, and just experiment with yourself. Okay. In my last video, we did the dynamic NAT. So as of now, you know that NAT is used to translate the IP addresses, mostly private to public. Right? Now, the one that we saw was dynamic, and we created a pool of public addresses, and all our internal devices with the private IP address used to take one IP address from the public pool and go to the internet, and then the next one from the internal private pool will take the next address, and it will be a dynamic allotment, right? So now the next thing that I want to tell you is about the static NAT, what it is and why we use it. So mostly the static NAT is used to translate a single real address to a single mapped address, means a public address. This is, you can say, 1-to-1 translations. Okay, and I mean that address should be routable on the destination network. For example, if I want to reach from my internal PC, okay, I have a PC here internal, and there's an ASA here. So let's think this is an ASA, and I have to reach some server on the cloud which has a public IP. In this case, let's say this is the Google IP of 88888. This is DNS server. So I want to reach this DNS server. Right? So this DNS server should have that IP address that is going to be translated. I mean the public IP that should be routable here. So if I am going to translate this internal IP of 10.1.1.1 and I would translate this to say 20.1.3.2, which is a public IP, right? This is a public IP, this is a private IP, and the IP that I'm going to translate this to should be routable on this device. That means that should be routable on the internet in this case. Okay, because this is a public IP and this server should have a default route or something that should be pointing, and somehow it should be reachable to this IP because of the public nature, right? And the most important thing is that the static NAT is bidirectional. The one we did, I mean, the last video was dynamic, and it was only one way, that is called the unidirectional. Even the static PAT is unidirectional. So what that means is, so for example, I had the, let me just clear this drawing and let me start with a new one. So for example, in the dynamic NAT, I had a PC inside which wanted to reach the internet. So this is my firewall like this, for example, and it has a connection to the internet, and somewhere in the internet I have a Google DNS server which my internal PC wants to reach. So for example, what happens is this has been initiated by my internal resource, like this packet. So I have a DNS request that has been created by my server. So once it goes outside, there is a dynamic NAT pool here, and it gets an IP from this pool, say 20 dot something, and in our case, and it reaches the 888 and it replies back to this guy. And that's how the untranslation happens, and the internal user gets the return traffic. Now imagine if this server initiates the packet to this IP, it will not be untranslated. So that is what is called the bidirectional and unidirectional. So this case is what? Unidirectional. So that's why I said the dynamic NATing is unidirectional, while as static NAT is bidirectional. So mostly you will see this configured when we have a server in the DMZ. Okay, this is my DMZ. So we will be demonstrating it on DMZ3 servers. So in our case, we have a router, and I will try to enable telnet or an HTTP or something, and I will show you how this works. Okay, so for example, we have a web server which is serving some HTTP requests. So this guy on the internet doesn't know the, I mean, he cannot reach the private IP address of this router, right, or this server. So how it, I mean, reaches the how it is able to access the servers that these servers are, I mean, serving on the DMZ is with the help of static NAT. So what we do is we bind this private IP to a public IP on the internet, which we have, I mean, taken from the ISP, and we actually create a DNS record for that IP. This is called the A record. So we have a record on our DNS server which says the translation from the domain name to the IP address, to the public IP address. Okay, so for example, we register that IP address with the domain name of www.zbnetworks.com, right? And once the DNS request is received and this A record is read, then the ZB networks gets translated into 192.1.1 20.11. Okay, and now the public server has this IP, and it goes to that IP, and once it is hit on this ASA on the outside interface, it checks the translation table and it checks the rules as well, if it's allowed or not. In this case, it should be allowed because it's from the low to high, so there we should have a rule there. While as internal high to low, you don't need that rule, right? Because TCP and UDP is inspected. So those are basics. So let's move on to the NATing part. Once you have the rules and you have the NAT, the translation will happen and the destination will be actually changed from 11 to 3.3. 192.168.3.3. You will see the same concept in other firewalls, and where that they call this as the destination NAT. But in case of ASA, specific to ASA, this is still a source NAT. Okay, don't get confused on this. This is with respect to only ASA, because 99% on ASA is called source NAT. Okay, because I mean, with respect to ASA, it's like when your address gets translated, it's called what? Source NAT. And when the remote address is translated, it's called DNAT, destination NAT. In this case, what we are doing, source NAT, right? Even it's in the destination field of the packet. When the initiator from the outside hits this IP on the 20.11, and we translate the destination IP to 3.3, but this is my address, right? This belongs to me, 20.11 or 3.3, right? While as 8.8.8, which is the source on this packet, doesn't belong to me. If I change that 8.8.8, that is DNAT for ASA, and we will see that in the future videos, right? So how do we do this? Let's do some of the examples so that you understand this. But before that, let me just I covered this, that this is bidirectional and static PAT, and your dynamic NAT is unidirectional. And some of the examples you can see here, how you configure the static NAT. This is one of the ways you configure static NAT. I'll show another one as well. So in this case, we will be using the objects, right? So you will create two objects. You have the real object, which will be your private IP address, and then you will have the public IP address, which is called the map. And how you do it is you say the NAT and inside, and then the outside and source, and here static. So in that dynamic, you had the dynamic keyword here, then you say the private address and then the public address. So there is another thing that you need to understand about this NAT NAT statement, right? So when you create an object, right? So when you create an object and when you name that as network, say inside, okay, and then you say, right, the host or the subnet, whatever range, and then you say the IP address, and then you say the NAT statement, and then the inside, outside, whatever. So this is basically always the high one, the high address, and this is the low security level address, and this is always the high security level address. Understand? But in this case, you can see this is my what? I have configured this as my high. The low, right? The public. But just ignore this, because I am telling it not based on this one. I am telling it based on the examples that we will do. This is one type. Just remember that this is the high address, okay, and then you have the here you always say the low address. After the static or the dynamic, you always say the low address, okay. And now this high is always linked to this, and this low is always linked to this, okay. So this is 99%, this will be like this. And I will show you when this would change. So always high, low, and here you will, after the static or the dynamic address, always the low address, the public address here, okay, on which you want to translate it to. So that is one thing that I wanted to, clear the concept to you guys. And now what I want to show you is some of the topics related to the static NAT. Right? And once you create the static NAT, right? So let me just close this. Okay. So when you create a static NAT, what happens is the entry is created the time you enter the NAT statement, because this is a this is a static NAT, and in the dynamic NAT you wait for the traffic to be initiated, and then only you see the NAT translation. But here when you enter that before the traffic hits the ASA or the public IP, the NAT translation will be there in the table. We see that. Okay, and as I said, static NAT is generally used to translate the public facing servers on the DMs. Okay, the reason for that is the clients from the internet will need a fixed IP address to send the request, right? You need a public IP address for the clients, and you need the ACL needs to be configured for the out to in traffic, or you can say the low to high traffic. So there needs to be, on top of creating an NAT statement, you have to have the ACL configured. Okay, and remember this, that the ASA beginning from 8.3 and above, the ASA translates first and then checks the ACL. So that means always you will have the private IP address in the ACL. Simple as that. Just remember this. Prior to 8.3, it was different, but you don't need to understand that. So anyways, so this is what we have. Okay, so let's go to my topology. I think I have it here somewhere. Let's bring a new tab. I have my server 192.168.1.99. Let me just log into my server. Great. Let me turn on my EVNG virtual machine, this one, and we will start with the topology. And we'll see how we can do the translations and how we can verify those translations have been configured. Right? Let me turn on this. It should be okay. For the time being, I'll pause the video, and again I will continue once the servers up. Okay, so I have the topology here. So this is what we are going to do. Let me just get my pen and start drawing. So what my plan is that on R3 here, what we will do is we will enable telnet, or say we will allow ICMP. So whenever a person from the outside, which is our R2, this guy, if he reaches on 192.1.20.50, this AC should translate it to say 10.3.3.1, and we should have a ping, only for ping. If somebody pings on this address, then it should translate and go to 10.3.3.1. Okay. Okay, and you will create an access list here also. And also what I'll do is, if a person comes to 20.50, say 52 or 53, whatever, let's see when I do the translation. So what should happen is, this should be translated to here .3 on this interface. Okay, and this should be only done when we have a telnet packet. Okay, so I will configure this as the I will allow a telnet here in the ACL. Okay, so that is what. And also, just to um, let you guys know that we will also create two NATing and two ACLs for web traffic, which should be your port 80 for HTTP and port 443 for HTTPS. And I'll also show you the translation for that, and also the access list, but I'll not be able to demonstrate because we don't have that. But I'll be testing with the telnet and the ICMP packets, right? So yeah, that's the plan, and let's see what we will do. So I'll clear this, and let me take my notepad, which I have here, this one. And what we will do is, we will have the the translations. Okay, so let's see the plan of implementation, like that. Okay, what we want to do is, we want to have a 192.168.3.3, which is our which is the R3, right? It should be translated to 192.1.20.53, and that should be for your, say, telnet. And the same thing, 10.3.3.1, if it should be translated to 192.1.20.52, and it should be allowed on ICMP, like that. And also for your web, right, we need only what, 192.168, say 1.11, not 1, 3.11. This should be translated to 192.1.20.50, and this should be your web server, right? Web server, we should have the 80, port 80 and 443. And also on the ICMP, you don't need anything. This is ICMP, and telnet should be 23. You will specify telnet as well, yes. And then also you need the ACLs. So ACLs, configure the ACLs. So ACLs, how it should be. So before ACLs, that configure the NAT statement. As I said, the syntax. Okay, syntax would be like you should have the object, and then network you will specify, and then the name of the object. Okay, so as for the service of web, you will say web, or maybe something like ICMP, telnet, depends on you. So then you say the host and the high address. I mean, this is your high level, this high security level, which will be your mostly the private address. And then the NAT statement would be like this, high and comma low. I mean, this is the security level, and then you say static, and then you say the IP address of the low security level, which will be your public IP address, the outside. Yeah. So this is the syntax. Okay, and always remember this. Again, as I said earlier, that this will always be with this one, and this will always be with this one. So remember that. Clear this. You also have the option to configure the objects. So how do you do that? As I have specified in my here. So you create the object. This is the pad. This is the static pad. Okay, here have the static net. So you have the object network, the real object, which is your private. Then you say the mapped object, which is your public. Then you say NAT, high, low, and then source, you specify the source keyword, and then static, and then the again the this is like the the high and the low. So high comes here and the low comes there. Okay, so like that. So we can do it like this also. This is like from the global. This is called the globe. Creating NAT on the global. Uh, I mean, uh, Configuration. While we do the other one, which you will see in the examples. We do it in the object. Okay, and this has a difference in a sense. If you do it globally, it will go in the section 1. So this is also important, and I would like to go and throw some light on this. So if you do something like this, there are actually sections. I will show you in that. You have section 1, you have section 2, you have section 3. So and section 3 in the NAT table. Okay, so it actually has a preference level. So section 1 has a higher preference than section 2, and section 2 has a higher preference than section 3. Now, what is this section and all these sections, right? So if somebody does a global NAT, it goes in section 1. That means the global NAT will be preferred over section 2, which is the dynamic NAT, which you do on the inside the object. Okay, so if you do any NAT inside the object, that goes into section 2, and section 3 we will talk about this later. So as of now, just understand that the section 1 is the NAT that you do on the global configuration, and when you do the NAT inside an object, it will be in section 2. Okay, so that was a brief info on that. I'll clear this. Okay, now let's do the configuration on my ACs. So I have my AC here. Let's go to the putty. Okay, let's see the ASA. So do I have any NAT configuration? No. Show interface IP brief. Yeah, so I have my IP address. I can ping my 192.168.3.3 is my router. I can ping them. Can I ping show route? Let me see the route if I have to my 10.3.3. I don't think I have a route, so I need to check on the R3 that I have that. For the ping, right? Show IP interface brief. Yeah, I have 3.3 show IP route. If I see, I have a static route towards the ASA, but ASA doesn't has any route, so I should have a route towards DMZ3, and address is 3.1.0.0.0, and then you have the next hop, that is 192.168.3.3. So that, okay, the mask is not right, so this should be okay, done. So now if I try to ping this 10.3.3.1 should be reachable. Yeah, so my AC can reach the loop back on R3, because I'll be translating this loop back to some address on the public side. And then on R2, I have enabled this one, and I can ping 192.1.20.10. Hope you remember all the IP address schemas. So R1 I don't require as of now, because we'll be working with R2 and R3. So let's start with the So let me just open this. Okay, so I need 3.3 to be translated to 1.20.53 and telnet. Okay, let's do the NATing first. So for this, I need what? I need on ASA. So 3.3 is my router, and it should be translated to this IP. So object, and that too should be telnet. Okay. Let's say object network. So let's name it telnet. Telnet to R3. Telnet R3, right? And then I have to specify the high address. So I will say host, and this is my high interface 3.3, and then I have the NAT statement. Now NAT is from the high interface, which is my DMZ3 to my outside, right? Outside. Oh, okay. So this should be like outside, comma, and then I can have the static, and then your low address again. Okay, so this is my address that I want to represent on the outside. So this is a one-to-one NAT. So whenever a person comes on 50.53 on the outside, it will be translated to 3.3. Okay, that and we will specify this only for the ACL. We will have to specify the traffic type. Okay, and then we have the so I'll exit from this, and this should go into section 2, right? And let's go to the next one, which is my object and then network, and I will say ping. This is my ping, and I will say host. This is my 10.3.3.1, and this will be NAT my again DMZ3 comma outside, right? And then again say static, and then the IP address that I need is 192.1.20.52. Done. I will again exit, and I need next one for my web. So again object, then network, say web, okay, and then I have the host, which is 192.168.3.11. I don't have any host, but this is just an example, and I will say the NAT statement again from my DMZ3 to my outside, and then static, and then the IP address that I need. That is done. Now exit. Now I need the access list. Now access list, which I say out in out permit. Now I need the telnet TCP any, that can be any from outside, to host. Now the IP address should be what? It should be the private. Okay, this is for the telnet, and I will be doing the telnet to the R3, and then we can specify the telnet like this. You can say telnet, or you can say port number 23 like that. This will also do. Okay, then I have the next statement, access list, same out permit. Now I need for the ICMP from any to my host, which one? 10.3.3.1. Here also you can see echo reply, whatever you want, and then you have the access list for out permit TCP any to host 192.168.3.11 EQ. You can have one for HTTP and one for the HTTPS. Okay, so we have the NAT statements, right? Now this is, because this is a static NAT, so when I say show xlate, there should be translations in table, because this is static. So you can see as from DMZ inside, from the high security level, you have 10.3.3.1, which is represented on the outside as 52, and this is actually for the ICMP, right, the ping. And also from the DMZ, the .3, which is the router itself, is represented 53. So we have to telnet at 53 and ping 52 to get the reply, right? And that's it. So let's go on to the and also you can see show NAT detail, as I wanted to show you one thing. So you can see this is in section 2, right? Okay, because this is not the we did it inside the object, we didn't do it globally, so that's why it is in section 2. But if we do it globally, then of course it will be in section 1, and section 1 is always preferred than section 2. And inside all the sections you have the what do you say, it's like top down order wise, it will be index wise, index number. So first one will be checked first, then second, and like that. Okay, so let's go to R2, and as I can see in my here 10.3, so I need to ping on 52. Okay, so if I do here, it should be from R2 52. Okay, I need to ping 192.1.20.52, and this should be translated to and I need to see if I have the, okay, I have not applied the access list, right? Yeah, so I need to apply access group out in interface outside. Okay, now it's fine. Go to R2 again, do the same thing, and this should be translated and the ping should be successful. You can see. So how do you check it? So you say show NAT, or you can say show NAT also. Yeah, show NAT. If you see, you will see the hits. So you can see on that ping you have a hit of untranslation. Okay, so untranslation is the number of packets you send from here. So that many times it will be translated, right? So if you again do this, let's see, and hit is 1. This is the actual translations, untranslations. Okay, so this is flow wise and this is packet wise. So now the problem is how to check on R3, right? Because let's do a debug. Because you need to see what packet you are receiving and from what IP address you are receiving. And yeah, so or what you can do is we can do a packet capture. That would be more on gig 02. Okay, and I will capture gig 02 here, and you will see the packet that is arriving and leaving this interface. So I mean, by default, what it should be is, so it should be like, so when the packet is created on R2, source and destination. So my source should be the R2's address. I think it's 192.1.20.2, this interface, G00 interface. This should be the source. And destination, as I said, I am doing 192.1.20.52 for the ping, right? So this is the one. Once it hits the ASA and then the untranslation happens, the source should be the same and the destination should change. The source should be 192.1.20.2 and the destination now should be translated to this one. Okay, so let's see if this is the case on the capture that we are doing. So let me go to my Wireshark. Okay, here I have the Wireshark. So let's generate a ping from R2 from the outside. The same ping we did earlier. We should have some packet here. Yeah. Now let's grab this one, and you can see on the source you have 22.2 and then the destination has been translated to, because I did a ping to 52 right here in my, here you can see what I'm pinging, 52, but it has been changed to 3.3. Yeah, and the reverse should be also possible because of the translation. So if I go to R3 and ping the, which one? 192.1.20.2, I think. Yeah. So that is the address on the, but I have to do it with the source. You know why? Because I am translating the source. So if I do source, then I say loopback, source loopback 0, right? So this is my, which one? Yeah. So I can do this. So this is what I say is, now if you check this one, it should be the 10.3.3 should be translated to, that will be seen where? That will be seen on the R2. So if I go to R2, this is what is bidirectional. So if I say debug IP packet details here and do the same ping from R3 with the source of loopback 0 and go to R2, and you will see that you will receive packets from 52. Let me just do a U all. Yeah. So you will see that you have received the, this is the reply that is going, but the source of this packet should be here. See, 52. So that is how, what I mean by the bidirectional, right? And that was the ping, right? So from R3 we did another translation which is the telnet. So for that, I need to see if on R3 I have telnet enabled. Show run section VTY. Should have something here. Yeah, I have Cisco 1 transport. No. Okay, I have this. So on R2, I should telnet on what IP address 53. So let's telnet 192.1.20. This should land me up on R3. Yeah, so Cisco 123, and if I see, I'm on R3, right? And I can say show users, but this will be the IP address of my R2 only. With the source, I'm not changing it. And likewise, I can do. I can go to R3 and go directly to telnet 2, provided that telnet is enabled on my 2, like this. Yeah, it is enabled. So Cisco 123. This is because of the bidirectional nature of the static. So if I see now, it should be .53 here. 192.1.20.53 will be the source. Now the source will be translated. Right? So you can see here, yeah, 53. So that is how it is, right? And if I did something wrong, I should say exit, and Control Shift 6X should work, yeah, and I should say exit. So I should be on R3. I was like actually on R3 already. So that is the two types of the NAT verifications we did. One was the ICMP, second was the telnet. So web I cannot do, but that is how it is. Okay, so hope you understood all these statements. But what you need to do is you need to go through all of it again and practice, and you will understand once you practice these concepts with your own, creating your own lab and try to go through all this.
Just a quick recap of the previous videos, right? Previous type of NATs actually. So the first NAT we did was the source NAT that you call, right? Source NAT, wherein what you do, or you can say dynamic NAT. What you do is you create a pool. You create a pool for the private. Right? You create a pool for the private address that you have in the object, right? You have an object which says subnet or host or range. So what we had is the object was a subnet of this, right, /24, and then we had a pool for the public address, and we had a pool from this range, say 192.1.20.0 to 50, something like that. So you had a pool like this. So whenever any IP from this subnet wanted to go outside, the ASA translated the source address, right? Source address to something from this range, and then it went outside. And this guy, this person on the internet or on the outside interface would see that that source is coming from this address range, right? So he had no issues with routing the reply back. So that is how, and this ASA would have a translation table, xlate. If you say show xlate, you will see that translation table there. That's how the ASA would keep track of the private and the public IP, or the translator IP address. That is one thing that we did. And then what we did is the static NAT. So static NAT was one-to-one. So for example, anybody from outside wanted to talk to this server in the inside, so we represented this this IP, say 192.168.3.3 on the outside with a public IP, say 192.1.20.25. So anybody who wanted to reach to this server, right? So maybe there was a web application here, or say telnet services were going on. So yeah, so that person in the public domain wanted to reach here, so he would go and hit this IP address, and once he will hit this IP address, the ASA would have 1-to-1 NAT, which would say anybody coming to 192.1.20.25, kindly change this to 1.192.168.3.3, right? So this was the issue. So this was the thing, right, with the static NAT. Now the destination NAT, as I said, is quite different in ASA as compared to other firewall. The destination NAT in ASA says if you translate the address of the remote user, yeah, or you translate the remote address, then it is called what? DNAT. Until now, what we were doing source NAT only, because we were only translating our source, that was this one. Local address, sorry. So source NAT is like local address. So whatever local address you had, you were translating 192.168.3.3 to some IP address, right? You were translating 10 series to some IP address. So these were your local IP addresses. So now what we can do is to demonstrate the, wait a second, just let me grab a pen. To demonstrate this, what I will do is I will say have a server here, okay, in the DMZ3. I will have a server, and then say for example this IP address 200. This is a server on the internet, and he's trying to reach to this guy, this server here. I mean, this is not the case in today's world, but this used to be there in the earlier networks, and I just want you to understand what DNAT is actually in ASA. I mean, people have confusion in this, but you after I mean going through this video will be clear with this. So the thing is, when this guy wants to reach this person, what is the first thing I need to do? I need to represent this person that is on .3, say, on the outside with some IP address. So I will translate this on the outside as 20.say50. So I will do a static NAT 1-to-1, which we did in the last video, right? So that is the first thing that I need to do. Done. Once I've done this, then what will happen? So for example, this guy with the source of 200.1.1.1 is trying to reach the destination of 192.1.20.50, right? So this is the packet that is coming from the internet. Once it hits the ASA translates this. So what ASA does is it keeps the source as it is, but it changes the translation to 192.168 according to the mapping that we have done, right? This thing. This is the packet after it traverses the ASA. Once it reaches this guy here, what he will do? He will change the source and destination, right? For the reply, the source would be himself, right? 192.168.3.3, and the destination would be 200.1.1.1. So now, in a normal scenario, this would have been possible, right? This I mean, traffic would be successful. But now the catch is that this machine over here has no routing capabilities. No routing capabilities. So what does that mean? Okay, that means this does not have any option of default gateway. No option of default gateway. That in turn means that this guy can only talk to the people on this segment only, right? So if I have n numbers of I mean machines here, so this server could talk to these people, but it cannot reach outside the network, because for that it needs a gateway, and that option is not there. I mean, it cannot route out of the. So how to, I mean, do this kind of, how to allow this kind of traffic? So for that, what I need to do is, so for example, now again I have this person which has the 200.1.1.1 IP, is again trying to reach this same IP of 1.20.50. But what I need to do on the ASA is I need to figure out a way where I can change the source, this is which is 200, right, to something from the local subnet dot 3 dot say 20. Now this guy when tries to reach 192.168.3.3, he would have no issues to replying back, right? Because it's in the same subnet. And then when the traffic reaches the ASA is going to again untranslate that and send the traffic back to this guy. So this is what actually is DNAT, because what you are doing, you are changing the remote address. A few things to note though is that the server that is trying to reach you should have a static IP, right? So you should know this. So this can be a scenario where you have a data center here and a data center here, right? And these data centers have machines they want to talk to each other. So you know the IP address of both the machines. Yeah. So that can be one scenario. So how you can do this? I mean, this is the whole what do you say, the theory, right? What about practicals? So wait a second, let me turn on my machine here. 1, 2, I need these 3 machines only, just in case I'll turn on this one as well. Okay, so what we will do, first of all, what we are going to do is I will take my notepad. First thing first, I need a NAT for my for the R3, right? For the R3, I need a NAT, one-to-one NAT, which says that this IP is available on the internet, right? So how do you do that? You say network object, yeah, network object, and you name that network, say DMZ3, yeah, or you can say server 3, kind of this, okay. Then you say the host. I mean, if it's that object is a host, right? You know that you can say subnet and ring. So host my IP 192.168.3.3. Then you say the NAT statement, NAT. So here it's very important now. So you have the high interface and the low interface, and then the low IP, right? I mean, so with the host you have the high IP address, high security level. So here you have the high interface, DMZ3. This is my high interface because this is 50. Outside is 100. Yeah. So high, then comma, then outside. That is the low one. Yeah. Then after that you say static, and then you say the low IP address 192.1.20.50. I'm representing this IP address on the outside as 50. So that is done. That is one of the things that we need to do. Second thing is the NATing, right? NATing for the source, actually. Yeah, the DNAT, the remote host, right? So that is what we need to do. For that, you need to understand one thing, which is the position of these interfaces is very important, and you need to understand this. Okay, let me grab my pen. So this outside and DMZ, right? These are very important in a sense. In a sense, when the firewall, right? When the firewall sees any traffic coming on this slot, the first slot, it understands he has to translate the source. And when he sees that any address hitting on the second slot, he has to change the destination. Again. So the first slot and the second slot, it matters a lot in a sense that the first slot, any traffic hitting on the first slot, for example, I said DMZ3. So now if the traffic is hitting on DMZ3, right, it will change the source. So for example, just imagine DMZ3 wants to go outside because we have the one-to-one NAT, right? One-to-one NAT is bidirectional, so DMZ3 can go outside. So just imagine DMZ3 is 192.168.3.3. Going to destination is say anything on the outside 192.1. say R2 20.2. Okay, So now just imagine the source and the destination. The source is this one, right? And it's coming on which interface? DMZ3. So the firewall will check, okay, DMZ3 is here. It's in the first slot, and the IP address is which one? 192.168.3.3, right? So I need to translate this. I need to translate the source of this IP address. So now source would become what? Source would become to the address that we have specified, 1.20.50, and destination is going to remain the same. Right? Destination is going to be the 192.1.20.2. So that is how the source and destination, I mean, slots matter a lot, because in the next statement, the statement that is going to help us to do the DNAT is very important. So how we are going to do the DNAT? Let me just go and give you this idea. So what we are going to do is we are going to say network object, say 199, host 199 or 199 host. Okay. Then you have the host statement. Okay, I'll take 200, right? I'll take 200. So I have the 200 here, and then the host is 200.1.1.1. Now imagine the traffic coming from outside. How does it look like? Source is 200.1.1.1 going to destination 192.1.20.50. What we need to change here so that this machine, which has no routing capabilities, can talk to it, because we have taken care of this one with this statement. Yeah, with this statement, it will be translated to 192.168.3.3. That is done. Now, because it's hitting the outside, right? Outside you can see, and the IP is this one, so it will understand that it has to translate it to the destination. Now the source, okay, the source is 201. We need to translate this to something, say from the inside 192.168.3.20. Yeah, so in this case the NAT statement is going to change, because I'm expecting the traffic to be hitting on the outside interface, right? So outside changes, I mean outside, when it's coming from the outside, I need to change the source. So just imagine which slot changes the source. Yeah, which slot? That is the first slot. So the NAT statement is going to slightly change here. So I'm expecting the traffic to hit on the outside, and I want to change the source. So I'll keep that interface on the first slot. That means I will change the source of that traffic. Yeah, going to the DMZ, and I am going to change this traffic to 192.168.3.20. So this is how it is going to be looking like. So I will demonstrate this on the lab that we will do. Let's go quickly on the lab, and then you will understand more better, right? Enable show run. I want to see if I have any NAT configs. I don't have NAT. Show run, if I see, do I have any running config at least? I think I have the IP addresses, right? Okay, let me see. Show IP, show interface IP brief. Yeah, I have the IP addresses. What about the routers? Can I ping my routers? Ping 192.1. Oh, okay, sorry, you are not able to see this. Yeah, 192.20.2 is my R2. Yeah, I'm able to ping that, and also 168.3.3 is my R3. And no, I'm not able to ping 192.168.3.3. So let me go here and see what is the issue. Okay, so it is not configured. So let's go into R3 and say, first thing first, I need to configure the interfaces, right? Okay, give it a second. And then before that, what I can do is I can go to ASA and I can just copy this thing. This is my static NAT that I need to, yeah, config T and done. I think I have done the okay object network. It's not network object, it's object network, sorry. Okay, so I'll copy this, paste it, and done. So this is my static NAT. So if I do here show NAT details, I should see the NAT here, right? It's in the, even if I say show xlate, it should be there because it's static. Okay, so first thing first, and I need a access list for this. Show run access list. If I see there is no access list, so I need to configure an access list. Access list say 101. Oh no, say out permit. So I'll test it with a telnet TCP from host 200.1.1. So this is specific, so I need to initiate the traffic from this host only. 200.1.1.1 to host 192.168.3.3 EQ telnet. So only telnet will be allowed. So I'll apply this access group out in interface outside. That is done. So now I need to configure R3 here. Yeah, enable config t host name R3 and I need to see the interface gig 0 0 interface gigabit 0 bar 0 no shut IP address 192.168.3.3 with the subnet mask of 24, right? 255.255.255.0. That is done. Exit. Now I need to see the telnet. I need to enable telnet. So I need to go to line VTY 0 through 4. I should say password Cisco and login and I need the transport input all. Yeah, done. That is done now. Now what I'll do is I'll not do the destination NAT as of now. I have the static NAT and I will debug this, debug IP packet details. Okay, I'll just debug. You just see the source of the packet that I have. This, if I had a routing, it would have been worked, right? Because in our past videos you have seen that. So now if I see show IP route, I don't have the route to reach outside my network. You don't see a default gateway, right? So let's see the traffic from R2. So if I go here and if I see, okay, enable show IP interface brief. If I see I have the show IP route. If I see, do I have any routes? I should need a route to reach that. No, because I don't need a route because I have that static, right? So if I go to telnet 192.1.20.50, I think I had on the ASA. If I see it's it's 50. So I need to hit 50 with the source of loopback. Which one? 200, right? Loopback 2. Once I do this, I need to go to R3 on the inside. So you can see that the source is still 200.1.1.1. That is why the traffic is not working. Hope guys you understand. Let me just explain to you again on my board here. So I'll clear this. What is happening to this traffic? So this traffic is generating from this R2 with a source of 200.1.1.1 and destination of my outside IP address of which I am representing the server, right? 20.50. So this is reaching the ASA, and ASA is doing its one-to-one NAT, static NAT, and it is changing the destination IP of 192.168.3.3. So this is now reaching this R3, and you can see that in the logs as well. So in R3 you can see that the source is 200.1.1.1 and the destination is himself, right? It's himself 3.3. But now if he tries to reply back, then it will not be possible because of you can see that somewhere you should see routing failed. Because of routing, there is no route, so it will fail. Yeah. So for that, what we need to do is we need to change the source of this packet, right? We need to make it something from the local subnet. So for that, I will again type the command that we had. We will do the NATing, the destination NATing that we need to do on ASA. So on ASA, I'll go, and if you see here, I will say object network 200. I should know the that is the only catch. I should know the remote server IP address, and then host. I will specify the host IP address of that person, and then I will say NAT, and then the statement. Okay, this is the statement. Now this is done. If I say show NAT details, yeah, you can see this is in the auto NAT. This is not the manual NAT. This is the auto NAT. Still auto NAT, right? So the static and the DNAT comes into auto NAT. So this is section 2, and manual NAT is section 1, which is which gets preference over these two NATs. We will see in the coming videos about the manual NAT. So inside auto NAT, this is your DNAT, right? So now let's do the same traffic again from the R2, right? Now I need to do this from the R2. So now when I try to do this, now when I go to R2, now you should see the source. Okay, I can see the source. Can you? Yeah, it's working. Wait a second. Yeah, I can see the source here. Now the source has been changed. So now this person can reply back to that traffic, right? It is not responding. I need to check on this, but still the NAT is successful. So we have the source as well as destination changed to this. Now I think the issue is with the router. I think I have not enabled the telnet completely. Let me check. And if I go on the ASA and check the logging, so if you go to the NAT only, let's check NAT. You will see the untranslation from DMZ to this server, right? Untranslated this. Yeah, and you can see, so this is untranslation, this is translation hits too. Yeah, and if you see logging on, let's do the logging on, say console 7 and logging enable. I want to check the same logs is the R2 replying back. So UDP request, no, this is not the one. This is the one. 2 hand going to 192.168.3.3. Yeah. And I need to see the show connection. If you see, say I have a connection from the outside. This is in the inside. This is, this shows both the translations. You can see, right? 200 is the public IP, and the inside IP is this one, and this is your inside IP on the telnet 23. Yeah, so let's do it again. And now I need to do a U all on this as well as on the R3 here. So these are the on the ASA I should not do U all. It should be routing failed for which one? 50. Oh yeah, I got it. So the issue here is I don't have a route on the ASA. So you see, yeah. So that is the issue. So I'll say no logging on, no logging console 7, no logging enable, and then I will say route outside 0.192.1.20.2. So route, ASA didn't know how to reach 200, right? The traffic has been initiated on 200. That is the issue here. And on R3 also I will go and debug and undebug this traffic. Now if we do the same thing again, they should work. Yeah. So if you do the show users here, it should be from the same subnet, that is 192.168 or 3.20 show users. That is the source, right? So that guy is trying to, the R3 doesn't know that it has been accessed from outside. It sees that it has been accessed from the local subnet. Yeah, it thinks somebody from this subnet is accessing the accessing him, right? So let us check that again on R2. So yeah, that is the IP address. Yeah, so that is it, guys. That this is the destination and that I was talking about in the ASA. Hope you understood the concept and whatever I demonstrated to you. If you have any questions, you can just comment in my video. And the best part is you can practice at home, it at home, and it will be more clear to you. Just go with me, follow along, and it should be simple and easy. In my last video, we have talked about the destination NAT, which is part of the auto NAT, and also we have seen dynamic NAT and also the static NAT. But there are two more NATs that are part of auto NAT as well, which is the dynamic PAT and the static PAT, which are which we are going to do in this video of today. So I'll cover those topics as well. But all these NATs are part of the, if you see the bigger picture, it's part of the section which is called auto NAT. You might have seen when I type show NAT details or show NAT, you will see sections. Okay, section 1, section 2, section 3. There are 3 sections: the manual, the manual policy section, the auto NAT, and the section 3. So these are like preferences. The manual NAT will get the first preference, then the auto NAT, then the section 3. Okay, so let's start with the this dynamic PAT, right? We'll go with dynamic PAT, then we'll go with static PAT, and I'll do the theory plus demonstration like I do. So let's get started. So first, what I have is the PAT. Let me grab my pen then. Okay, so till now what we did, until now we did the dynamic NAT, right? The dynamic NAT. So what did we do in the dynamic NAT is we had a pool of IP address which is 192.1.20.0 to 50. We had a range, almost 50 IP addresses, 50 public IP address, which is a kind of luxury in today's world, because this will cost you money. You have to register with IANA to get these IP addresses. And then what happened is, whatever IP address, whatever say devices from this range, they wanted to go, say for example source, then I'll keep destination. So this is the table that it kept. Kind of, let's take only 2. So for example, I have 10.1. Say 31 wanted to go to 8.8.8.8. Yeah, and then this guy also wanted to go, there was another user, let's say 50, wanted to go to, again say DNS. Yeah, and then what happened is, on the ASA it kept the translation table, and it translated the source to some IP from the pool, right? First come first serve base, first serve base, and destination remained the same. Likewise, the second guy who came got the next IP from the pool, right? So say 2 and 888. So this is how it was. It was tracking all these connections tables, right? Like this. So whenever anybody came, the return traffic came to say this, this was the source, it translated to this guy. And if this was the source, it got translated to this guy. And that is how the whole traffic used to flow. But you could easily run out of IP addresses in situations like this, because say you have a /24 here, then you have around 254 clients here. Then again, you might have multiple subnets, right? You can have the wireless subnet, you can have the wired subnet, you can have the sales subnet, you can have finance subnet, you can have so many subnets, right? So how to, I hope I have the spelling is correct. So how to go on with a situation like this? So the best way to handle this is the PAT. Let me just clear my window here. So let me just demonstrate to you how PAT works. So now again, just think we have this. Now PAT uses only one IP address. You can assign multiple IP address and have a fallback of PAT like this, but in general you have one IP address. You can use the external IP address as well. So what happens is now in this case you have the source, you have the destination as well. Now just imagine the same table. Okay, this 11.11. I hope 31. Just imagine this guy. Again, he's going to go out, and there is another guy 10.11.11 dot say 50. So these two people are going to destination 8.8.8.8.8. This is also going to 8.8.8.8. So apart from the source and the destination, the firewall keeps the source port and the destination port in this case. Yeah, so source port can be random. I mean, not can be, it is random, 1, 2, 3, 4, and say 5, 6, 9, 8, something like that. But destination port is dependent on the service that you are going to access. So for example, if you go for the DNS 53, for example, you're going to HTTP, yeah, web services, HTTP or 443. So that will always be application specific. Yeah, so that is the traffic that is trying to go from in to out. Now once it hits the ASA, now the table will be different. Now the translation will happen, and now you have the translated address of 192.1.20.10, say for example, that is the IP address of my interface here. So this person, this guy has been changed to this IP, plus it has the port number, plus the destination is same, and the destination port is also the sorry, this is 53, right? 53. Yeah, so this is how it looks like now. There's the source IP, source port, destination IP, and destination port. And then the next person that comes, again the same IP 10, but the port is 5698. And then you have the destination IP. Say in this case is the same destination IP but a different port. Yeah, so that is how the firewall keeps track of the source IP and the source port, destination IP, and the destination. So now imagine that the return traffic hits the firewall and it checks the source IP is 20.10. Yeah, I mean sorry, not 20.10. It will be the flip side. So source is 8888. Yeah, and the port is like 80. Then we'll check. Okay, I have this table, so I have to translate to this IP with this port. Yeah, so I mean after the ASA does the port translation, it can change the port source port as well, but it will keep track of that port. So if I change this port, what was the original port? If you check the connection table, it will have the original port, not the changed port. Okay, original port in the connection table, but in the translation table it will be the changed port. But in most cases this will be the same. Okay, so I mean there are these two are different. These two type of PATs have different terminologies. The first one, wherein you don't change the port, is called port forwarding. So you are not, I mean, changing the ports, you are just forwarding the ports. and wherein you change it, it's called the port translation. A simple example would be, you might have seen there is a server on the internet, or you have a server inside your DMZ, inside your corporate network, which is serving the web traffic on port 80, but you don't want people to know it's on the outside on port 80. So you tell your people, if you want to access this service, do one thing, do access this on a public IP address of 192.120.50, but the port will be 8080, and this will be then translated to 80 in the inside. So this is port translation. Okay, so let's do the dynamic pat first, and then we will do the static pat. The difference is dynamic pat has the ports dynamically assigned, right? But in static pat we do it manually. We say that this is the port which you should listen. As I said, this one, this is static port. So from the outside, if you want somebody to access your servers and you don't have much IP addresses, so you will use the port numbers to segregate the services. So for example, you have a web server, you will be listening on port 8080, and it will be listening on port 80 in the inside. And likewise, you have, or you can say 80 and 80, so that is port forwarding. Okay, then you may have a server which is listening for DNS, so say 5353, or maybe 5053, or you can have say telnet. Likewise, so that is your static pat. So let's start with the dynamic pat. Let me just clear this here. Okay, now so I should have the ASA here. Yeah, I have ASA, and then I should have the R1 here. So what we will do is we will do a pat. Okay, I need to initialize the I think ASA is configured. If I see show interface IP brief, yeah, it's there, and show NAT, if I see it's there. No, show access list, no, show run access list, if I see to have, no. So I have the IP address configured. That means I can ping the outside router 1.20.2. yeah, that is configured, so I don't have the inside. So let's do one thing. What I'll do is, so if I want to go from inside to outside on R2, say TCP, so I'll enable telnet on R2, but then I need because R2 will not be able to have a route back towards this R1, right? Because I will not set up a route there. So what will happen is it will be translated to the external IP address of the firewall, that is .10 192.1.20.10, and on R2, if you check, you will see that it is ASA's IP, that is SSH, telnetting into the R2. So yeah, so let's see how it goes. It's quite simple. It is like the okay, it's like the dynamic NAT that we did. Config T. So first of all, I'll change the host name to R1. Yeah, then interface gigabit. I think 0/0. No shut. IP address 10.11.11.1. 255.255.255 and 0. That is fine, and I should have a interface loop back say 10. Yeah, then IP address 10.10.10.1 with the subnet mask of /24. So that is there. Then I should have interface loop back 20 with an IP address of 10.20.20.1 255.255.255.255.255.0. Okay, then end and write, and if I see show IP interface brief on this router, I have these IP addresses configured. So if I try to ping from my router to the interface of the ASA, it should be successful because this is a to traffic. Yeah, and ICMP is allowed on the to traffic of the ASA. So now if I try to say on the R2, I'll go and enable telnet. On R2, if I go and enable telnet, okay, enable show run section VTY. I don't think I have telnet enabled. Yeah, it is there. It is there. So if I do a telnet from inside to outside, that should be allowed because that is the default behavior because TCP will be inspected, right? So telnet. Before that, I will do a on R2. I will do a debug IP packet details. Okay, so I'll do a telnet to 192.1.20.2. Before that, if I do this, this will not work because I don't have a route on the router. Show IP route. If I check, I don't have a default route, so it will be dropped on the router itself. So I'll configure a default route, IP route 0.0.0.0.0, 0.0.0.0.0, and I will configure ASA as the next hop. Okay, then that is done. Now then again, I need to go on the no for this traffic I don't need to, because my ASA knows the 192.120.2 subnet. So 190.1.20.2. So this will go to R2, but it will fail because R2 doesn't know how to reach 10.11.11.1 because I'm not doing NATing. So now let's do pat and let's see how this works. On this, Control X. Okay. Now on R1 I don't need to do anything. On the ASA I need to do the configuration. This is quite simple. So what you do is you configure the again the object network like we did. Object network, say inside, this is my LAN, inside LAN, enter, and then you say the subnet. So for me subnet is 10.11.11.0, and then you check the mask 255.255.255.0. So this is my host. Then you say the NAT statement again, the high and the low. So high is my inside, and then the low is my outside, right? And then you say dynamic, and then you can say the interface or the IP address. If I say interface, then I have to say the if I can just click enter here. Yeah, this will automatically take the outside interface. But what I can do also as well is I can have a static IP from the outside, from the public side. From the ISP, they can give me a single IP address or maybe a range of IP address. So I will just take this say 55. Okay, so what will happen when I configure interface or a single IP address? The ASA is smart enough that it knows that it has to do patting. Okay, so I'll do exit. Now if you see show xlate, you should see the you don't have the translations as of now because this is dynamic. Show NAT details. See, you have the details of the NAT, and again you can see this is the auto NAT section, right? Section number 2. So you can see you have this pool, this inside subnet, which will be translated to this IP address. Okay, so let's go and test the same telnet that was not working earlier. Now if I go here, so now you can see that this is receiving from the source of 55. Wait a second, encapsulation failed. Let me check what is the issue here. On the ASA, if I go, it should not be an AC issue. Show connection if I do here, and show isolate if I do here, I should have a NAT. So now you can see that I have a NAT from inside with this source, and it is going to outside on this PAT, right? So from outside, when you come inside, you will be translated to this IP address. So this is the reverse. But if you show con is not working. That is the issue, that my connection is not working. Let's again try this. Telnet to 1.20, and now it's open. Now I need to see the con. Now I can see the connection, and now I can see the original port numbers. 190. See, 23 is the telnet, right? And this is the source port number. Again, if you see isolate, it will change. It has changed, and is expecting this return traffic. I mean, from this guy, it's expecting the return traffic. So this is the translation. So this is the dynamic pool. PAT, dynamic PAT, wherein you can have multiple IP address from the inside going to the outside. Now let's just do this. If there was another subnet. Okay, so how do you do this? So you again go and say object network. So let's do this for this 10.10.10.1, right? Object network. So say, for example, this is my WLAN, wireless LAN, right? Yeah, wireless LAN, and I will say subnet 10.10.10.0.255.255.255.0. So this is my subnet, and then I'll say NAT, the high interface, which is my inside, to going to outside, and again dynamic, and then the IP address 192.1.20.55 this time. Again the same IP address, enter. Oh, that overlaps with the pool. Oh, I cannot do that in the dynamic. Yeah. So that is that. Done. I can do this on the interface level as well. Okay, so let's do this for the interface. So all the pool members, if I have anybody from this pool, and they will be able to go using 55, and another pool will be able to go using the external IP address. So let's go here, and on R1 now, if I do the same telnet but with the source of loopback 10 this time. So this is a different IP address now, trying to reach the external on R2. So if you see, this is my source. Wait a second. So what I need to do is I need to go and change the pool. So if I go here, exit, I've done some configurations. I mean, there are overlapping configurations here. So I can see interface WLAN and your inside LAN. That is fine. We do only show NAT, and then include NAT. So I have the dynamic and this one. Yeah, these are the two statements that I am looking forward to. So I have one which says inside LAN if going to the dynamic. So that is fine. That should be fine. I think I have my this already running. So who's that? This is 2.10 trying to reach. My ASA is continuously trying to reach this. So ASA, if I go here and clear connection con, session. Okay, I've done the clear connections here, but I don't know what traffic is. Let's stop this on here. I will do a you all. Okay, now let's see what traffic is this. IP address source is this, going to 2.10, and again this is R2 going to telnet. I don't know, maybe that traffic is continuously this is R1 to R2. I had an inside to outside R1, right? This one. So let's again do this one, and let's see the same traffic on ASA. Show xlate. If we see, I don't have for the 10. Yeah, I have this for 1010. So I have this for 1010. Earlier it was 1011. Now it's going outside on the 10 on the interface of the ASA 1010, and then I have the NAT details also. So you can see the translations going on this one, hits 2. Yeah, you can see. So that is how it's I mean working out. Yeah, I should do this once or twice. I don't know why this. So I need to check on the route, show route here. So do I have a route? No, I don't have a route. I mean, if you just imagine of this traffic, so this traffic, the second one that we are trying right now, is source of 10.10.10.1 going to 192.1.20.2. This is R2. So the port is 23. This will be some random port here. I'm not bothered about the port right now. But the translation that happens is 192.1.20.10 going to 192.1.20.2. So this router should not have any issues returning replying for this. And then when it gets the ASA knows, okay, ASA doesn't know about 10.10.10.1. So that is the issue there. We don't have a route for that. So let's clear it, and okay, clear, stop, and I will have a route for ASA. I will say a route inside 10.10.10.0 255.255.255.0 go to 10.11.11.1. So that is the route that we need for this traffic to function. So if I do this again, this is open, and I think the password is Cisco or Cisco 123 maybe. Yeah, if you check the show users, this will be the external interface, the .10. Yeah, and yeah, you can see .10. Yeah, you again go and check the show xlate. You'll see the .10s there, and if you see the show connection, you'll see the original ports there, 23 and 38350. So that is your dynamic path. Yeah, I mean, this video is getting longer and longer. I will cover the static path in another video. But dynamic path, what does it do? Just an overview again. Dynamic path allows multiple internal devices to go out to the internet using a single, single public IP. Yeah. The translation table uses randomly generated source port, and in the translation table to keep the translations. That is what the dynamic path is. So that's it for this video. Hope you understood the concept of dynamic path, and also the demonstration that I showed to you is somewhat understandable to you. But what I would recommend is to do as I do it. You set up this lab and follow me on to the command line, and and do it yourself, and that's how you will be having more clarity on it. And if you have any questions, just drop a comment in my video, and please don't forget to like, share, and subscribe to my channel as much as possible. And here, and let me log in and let me turn on the devices. So I need this, and this, so you can do this as well. So let's start with the concept of dynamic, static PAT. So static PAT is basically, so first of all, the difference between dynamic dynamic PAT and static PAT is just as same as static NAT and dynamic NAT, right? First of the difference that it has is, let me just grab my pen and quickly I can do that. Okay, so I have my pen here. So what happens is, in the dynamic PAT, your source gets translated, correct? And this is unidirectional, just as the dynamic NAT. Just imagine, instead of this R3, you have a switch here, okay, and then you have multiple servers here. You have multiple servers here, right? So the first one, say this is a web server, yeah. So this one, say, is a web server, and it's listening on port 80. And then say this one is a telnet server, listening on port 23. And say this one is a email server, listening on port 25, all TCP, right? Or you can have another one, say DNS, listening on port 3, UDP, TCP, both. Right? Okay, so this is a normal scenario in any organization, because they have servers in the LAN or on the DMZ, and I mean, people from outside, I mean, basically on the internet, they're continuously accessing these services, and then you don't have much, enough IP addresses to allocate dedicated IP address to each server. What you do instead is you do the static PAT, wherein you say they you have a single IP address 1.20.45, and all the servers can be reached with the same IP address but different ports. So if somebody wants to access the web server, he has to type in IP address and the port number. And say if someone has to access the telnet, he has to type in 192.1.20.45, but with a different port of, say, 23. And someone, if is trying to access the email service, he has to access the same IP address, yeah, 1.20.45, but then on the different port number. So what I'm doing here, these are called port forwarding. Okay, then also you have a concept of port translation, or you can say port redirection. In that case, what you do is you say 192.1.20.45 is the IP address, but in case you want to access DNS service, don't hit on 53. That is what everybody knows, well-known port. Hit on 5353. Then I will redirect this to the actual port that is, on which the server is listening. So this port that is on the outside is a listener for the ASA. Listener port is 5353, but the target port, is 53 on the actual server. So let's see how you do it right. So let me grab first of all, I hope this is clear for you guys. I mean, so you have a single IP address, different ports, and that's how you access all the services that are that are available on your DMZ. Let's clear this, and let me just grab a notepad so that I can just, okay, I have to close this one. Okay, so let's see how we are going to do this. So I don't have different servers here, so I'll just try with the telnet, and I will also set up the NAT statements for other services, but I cannot test those. I will just test the NAT telnet. Yeah, so first of all, what we need to do, you remember the NAT statement for the static NAT. Yeah, let me just quickly go through that. It was object network. So you create an object all the time, right? Object network, say this is some name. So let's create for the web. So this is site like web. Okay, then you say the host, because it is going to be only one web server. So this is going to be the actual IP address, the private IP address of the server, actual IP address. So in our case, let's say this is 3.11. Okay, let's have a requirement first. Okay, so that you will not be confused. So 192.168.3.11 is going to be patted to 192.1.20.45, but this is going to be serving the web server, yeah, on port number 80. Fine, and then I have another IP address of 192.168.3. This is the inside 3.3, and this is again going to be translated to the same IP address. Yeah, but it is going to be telnet this time, telnet server, which will be listening on port number 23. Yeah, and then I can have another 192.168.3 dot say 12, or yeah, say 12, and then I can have the same IP address again. That is the whole idea, but this one is serving a different service, right? That is email, that is on port number 25. And then I can have another one, 192.168.3 dot say 13. This is going to serve again the same IP address, but say DNS on port 53. Yeah, so that is the whole requirement. Now let's start with the first one. Okay, number one is like this. So I will have the object network this 11, right? Then I have the NAT statement, then the high and the low. High is my DMZ, so DMZ 3, and low is my outside. Okay, now here you don't have dynamic, you have static. Just as in the static NAT, you have the static statement. Then you have the IP address that you have, this one. Yeah, you go on and put it there. That is how we had in the static NAT. The difference now here is with the keyword of service. So here you specify service, and then the ports. So the port after service is the port that is on the actual server, that the server is listening on. That is the actual one, 80. And this one is going to the second port is the port on the outside. So if I want to if we want people to come on 8080, this is how you do it on the outside. Okay, so this will actually, let me grab the pen. So how it corresponds is, so this one goes, sorry, let me clear again. Okay, so this DMZ3 goes with this port, and let me grab a different color, and let's go for blue. and then this outside goes with this port. Hope this is clear to you, right? So that is how you configure the NAT. So that's done. Now we'll move on to the next one. I will keep it as 8080, and then I have the second one, which is the, I will just copy all of this just to be quick enough. Second one is for telnet. Okay, so I will name this as telnet. Yeah, and the IP address 3.3. This is what we are going to test. So this is going to be the same, just the service is going to be different, 23. So let's do a port redirection here. I will go on 2323. Okay, and then I have the third one, which is the email. Rest is same. Here I will do 25 and 25, and then I will do the fourth one, which is going to be my DNS. I actually don't need this, but just to, and also this one is email is 12 and this is 13 outside, and this is my DNS, so it is 53 and space 53. After this is done, you need access list, right? This is one part, and now you have to allow the traffic from on the outside interface. So I will have access list, say out, then I say permit TCP. So the first one is web, right? So I don't know the IP address which is going to come from the outside, from the internet. So I'll keep it any, but I know the IP address that it is going to hit. So I have the 192.168. This is going to be the actual IP address of the server, right? Host this, and then EQ TCP equivalent to 80. Likewise, I'm going to copy this. I have another one for the telnet. Again, that is TCP, but my host is 3.3 and equivalent to 23, right? And likewise for the fourth one, email, again TCP, but the actual server is going to be 12 and the port is going to be 25. And the last but not the least, the DNS is going to be 13.3 and this is going to be UDP, and this is 53. Yeah, so that is how it is. And also the access group, out, in, interface, outside. So that is the whole picture, how I have to configure my ASA in order to give access to the services. So let's try this on the ASA. I'll go quickly on the ASA. Grab the ASA. I think I have the enable show run NAT, no NAT, show run access list, no access list, fine. Now I need to see show interface IP brief. I have the IP addresses. Yeah, can I ping the outside 192.168 or no, not 192.168. 192.1.20.2 is my outside router, and I want to ping 192.168.3.3 is my DMZ3. So yeah, I need only these two. So let's start configuring the ASA. So first thing first, what I need to put is the these commands. Copy, and I'll put it there. So something is wrong. Yeah, let's see. Service, tab, or question mark. Oh, I have to give the port, sorry. TCP and the 80. Okay, let me just quickly grab here. After the service, I have to give the TCP or UDP mostly. That would be the only option here. Or you can have protocols as well. UDP. Okay, so that is one down. Now the second one, Second one is going to be the telnet. And this is overlapping with the existing pool. Do I have pool? Okay, let me just check. Show run NAT here. TCP telnet, TCP www static, this one. Okay, let it be like this, no issues. Let's go to 25, this one. Okay, no issues. Now it's the UDP. If I see show run NAT here, I have these in the running config. Now when I see show xlate, these should be there because this is static, right? It's not dynamic. It doesn't wait for the initiation of the traffic. It's there in the xlate table already. And also if you see the show NAT details, you will see this in the auto NAT section. Section number 2. This one. Yeah, you have all the NATs. 192.3.3 is going to be translated on this, and map port is 23. This is the outside port, right? And you can see the map port here, it's not changing. Yeah, for this only we have done the port redirection. So I'll go on the now after this I have to have the access list. I'll copy all the access lists, paste it here, and then the access group. Done. So that would be it. And now I have to go on the R3 and see I have the telnet enabled or not. Enable show run section VTY. Yeah, I have that enabled. Now let's go to R2 and quickly hit on the telnet 192.1.20.45 and see, and then I can do the port. Okay, port number directly like this. So you can see if you hit the question mark, you can see about the port number, this one. So you have to just specify the port number. So if I say 23, this is not going to work. If I go to ASA, I will check logging, enable logging console 7, and let's do the same thing again. And show NAT, if I do, should not see any translation. What I'm expecting is on the telnet part. So telnet is this one, and I'm expecting not to see any hits on this. So let's go again and do this, and I'm not seeing any hits. Yeah, let's go and change the Ctrl+Shift+6X. Let's change the port now. Ctrl+C, Ctrl+X. It's not working. It's not breaking. Let's wait for this traffic to break. Now let's go and do the 2323 here. And you can see as soon as I did this, you can see a connection has been built. Yeah, TCP connection 11 from R2 on this source port and going to R3 on port number C 23. So this did the redirection, and the actual port was this. Yeah, so show con, if you see, it should be there. Yeah, I have the con going from 22 to 23, right? And that is the connection table. But I need to see why this isn't working. This should be working. I should have a connection open on the port. Because there is no issue with the routing, because this is directly connected. I mean, 192.168.3.3 is directly connected to the ASA. But you can see the TCP connection is building up. Let's do a, I mean, on R3, let's do a debug. 03 is there. Debug IP packet details. And now from R3, this is my R3, R2. From R2, I'll do the same thing back, and let's see what is the. Okay, I see the problem. I don't have a route from R2, from R3, sorry. So yeah. So if I go here, config T, if I see do show IP interface, do show IP route, there will be no route. I mean, I should need a default route actually. IP route 0.0.0, 0.0.0, and I should point it to 192.168.3.10 on the interface of the ASA. Okay, and this should do it now. And I have done you all. Now, if I go here, this should be working. Yeah. So the password is Cisco. Yeah. And if I see show users, it is going to be the one and only 45. Let's see. I mean, okay. I'm not changing the source. Remember, I'm not changing the source in this case. So source is going to be the original, and I mean, what is going to change is for this guy, the destination for the R2. The R2, when he's going outside as a destination, he's hitting on the outside interface of 20.45, right? That is getting changed to inside 192.168.3.3, and also the port he's accessing on 23.23, which is getting redirected to 23. So yeah, that's it. I mean, that's the static PAT, as simple as that. Yeah. So hope you understood the difference between static NAT, static PAT, dynamic NAT, dynamic PAT. So I mean, the whole difference is the port numbers, right? And where you use them, where you use the dynamic NAT and dynamic PAT, where you use the static NAT and static PAT. Yeah. So that's it. We have covered a lot of topics related to Cisco ASA, and in this video we are going to cover the topic of manual NAT, or people call it policy NAT, or you can say twice NAT, double NAT, whatever you want to call it. So we are going to cover the manual NAT. So first of all, let me explain to you what manual NAT is. I mean, based on the sections, I mean, you have seen me talking about sections all these while, right? What are those? So first of all, we have, okay, let me grab let me just clear and cross this, and let me open my whiteboard. So until now we have covered in the NATing concept, what we have covered is we have covered the auto NAT only. Auto NAT. Under auto NAT, what we have covered is, first thing we covered the dynamic NAT. Yeah, wherein we created a pool and then NATed it to that, I mean, inside to that pool. And then we have covered the static NAT, one-to-one NATing. And then also we covered the destination NAT, DNAT, with respect to ASA. And then we covered the dynamic PAT, port address translation, and also the last video that was the static PAT. But if you talk about the larger perspective, these are all part of the auto NAT. Yeah, these are all part of the auto NAT. There's another section. This is actually section 2 when we check the NAT, you will see there is section 1, 2 like that, right? So this is section 2, and there is another section called section 1, which is the manual NAT, or you can say policy NAT, because this is based on policy, or even twice NAT, double NAT, whatever you want to call it. So this is section 1, which means when you have a what do you say, a rule that is part of section 1 as well as section 2, the preference will be given to section 1. Okay, preferred over all the sections. So that is the preference level of section 1, section 2, section 3. So how it is different? Well, just to give an idea, let me just grab and clear my. So as of now, what we have done, we have this ASA in the middle. Yes. Then we have the LAN, inside LAN here, right? So we have some subnets here, right? We have the 10.11.11 subnet. We have the 10.20.20 subnet. We have the 10.11 subnet in the inside, right? And then on the outside, what we have a router, and behind that router we have a couple of IP addresses, which are the one is the that I'll be using is the 199.111/32, and we have 200.111/32. So now what we will do, in the previous videos, what we have done, we have created a subnet object here, object network, and then object network say inside, right? Then we said subnet, then subnet we I mean 255, right? 255.255.255.0. This is the subnet that we entered, and then we went and said NAT, and then your inside to outside. Yeah, then either static, either dynamic. So let's say we are doing dynamic PAT, say we did dynamic, and then the interface or the IP address. Yeah, interface. So this will PAT all the IP address to this interface, which is 192.1.20.10 in our case. That is the firewall's IP address. So whenever a host from this range tries to go to outside, from inside to outside, his source will be translated to this IP address. Yeah. So in all the cases, it was like this only. Almost the dynamic NAT, the static NAT, the dynamic PAT, static PAT, it was all like this. If source is from a zone, or from if it's a host, or or a subnet or a range, and from a particular zone going to particular zone, then translate the source. Yeah, just the case of DNAT was different. Apart from that, every natting was working like this. But what if we have a requirement wherein if this 10.11.11.1 is trying to go, source is this, and the destination is say 199.1.1.1, you have to translate the source to say a particular IP address of 1.20.55. And if the destination is 200.1.1.1, then you have to translate this to a different IP, say 60. This cannot be done using the auto NAT. For that, you have to use the manual NAT, because this is like a policy. So that's why you call it as policy NAT as well. This is simple, but you can also use the same manual NAT to do translation of the destination as well. When you do that, it is called the twice NAT, or double NAT, twice or double NAT. Yeah, you can also do translation based on services. What do I mean by that? You can also have policies like if this pool is trying to go from inside to outside using telnet, then translate to a certain IP address. If the same host again going to inside to outside, but this time SSH, then a different IP address. HTTP, different IP address. So that is what manual NAT is, and it is very powerful. And mostly this, I mean, you will see the use cases wherein I will say, so say for example, you have a firewall here, ASA, right? And behind that you have this LAN, and then you are connected to the internet, and then you have a branch router here, you have a branch office, and behind that branch office you have again a LAN. But just think of this, if you have this same segment, LAN segment on both sides, and then you have the IPsec side-to-side tunnel there. Now your interesting traffic, the ACL, how would it look like? It's going from 10.1.1.1 to 10.1.1.1, right? So this is what the manual NAT can help you with. Yeah. So you can have a policy saying if 10.1.1.10 is going to 10.1.1.0, translate the source, translate the destination. Yeah, let's see this in action, how to configure this and how it works. Yeah, let me close this, and I will just turn on these routers because I need only R2, ASA, and the R1. So here we will be doing all this. So let me grab my R1, have my R2, I have my ASA. So what we will do, the plan here is, okay, the plan here is we will have a dynamic path on this subnet, and we will path this to the interface, this one. And when we do a telnet, say we do a telnet from R1, and the telnet source would be first 10.1.11.11.11.1. If I don't specify the source, then the source is this thing, and the destination is 199.1.1.1. And okay, sorry, destination is this. So what will happen in this case? Normal behavior is 20.10. It will be translated to this IP address, and this R2 will see that the firewall interface is trying to access, and there's no issue with the routing, so it will reply back, and this connection will be possible because of TCP. It was because it's initiated from the inside, while as the outside to inside you need a rule that you know, that is basic stuff. But that is simple, right? Even though if I do the same thing with a 200.111, this should work. We're using the same IP address as the source, right? Netting. But on top of that, I will have a, even if you have the source as 192.1.22, the result would be, outcome would be same, right? The same IP address. But now what I will do, if I will create a policy that says if the source is 10.1.11.11.1 going to 199.1.1.1, then change the source address to 192.1.20.60. And if the destination is say 200.1.1.1, then change the source to 192.1.20.61. Yeah, so that is the requirement. That is what we are going to do here, and that will suffice you as. And also, I mean, when you have the dynamic NAT here, and then you will see that the preference is given to the static manual NAT here. Okay, so that is clear. Now let's go to our ASA here. I want to check ASA. Yeah, enable. I need to check first of all the IP addresses, show interface IP brief. Yeah, interface is okay. Let me ping on to the both sides. This is the R2 and R1 is 10.11.11.1. 10.11.11.1. That is working. Now I need to check the route. So this should have route for 199. So that is through route outside. Okay, I have to go to the config mode or route outside. Sorry, outside 199.1.1.1, and this is going to be the net mask. Okay, this is /32. So the next hop would be the R2's IP address, and the same for 200. Yeah, and yeah, that's it. So let's see how this works. So first of all, I need to go to R1 and see if R1 has the IP addresses configured. Enable show IP interface brief. It has the IP addresses, and I know I can ping 10.11.11. Sorry, the interface of the ASA, that is 10. Should be able, because yeah. So that is fine, and I need to have a route here. Yeah, I have a route, a default route that I need. On R2, I again need the enable show IP interface brief. Hopefully I have the loopbacks and all. Yeah, loopback 1, loopback 2, and loopback 0 as well. And I need the I don't need a route here. No, I don't require a route, but I need the telnet here. Show run section VTY. It should be there. Yeah, it is there. Good enough. So now how to do this? So first of all, let's do the let me grab a notepad. It will be easier for you guys. So first of all, how do we do the object NAT for how do we do the dynamic path? So I need the object network, and the object network is inside 10.11.11.0. Then I say subnet 10.11.11.0 with a subnet mask of 24. Yeah. Then I say NAT inside, going to outside, then I say dynamic, and then the interface. Yeah, this should be sufficient for my traffic to go from inside to outside. If I do a telnet right now, obviously this will not work. 1.20.2, this will not work because there is no NATing, and that's why R2 has no reachability for the inside network 10.11.11, even though R2 is receiving the packet, right? You know this much. So let's go to ASA now and paste this config. Once I go here and I see show NAT details, now you see auto NAT section 2. You don't see section 1. You will see it shortly, but when you see show xlate, there is going to be no xlate because this is dynamic. It's not a static one. Once you initiate the traffic, then only you will see the. Now if I do this and it is working now, if I go to ASA and check the xlate, I should have my xlate, which is translating this inside user, which is coming on this with the source port of this one, and it's getting translated to this IP address, which is the firewall's external IP address, and the same port. It's not changing the port. I'll go here Cisco 123, just in case you are not convinced. I'll check do a show user on R2 and see the IP address that is accessing it, and it should be 20.10. Yeah, well enough. Now what I want to do, in this case, if I do anything, if I from here I say exit and I did a telnet to this one, or now I'll do a telnet to this IP address again, there will be no change in the source. Same 20.10 will be there. You'll be seeing that because this is a dynamic NAT. No, dynamic PAT. Even if you do NAT, you would see something different. Same, because of the cache, right? If you go 200 1.1.1, 1, 2, 3, and I see show users. So again, the source IP address should be 20.10, the firewall's IP address. So now I want this policy wherein if my R1 is going to say 200 or 199, it should be translated to 60, and if it's going to 200, it should be translated to 62 or 61. So how to do it? So with this NATing, you need objects for everything. You cannot have IP addresses like from here. If we say dynamic and an IP address, you can type that, but here you need objects for every IP address that you are using. So in our case, we will be using IP address this one, for which we already have the object. We don't need that object. Then we'll be using these two IP addresses, then also the translated IP address, both of them, right? We need the 60 and 61. So let's start with object network. Object network, I'll say host 199. Yeah, then I'll say host 199.1.1.1, and then again I will say exit object network host 200 1.1.1 exit. I need a translated one, so again object network translated for one. So if this goes to 199, this should be translated to say host 192.1.20.60. yeah, exit, and I will again copy this, and this one, it should be 200, and this should be 61. Yeah, so we need all these objects. Okay, good enough. I'll go and paste this to my ASA. If you check show run objects, you should see all the objects. So I have the inside net, I have this, everything. So I need one for this object as well. If I say object network R1, yeah, and the host IP should be 10.11.11.1. So this is one more that I need. Copy this here. Object network R1 host 10.11.11.1. yeah, after that I need the NAT statement. But for manual NAT, you don't do the NATing inside the object, so that's why you call the auto NAT as well as auto NAT also as object NAT, because you do the NATing inside the object. But here it's under the global configuration. You can see if I go to an object like this and I say NAT and I hit a question mark, you will see two options, one for the object NAT, one for the manual NAT. But if I go exit, it shows both the options here. But if I type NAT here and hit question mark, it shows only the options for your manual NAT. So how do you do this? So again, you say inside, going to outside, then you say source, and then you have a static. You can also have dynamic, but I'm doing this static. Now you need this time, you need the real source. This is your private IP. So I have R1. Now R1 should be translated to what? Yeah, so we have the let's do the 199. So it should be translated to this X199. yeah, when the destination is static, and now it will ask for the mapped destination, that is your translated destination. Yeah, so that is your host, this one, and again the same, because I'm not changing the destination. So hit enter. Yeah, so I will do the same for for the other one, but that should be 200 destination static H200 H200. Yeah, when I do the show NAT here, Now you will see the section 1, and inside section 1 you have already two manual NATs defined. So if I see show NAT details, it will show the same thing, but I'll show the check the xlate. For xlate, I already have this getting translated to this when 199 is going to 199. That means totally when this inside is going to 199.111, it will be translated to this, and when this guy is going to this 200, it will translate to 61. Let's check that. So I can go to R1, and what I can do is I can tell it first of all 199.1.1.1. So you had seen before this I did 199 like this or 200, and it was this external IP address. So now in this case, if I try the same, let's wait for a while. It will take some time. Hopefully, I have to try it again. So yeah, let's wait for this to fail first. And also we can do a show debug transactions, I think. Something TCP, I think TCP transactions, yeah. TCP. Do I have debug TCP transactions? TCP sessions, I think. There was a command, I don't know. I don't remember it right now, but yeah, let me do this and Cisco 123. Anyways, we can verify using this as well. So now when I go as, to this source of 199, it has been changed to 60. While as if I exit and go to 200, this will be translated to 61. But if I go to 20.2, which is router R2, it will be same, the dynamic path that will be there, because there is no manual NAT statement for 192.120.2. yeah, so it will fail for the first time, and then in the second time it will be. So if you check here again, say show NAT details, you will see the hits on. So you can see the hits. Okay, let me try this again, and this is working. Cisco 123, and the user should be 61. Let's wait for this. Yeah, well enough. Exit, and let me just do this once again so that you see. So on this, the user will be coming from the .10 IP address of the firewall. This is hitting the dynamic path rule, not any manual NAT rule. Yeah. So yeah, so that was it, guys. And you need to, this is just a single implementation of your manual NAT. There are multiple implementations of manual NAT. You need to, study the case studies from Cisco. That will help you understand this manual NAT more, and also different case studies wherein you use this manual NAT to achieve a lot of things which will not be, which you will not be able to do it using the auto NAT. Yeah. Today's topic is, as you can see on my screen, transparent firewall. So what is transparent firewall? Let me grab my pen and let's begin. So until now, what we did was routed mode of the firewall. The ASA firewall, wherein the firewall was doing the routing as well. Yeah. So by default, the ASA, by default, ASA is also a router, which means it can do routing and it can support the routing protocols, yeah, which we have seen seen in our previous videos, like configuring RAP, EIGRP, OSPF on the ASA, right? So, and apart from that, also it supports the IP protocol, yeah. So that's the routed mode. What is the transparent mode, or you can say L2 mode? So you can come up with a requirement where you have a company where you want to install a firewall, but you don't want to change the IP scheme, yeah, because you already have the routing set up between the routers or the L3s. You have the SPIs here on your distribution switch, you have the edge router. So now you don't want to, I mean, change all of this, but you do want a firewall in between. So what you can do is you can slide in this firewall between that edge router and the switch and the L3 or the distribution switch, you can say. But that is one, I mean, case where you can use this ASA as an L2 firewall. But there is another case where you have the ISP. So you have the ISP's router is there. So you have the ISP. And then you have your edge router here, the company's edge router. And then you want to place a firewall here to check the, I mean, the traffic that is coming from the ISP. Yeah, but then, I mean, because the firewall doesn't support MPLS and all, so what you do is you have the MPLS running between the edge router and the ISP, but in between you have placed this firewall as an L2 mode, and it can inspect the traffic. So that is another case where you will use the ASA. And I mean, I've not seen this that much, but you can have say a server farm wherein you have a lot of servers, and then you have the clients here, and then you place the firewall in between. So that can be again a case like in you have the DMZ side, right? But I mean, that should not, as I said, I've not seen this case as much as, I mean, until now, that because this will be on the same subnet. I mean, these PCs will be on the same subnet. So you have a 10.1.1.0/24 subnet. So these guys here will also be on the same subnet. But yeah, they can be on different VLANs. They can be on different VLANs. That this can be also a scenario. But I mean, people don't understand why on different VLANs. That is again, I mean, totally dependent on the type of connectivity you have. So for example, you have a switch here. So for example, this kind of setup, right? You have R1, you have R2, you have R3, sorry, R2 and R3, and then an ASA. So for example, you have a switch here wherein you have connected R1, R2, R3, and then you have the ASA here with 2 ports. So this is the physical topology. Now you have to make the logical topology like this from I mean, from this physical topology. How do you do this? Because if you say, if you place this and this and this, or every I mean port on the same VLAN, say VLAN 10, then the purpose of ASA will not be I mean there, right? Because the routers, because they are part of the same subnet, because a VLAN is equal to one subnet, right? That's what we have known until now. So if this guy wants to reach to the same subnet, so it will not go to the ASA, it will directly go to the R1 or say R2. So say for example this is R1 and R2 and R3. So that purpose of being there, ASA being there is not met. So in this case, what you do is, let me grab okay. So what you do is you keep the, so for example R1, right? R1, and say this is gig 0 by 0, you keep it in one VLAN, and then rest of them you keep in a different VLAN, say VLAN 20. Okay, red are in VLAN 10, green is in VLAN 20. So for example, when R1 tries to speak to the R2, so he has to send the packet to the ASA port, because it's the only port that is in the same VLAN, right? And that's how this port has learned the MAC address of R2 and R3, and then ASA, via ASA the traffic will transfer to the other port, and then from there it will go to the particular port where you want to send the traffic. So that is how you that is why you have different VLANs when you are doing the transparent firewall. So you will see a VLAN here, say VLAN 70, and you will see a VLAN here, VLAN 71, like this. You might have seen this, or you may see it in future if you have not seen it. So don't be confused why. This is the reason why. But in my case, I have physical connectivity and my logical connectivity are same, so I don't have any issues with this. So that's how it is. So let me just clear this, and let's see how to configure this and what is the difference config wise and also the feature wise. So let's start the ASA. Let's start all the nodes here. And as I said, by default, the ASA is in routed mode. And to check that, you have the command, which is the show interface command. So let me grab a notepad for you guys out there. So you can also, start. Let me just increase the font. You can also take notes like this. So as I said, by default, the ASA is in routed mode. Yeah, so if you have routed mode, that means you can't do L2, right? So you are doing the L3 mode, as you can say. Routed mode is also L3 mode. Now to change the firewall mode to transparent, you have to use the command which is firewall transparent. Firewall transparent. But be cautious. Once you enter this command and hit enter, there will be no prompts, and what will happen? The running config of the firewall will be blown up. So be very cautious about this command. So let me just show you how this happens. So if I have no, wait a second, this is booting up. So as I said, once you enter this command, the running config will be blown away without any prompt or confirmation. So be cautious about this thing. But say in case you did this, the startup config will not be blown. So you just need to do what? You need to reboot without saving the config. That's how you can restore to your startup config. But the running config is gone once you type this command. So let's see. Enable. I'll say show firewall. This will show me the mode, and you can see as this is stating as mode is router, that means routed, that means L3. Now let's do one thing. I'll go to config T and I'll say host name ASA. So you can see my host name is ASA. So now when I do the command firewall transparent and I hit enter, you can see the host name has been changed to Cisco ASA, and now this is completely L2 now, and my running config has been blown. Yeah, so for example, you did this, what you have to do is reboot or reload, reload, and don't save the system config here. Say no and then enter, and you will be back with your startup config, but your running config is gone. Okay, so hope you understood this, right? So my topic was to change it to the L2 mode. So I'll do it once again, once it is back booted back. So until then, what we will do is we will go to the routers. R1, I have R1, R2, R3. I will config these routers. So let's start with the R1, right? R1 enable config T. That'll say host name R1. Host name R1, and what I need the domain, no domain lookup here, because what happens is you sometimes end up typing the wrong commands and then you have to wait like this, no IP domain lookup. And what I want is the interface gig 0 by 0 on all the routers, right? Interface gigabit 0 by 0, and I'll say no shut. IP address is 192.1.10.1 255.255.255.0. So I've done this, and now I need the interface loopback 1 or say 0, IP address 1.1.1.1 255.255.255.0. Then I will go and say a router. I'll be running router rip here. So version 2, no auto summary. Yeah, I'll be advertising network 192.1.10.0, and I don't need to specify the subnet marks anyways. This is class C, so, and also network 1.0.0.0. So that is what I need to do on my R1. So then, okay, let me go to R1. I will copy this, and also I need the telnet. So I need to go to, I'll say exit, and then line VTY 0 through 4. Password is Cisco. I'll say login. I will say transport input all. So that is done. Now what I need is the same configs for R2 as well as R3. R2. Okay, let me just grab all of this config and go to R1. Copy. No, I need R2 as well here. No, and R3 as well here. So all the routers are here. I need to go to R1. Okay. So now that I think ASA will be back. Yeah. So now I'll say enable and I'll say show firewall here. Yeah, it's in router mode. Now let's go and do the firewall mode. Firewall is like transparent, and done. And if I see right now, so firewall should be transparent. Yeah, so I don't need to reboot, but yeah. So let's go to R1. This is my R1, right? Enable. I can go and copy and paste. So everything went well, right? And I need to go to now R2. I'll paste it here. So I have to change the host name. Then I have to change the IP, this one as well. Then this one, this is fine. Version 2 is fine. Everything is fine. So this is for R2. And let me go to R2 here, this one. Enable R2 and done. That is done. Now I have R3 as well. Pasted. R3 is .3 and R3 here, and the loop back, change it to 3333, and this is fine, and this is 3, because okay, I don't need the subnet mask because anyways this is like class S. Okay, let's copy and paste back this one, and need to go to R3 this time. Yeah, so and right. So now if I see R1 and R1, so R2 and R3, right, they will be they are in the same segment, so they are able to reach each other, and also the updates, right, the RIP updates are shared between them, so they have the routing updates. So if you see show IP route here, you will see the RIP routes. So you can see the RIP routes here, and also on R3, if you go the show IP route here, you will see the RIP routes, and also the reachability will be there because this is on the same LAN, so no issues in reaching the subnets. But the problem is with your R1, and let's see how to solve that. First of all, we have the ASA, which is in transparent mode. So to configure the ASA in transparent mode, first thing is you have to change the mode, right? You already did change the mode to transparent firewall. So let's go here. So number 1, change the mode to transparent, okay, by using the command firewall transparent. That's what you did. So that was one thing. Okay, then second is configure the interfaces. Configure the interfaces of the ASA. But now, as you know, this is L2, so so you will not have IP address on the interfaces. So on this, just imagine this as a switch, but on the switch port, what you have as an interface, what you have the VLAN number. But here, in case of ASA, you don't have the VLAN number. But instead of VLANs, when you configure an ASA in a routed mode, what you have the name if that is still there. So if I go to my ASA, I have two interfaces, the gig 00 and 01. So if I go to my interface gig 00, which is my outside, so I will have the name if with the outside, and also I will have the security level, which will be by default 0. Just to show you guys, I'm typing it in, and then I'll say no shut. So this is what you have. And also the same for interface G01 if I go, but my name if would be inside, and also the security level is 100 for this one, and no shit. This is what you already had apart from the IP address in the routed mode. So it is same. Next, what you have to configure a bridge group. So you have to bridge these two interfaces. Okay, so you have to bridge this one and this one using same bridge ID. People who know Palo Alto can, compare this with the virtual wire. Yeah, so something similar to this is virtual wire, and you have to configure this bridge ID on both the interfaces, and that is how you bind these two interfaces. So you can go to the interface and say bridge group, and just have a number, say let's say 11 or 10, and same number should be on the other interface as well. So that's all that you have to configure on the ASA. Yeah, and after that what you have to configure is, so as of now the ASA has two interfaces with name ifs, security levels. Okay, just let's go and put this on the ASA. If I go here, okay, if I say exit and say show interface IP brief, you can see I don't have any IP addresses, but if I say show name if, I can see that the security level and the name ifs are configured. Okay, but as of now my firewall will not be able to understand the IP protocol stack. To make it understand the IP protocol stack, you have to configure what is called a BVI. BVI stands for Bridged Virtual Interface. Some people do compare this with the switch virtual interface, kind of similar, but this does not do the data forwarding. Okay, this BVI doesn't do the data forward, but you can use the BVI for management purpose. You can use to telnet to this box on that BVI interface IP address. So this BVI IP interface IP should be from the same subnet, this subnet. The subnet you have here, 192.1.10.0/24. So we will have .10 as the BVI. Yeah. Okay, so let me clear the diagram here. So now how do you do that? You go and say interface BVI, and then you type the same number, the number that we used in the bridge virtual group, 10, and then just the IP address. That's it. IP address 192.1.10. Okay, 10.10. Yeah, you can just hit enter because this is class C, so that is fine. And no shut is not required, but yeah, I just not required. So if I go here and say show IP, I should see the management IP 10.10. You can enable this telnet as well. Telnet 192.1.10.0 255.255.255.0, but you have to say inside, because from outside telnet will not be allowed, right? Inside. And now you can go to okay, I have to configure the password here, Cisco, for the telnet, right? Now if I go to R2 and I can telnet to ASA now on that particular IP, management IP, telnet 192.1.10.10. So I'll be able to telnet to the ASA using that, and my password is Cisco, I think. Yeah, you can see now. So that is the BVI concept, but BVI helps the ASA understand the IP protocol stack as well. So now that I have the ASA here, now do you think the routing updates, right? You have the routing updates from R1. Okay, from R1 from R2 to R1, the routing updates, RIP updates, right, are flowing on 224.0.0.9. So that is what you see, because this is UDP, right? UDP 520. Do you think this is high side and this is low? Do you think this traffic will be, I know the return traffic will not be allowed. What about the inside to outside traffic? Because this is UDP, and UDP is inspected by default. So do you think this packet is reaching R1? Yeah, let's see on R1 and debug the IP packets on R1 and see, are we seeing any RIP updates? Enable show IP route. If you do, you will not be able to see any RIP routes here. But if you see debug IP packet details here and wait for 30 seconds, you will not see anything. Why? I will just explain this to you. So the concept is, wait a second, let me see. This is the this is what it is sending. Source, you can see 1.1.1, right? This is not what he is receiving. It's not receiving, it's sending from its interface every 30 seconds, but it's not receiving from, say, 10.2 or 10.3. Yeah, so what you need to do for this, you need ACLs, as you would do in a routed ASA. You would need ACLs. But again, the thing is, why the UDP is not going from inside to outside? So that rule, that particular rule, which we studied in the initial classes, right? That is only applicable to unicast traffic. Okay, so to allow the multicast traffic, you need what? To allow multicast traffic, you need ACLs. ACLs on outside as well as inside interface. Understood, people? Yeah. So you need to specify ACL on inside as well as outside. Outside was clear, but here, because this is not a unicast traffic, you have to apply ACL on the inside. But be very careful, because on every ACL you have the explicit deny. So what people do is they allow the RIP updates from inside to outside, but forget to allow the rest of the traffic. So what happens is, even though the RIP updates are going outside, but all other traffic is denied by the explicit deny statement, which is at the end of every ACL. So instead of, you can do it granularly, saying the UDP 520 from this source to 224.0.0.9 EQ 520 and allow, right? And then you can say allow TCP any and UDP any. That's how the firewall behaves. But it's better to allow TCP any, or you can say IP any in this case, from inside to outside. But from outside to inside, you can be more granular. So I will go to R1 and say you all and debug all. So let's go into the ASA. So this is your third part is configure the BVI. How to do that? Interface BVI, then number 10, then IP address 192.1.10.10. Yeah, 255.255.250 also, or you can hit enter there. So that is what you do. Then what I did is I enabled telnet from 192.1.10.0 255.255.250, and I said inside. That's how. Before that I said pass wd Cisco. So yeah, then I enable telnet, and that's how you are able to telnet to the ASA. Now I want the routing updates from inside to outside. So what I'll do is I'll go and create an access list from inside, say access list in permit IP any from inside, and I'll say access list, oh sorry, access group in interface inside. So that is what I need to go and configure here, and you will see that the rep updates will be reaching to the R1. Change the host name ASA. So if you go here and see now, debug IP packet details. After some time, you'll see the rep updates from R2 and R3 coming to R1. Let's wait. So you can see this is R2, and let me just quickly go and view all. So you can see R2. So this is the R2, and also R3 will the R3 updates will be reaching because I stopped the debug, so we were not able to see that. So now if I go and see show IP route here, I should see the updates from 2 and 3. But what about 2 and 3? They will not be getting the updates from 1. Yeah, because I have to allow that traffic from outside to inside. So for that, I will have to specify a separate access list, but that would be specific access list out permit UDP from any to, or you can say from host 192.1.10.1 to host 224.0.0.9 EQ 520. This is RIP, right? I will copy this, and the same for our no, I need only this one. This will suffice for both of the routers, right? Access group out in interface outside. So that is what I need. And if I go here on R2, yeah, I have to specify on ASA here, and done. Now after some time, I'll be able to see the 1.1.1 reaching on R2 and R3 as well. Let's wait for some time. And before that, I want to see, you can see the 1.1.1 here. And if I go to R3 also, enable show IP route. You can see 1.1.1 here as well. So now what I want to ping from R1 or from R2 to R3. For that also I need a access list in permit ICMP any as of now I'll do. So I've enabled ICMP here as well as access list permit. Okay, sorry, access list out permit ICMP from host 192.1.10.1 to any, I will say. So now if I go to R3 and ping 192.1.10.1, this should be successful. And from R2 as well, this is R3. Oh, this is R2, yeah. And I can go and ping 192.1.10.1. This is through the firewall. So from return from R1 also that should work. 192.1.10.2, yeah, that is working, and also 10.3. So that is how you configure the transparent firewall, and that is how the transparent firewall works. Yeah. Few more things in the transparent firewall section. So that's why I'm doing this course lesson. Sorry. So now what we went through in the last lesson was that we now know that we can place the ASA in a mode called L2 or transparent, wherein you don't need to change the IP address schema of your network, and you can still be running your routing protocols, and just with the edge and the the distribution or whatever your type of design is, and the routing will not be affected by placing a firewall into your network in an inline mode, or you can say an L2 mode. So that is how it is. And we came to know about the the ACLs, right? They are working perfectly fine. Now today what I want to talk about is a type of ACL called ether type. And for those who don't know about ether type, it's an ACL, but it's an L2 ACL. You can just understand like that. Okay, let me clear this again. So to understand the ether type ACL, you need to go a little bit back to the basics, and the basics would be your TCP IP model. So in the TCP IP model, what you have at the top is the application layer, right? So you have the app layer, and then you have the transport layer. Yeah. And then after the transport, you have which layer? You have the network layer. That's right, network layer. And then after the network layer, you have again layer 2, which is called the data layer. And then at the last, you have the physical layer. So now just imagine every layer encapsulates and de-encapsulates, right? There is encap and de-encapsulation on every layer. Yeah, de-encap. So when the packet is moving upwards, it's encapsulation. When the packet is received, it's de-encapsulated. So how, my question is, how do the data layer knows where, what type of, protocol I have to send it to the network layer? Or how does network layer know which transport layer I need to send it to? How does transport layer know which application I need to forward this packet to? So each layer has their own header, and each header has that special information which tells the transport layer to which application it needs to send the packet to. So for the transport layer, you have a field called port numbers, right, which tells the transport layer where, to which application you need to forward this to. So for example, port 80, it will be sent to HTTP. Port 53, application DNS, like that. 23, telnet. 22, SSH. So that is the thing at transport layer. So now at network layer, what is the thing that tells the network layer to send to which of the transport layer, right? At the transport layer, you have mostly two protocols residing. You have the TCP and the IP. Oh, I just said the word, and you might have figured it out. So in the IP header, you have a field called protocol, and that protocol will decide to which transport layer I have to send the packet to. Mostly you have TCP and IP. So back of the head, if I remember, TCP is protocol number 6 and UDP is protocol number 70. So this is not IP, this is UDP. If that is wrong, please correct it. Check it, and and then from the data, how the data layer knows to which network layer I have to send it to. In the data layer, you have the MAC layer and the logical LLC layer and logical unit. So there in the header, you have a field called ether type. But mostly nowadays you have the, you had many
type of IP protocols. I mean, protocols rising on network. One was IP. Then you had Apple Talk. You have, I mean, more of that. If you go to a document from Cisco, this is the document. If you see here, you can see you have these non-IP traffics, IPX, BPDUs, MPLS, and all those stuff. So to control those traffic, you have to use the ether type. So for example, the BPDUs, right? The BPDUs are allowed by default on in an L2 firewall, but CDP is blocked. CDP blocked. Okay, so we will just allow CDP using the ether type ACL, and we'll check on R1 and R2. Likewise, you can allow MPLS, and also, I mean, by default the IP, which is 0x0800, is allowed for your information. You can see, you must have seen yesterday, right? We were able to communicate between R1 and R2 using IP. So that is by default allowed. So we will see how we can use ether type to allow CDP, and that's how we will confirm, right, that ether type is working. So also, if you configure MPLS, yeah, I'll also show you how to configure MPLS. But then the control traffic is using UDP port 646, which should be allowed using IP access list, right? Not the layer 2, the L3 access list. So we will check that as well. But the data traffic, which can be, I mean, controlled using the ether type, which is 0x8847. Yeah, I will also allow that, but due to the reason that I don't have an MPLS infra here, I cannot check the data. Anyways, I will clear this drawing, and let's move on to the devices. Let's clear this. Let's close this. So let's go to ASA. ASA is as is. So ASA is already open. Let's go to R1 and R2. I need only R1 and R2. So as I left the configurations, which I did in the last video, the transparent firewall video. So the configuration should be there. If I check show run access list, access list, I can see that I have the TCP telnet is allowed, ICMP is allowed from R1 to R2, and then the RIP is allowed. Then on the outside, I have also, I don't know why I have this on the outside. I don't need this because I already have one here with the specific host from R1 to R2. So if I go to R1 and try and ping, okay, try and ping R2, this should work. Ping 192.1.10.2. This should be working, yeah, because my ACL is configured correctly. And also from inside, I have the RIP, and then I have TCP and ICMP from the inside. And also I actually should do an any from inside. That is better, because all of the traffic would be denied because of this one and at the end, right? So let me do this. I'll say no, and I'll say no to this, and I'll say access list permit. Okay, sorry, inside. Sorry, permit access list inside. It should be a caps access list inside. Permit IP any. Yeah, so that should be working now. And if I go here and check here, show IP route RIP, right? So I should have the RIP routes, yeah. But I should be able to go from 192.1.10.1 because I have the IP any there. Yeah. So that is one thing that I wanted to show you. The second thing is, if you check show CDP here on R2, you will not be seeing anything from R1, sorry. But in case of R2, you should see R3 but not R1. Yeah, you see R3, okay, but not R1.
So why is it that? Because of the ASA blocking the CDP there. So let me go there and say, so how do you configure this? So you have, remember the rule of ACL. So you can configure one ACL per interface. Okay, and one ACL per interface, I mean, and per direction. One ACL per interface per direction, and then so for example, I have an ACL on the outside, which is called out, and I have another ACL on the inside, which is called inside. Yeah. Okay, inside. Then I can have another ACL on the inside, which will be in the direction of outside. That is also possible. So if I go here on the AC and I say ACL, sorry, access list in, out, in, out, yeah, permit any, so I permit IP any, and then I go and say access list in, out, permit, sorry, then I have to apply this, right? Access group in, out, in, interface, inside. So this is the direction, right? So out, interface, inside. I can do this. But if I do the same thing with the in command, it will not take it because I already have one there, or it does overtake. Okay, so if I check show run access list, if it's okay, so it will overwrite now. Yeah, you can see in, out. Now if I check the access group, that should tell me the, so in, out has taken the preference because it has overwritten. So I don't want this to. So one ACL per direction per interface, right? That is the logic. But because this is L3 ACL, so you have separate rule for L2. So you can have an L3 ACL as well as an L2 ACL, but the rule is same: one ACL per interface per direction, whether it's L2 and L3. So you can have both L2 as well as L3 at the same time. So instead of this, I need to say access group inside, in, interface, inside. Yeah, that is fine. So that's what I wanted. Now that's done, said and done. Now let's go and configure the ether type ACL. So ACLs, let's say CDP. Then you have to specify the ether type, and then you have to say permit, and then the ether type. So if you are going for CDP, this is the ether type. You can search. Then you have to say access group, CDP, no, access group, yeah, CDP in, interface, outside, and also in interface, inside. So let's go on R2 and R1 to check the, on R1 I want to check these show CDP neighbors. You have to wait for a while before this will reflect. So let's keep it like that. And okay. And one more thing that I want to show you is the MPLS. So if I go here, config T, and say MPLS IP, and on the interface G00, I say MPLS IP, and likewise I go here and say config T, MPLS IP, and also in the interface G00, I say MPLS IP, and I see the show MPLS LDP neighbors. There will be no neighbor. It should not be there. Okay, I think there is some. Okay, neighbor is up, but I don't know why it's up. It should not be up because I don't have any access list on the ASA show run access list. If you check, I don't have any access list that permits. Okay, I already have the access list. Okay, sorry. my bad. It's an old configuration that should not be there. Let's do it again. The neighbor should go down in a while. Config T. If I say no MPLS IP, the neighborship went down. MPLS IP, and now again up. I don't know why. Did I say no access list for my DCP? To which I said, let me check. Yeah, this is gone, right? And then why it's still there? So run access list. Now I see that I don't have this ACL here, but still my MPLS is okay. And let's do a logging enable, logging console 7, logging on. Let's do some T-shoot. Okay, so I want to check the MPLS. Do show MPLS. Do show MPLS. Sorry, neighbors. Sorry, LDP neighbors. It's still there. I'll go and say no MPLS IP interface G00, no MPLS IP. On R1 as well, I'll go and say no MPLS IP, no MPLS IP, exit, no MPLS IP. Oh, that should take care. Show MPLS CDP name. Oh no, sorry, LDP neighbors. So this should not be there now. Yeah, correct. And if I go to ASA, so I see inside outside that has been teared down. TCP 646, yeah, that has been teared down. And I go, maybe the connection was there, so that was the reason that it was yeah, clear connection all. Let's do this. Show that is the reason that the LDP was again working. Okay, fine, great. Now let's go here and say MPLS IP and exit MPLS IP. I have to do the reverse, right? Interface first globally, then in the interface. Interface 0 by 0 MPLS IP, and on R1 the same thing. I'm on which ASA. I want to go to R1 config T MPLS IP interface gigabit 0 by 0 MPLS IP. Yeah, and now if I see show MPLS LDP neighbors, that should not be there. And if I go to ASA, this is the correct behavior, because I should see this getting dropped, the 646 UDP packet from outside. You can see. So in order to allow this, you need an ACL. So access list. You can just check this ACL, and you can create an ACL based on this. So let me just go and open a notepad and paste this particular line there. Okay, so I have this one. I'll paste it here. So what I need, so I'm denying UDP source outside to inside. So what I need is, I need to allow this. So how do I write this? Access list out. So I need to allow this on the outside interface, because it's getting denied on the outside interface. Access is out. Then I say permit. Then what is the protocol? UDP, and then I have the host, which is 192.1.10.1, which is getting denied, to host 224.0.0.2, because this is the multicast, and multicast is not allowed by default. So that is the actual access list that I need on the ASA to allow this MPLS neighborship to happen. And I already applied this on the group, so no issues there. Still, I'm denying this, is it? I think there is some issue with the ACL. Access is out, permit UDP host. Oh, sorry. Access list. Yeah, access it out permit UDP to host this from host this equivalent this. It's fine. Yeah. So if I say 646, right? This is the one. Executed. Yeah, this is fine because I can see the LLDP neighbors are up now. Now, if I do show MPLS LDP neighbors, it should be there. So this was the actual way it should be, because the connections it was getting, the packets were getting traversed through the firewall. But by default, this should not be happening because MPLS again is multicast, traffic, which will be denied by default on the ASA. Okay, so that is one thing. Now let's check the show CDP neighbors, which we allowed a while ago. And now you can see from R1, I can see R2. Yeah, because from R1 and from R2, I should see both of them, right? R1 and R2 show CDP neighbors. Yeah, so I have, I have only one right now. Yeah, I have only one. So it might take some time. And okay, did I allow this on the inside? No, right? Show on the AC. Let's go here. Show run access list. I need the ether type ACLs. So where are the ether type ACLs? This is the one. Permit, and I have not applied this anywhere. Did I? Yeah, I have to apply this access group out in interface. I did apply this, I think. Let me go and check on the show run access group. And I don't think I've applied this. Okay, I've applied this on the outside as well as inside. Yeah. So this should be working now because R1 is fine. What about R2? R2 will take some time and it will eventually come up. No issues. Because R1 can see now this switch. Yeah. So this is a router which has a switching capability as well, and I means IGMP is enabled. So you can go there and you can see detail. Detail. Now, if so, you can see this is an L2. So I can see the switch. Okay, I can see the switch on the other side. Yeah. Eventually, the firewall, the routers will also come up. I can see this switch here. So this R1 can look through the firewall and see the switch using CDP. So that is there. Now, one more thing. So now you know how to create the access list, which is type of ether type, right? So for if you want to allow the MPLS, then the ether type that would be like access list, say MPLS, and you say type of the type of ACL is ether type, say permit, and then the ether type of MPLS, which is this one. You hit on this, and then you say on the access group MPLS in interface outside. So this is how you do for the MPLS. Yeah. So hope you understood the whole concept of this ether type. It's nothing but an ACL at layer 2, and yeah. So by default, your MAC address, the broadcast and all those are broadcast MAC address, and the multicast MAC address are by default allowed on the ASA, and the VP, that's how the VPDs will pass through, and the CDP is not allowed by default, so you have to allow and only the IP, which is 0x0800 is allowed, but not MPLS. So you have to go and manually allow the MPLS using the ether type ACL. In this lesson, we are going to talk about the concept of virtualization in ASA, and which is called the security context, or you can say multi-context. So what multi-context is and how we are going to implement it, the configuration part, the working part, we are going to discuss in this lesson. So let me grab my pen and just tell you about the multi-context part. So multi-context lets you divide the
firewall into multiple logical firewalls. So that means if you have one box of ASA with the use of this multiple context, you can divide this firewall into two firewalls, into two logical firewalls like this. So if you see the diagram here, I mean on the left this one and on the right this one. So this is what I have as a physical topology. Yeah, and this is what I can achieve with using the multi-context. I can achieve this logical topology. So you can have a context named context 1 and another context named context 2, and these two contexts will be separately managed with respect to the admin. Or you can have a single admin who will have access to both of them, both of the firewalls, but they will be virtually divided into two firewalls. If you want, I mean, you can have, say, a team of you have a subnet, right? This is a user group. Say this is a user group of say let me just undo. Say this is the sales user group and this is the IT user group. So they don't want to share a single firewall. So what you do is you divide a single firewall that you have, this one, into multiple logical firewalls, and then the sales admin team has access to its logical firewall and the IT admin team has access to its logical firewall, and they can manage their firewall rules accordingly. Yeah, so that is what the multi-context is. You can just compare this feature with the if you are familiar with Nexus, it has a similar concept of VDCs. You have if you have familiar with Palo Alto firewalls, it has similar concept of VSys, and also if you are familiar with FortiGate firewalls, it has a concept called VDOM, which does the same thing. Okay, so that's the whole idea. But how do you divide these firewalls? And you can have another a reason for this is nowadays you have you give firewall as a service to your clients. So this is also required in a feature called multi-tenancy, wherein you divide these hardware into multiple hardware and rent it out to the client so that they can use it. So you have a single firewall, but logically you have a multiple firewall. And how many firewalls you can make out of this depends on the license and depends on the firewall hardware. Depends on license you have and also the hardware model you have. But at max you can go up till, according to document of Cisco, you can go up to 250 or multiple context. But once you are into multi-context, there are some limitations. Until 8.6 code of the ASA, there used to be some limitations. But now, if you go 9.x and above, those limitations are not there. So first limitation that you used to have with 8.6 code and below is, first thing is you will not be able to use a box, say a single box with two contexts, and those two contexts should be in the same type of firewall, in the sense either it should be routed or it should be transparent. So you cannot have a mix of this. If, for example, the context 1 here, right, it cannot be like context 1 cannot be like transparent, and on the other side context 2 should also be transparent in this case. Yeah, transparent. But in the new codes, you can have mix. So you can have this as routed and the other side as transparent. So that thing has gone after the 9.x, and also you we're not able to do the VPN termination earlier, but now in the new codes that is possible. And also there was a limitation on running the routing protocols, basically the dynamic routing protocols. So you were not able to do the dynamic routing protocol. So in that case, you would had to do the static routes in the old codes, but in the new codes these limitations has gone away. So that is just a history. I mean, you would mostly be working with 9.x and above, right? So if you end up working on a code that is 8.6 and below, so you might see these limitations in those boxes. So once I mean, by default it is in single context mode, and to check the mode you just go to the command and say show mode, and with that I mean, you will be able to confirm the mode, either it's single or it's multiple. So or multiple. So in order to change the mode of the firewall, you have to just specify the command in the configuration mode, say mode multiple, and this will first of all prompt you for a confirmation, and after that you have to reload. Once you reload, then you are into the multiple mode. Yeah. And one more thing, that once you are in multiple mode, you already have one context called the admin context. Okay, you already have one context, admin context with an asterisk. I'll just let you I mean, I will explain this admin context, and then you can go and create the how many contexts you want, you can create through that admin context. So there are two things to be understood, is system context and admin context. So the system context or the admin context is a context which will not be used to forward data. Is not a usable context in case of data forwarding. Okay, no data forwarding. Yeah. So what does it do? It is basically for management purpose. Yeah. And also for uh, 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 for creating and editing. I mean, creating or editing the context, the user context, you can say. Okay. So if you want to create a new context, you have to be into system context, and this and admin context, right? This admin context has access to this authorization to the system context. So you can change this admin context. You can create a new context saying context, say context one, and then you can say admin context one, context one. What will it do? This command does is it makes this context one as the admin context, which will have access to the system context. So system context is like so just if I draw like this, so you have a big box, right? So this is your system context, and then you have a admin context here, yeah, which has access to this system context. Then you go on and create some more context, say context one, con one. You go and create con two, yeah. But con two and con one doesn't have access to the system context. So unless and until you are inside the admin context, you will not be able to see other contexts. So for example, you go into this context one, you will be only able to see the context two or context one settings and running config, like that. Okay. So for example, you go to the system context and say show context, and then that means you are able to see all the contexts, say admin, context 1, context 2, like that, if you are inside the system context. But if you are inside context 2, you went and logged in, telnet to context 2, that means you have only access to context 2, running config. So you can say show context, but you will see only context 2. But if you do admin context and then context 2 or context 1, so that means you are making this context 2 as the admin, and now admin, this context 2 will have access to the system context. Yeah. Hope this is clear. On the other hand, I just want to say, just imagine this system context as the root context, which has access to all other contexts, and you can create, delete, whatever editing options. It's like the super user for this box. Okay, system context. When you are in, once you are inside the system context, you have access to everything. You are the King Kong user, root user. Yeah. So that is what it is. And this system context or the admin context is only is a non-usable context with respect to data forwarding. So no data forwarding takes place through the admin context, and is generally used for management purpose, MGMT purpose. So you set up a telnet, or obviously not a telnet from outside. You will set up an SSH from outside, and you will just land up in this system context or admin context, and then you can access other contexts from there as a administrator. Or if you are a client, you will not be able to go to the system context. You might be having access to your particular context only. Okay, so how do you do this? You as I said, you go and change the mode with mode multiple, and then you specify the multiple, and then you are inside the system context. You go there and say context and the name of the context, whatever you have. So say context 1, context 1, and then you allocate the interfaces, allocate interface, and then you say, for example, so if I am, this one is context 1, this one is context 2, I will say allocate interface gig 0 by 1, and the same gig 0 by 0. So when I go inside the context 1 and say show interface IP brief, I should see only two interfaces, that is gig 00 and gig 02 as the 01 as the part of this firewall. So this is like a firewall, logical firewall box with only two interfaces. So I'll be able to see only that. But these are like user context, and somewhere you might see that these IPs are you will not be able to enter them in the system context, because system context is not meant to system context does not have those features. Once you change the mode to multiple, only user context will have for example authority to configure IP address on the interface. Yeah, I will just demonstrate it to you once I am in the CLI of the firewall. So that is one thing you need to be careful about. And then also different contexts will have different running configs. For that also you have to go and once you allocate the interface, you have to type a command, say config URL, and then you have to specify the this 0 and where you want to save it with the name, right? So usually you keep the name as name of the context .cfg file. Yeah, so every context will have its own running config. So and the same you would do for context 2, and you will create this multiple context setup. So let's jump on to this CLI and see how it is done. And ultimately what I want to achieve is, you can see these two diagrams, right? So what I want to achieve is this here. So I want my R1. Okay, I want my R1 traffic to go through via gig 01 and via gig 02 to R3 and back on the gig 00 and go to R2. Yeah, so here it's not E00, actually it's gigabit 00 here, because you can see here it's the single interface on R3. So the traffic, if I try to go like this, it should go like this. So what you can have is you can have two IP address from the, you can have overlapping IP address on this interface, because this is part of multiple context, right? This is part of context 1 as well as context 2, both. And you can have overlapping addresses as well on these interfaces. No worries. Yeah. So let's see how it is done, and I'll be explaining more once we are configuring the firewalls. So first thing first, let me grab this, and it is coming up. Let me just expand this, and I will also go to my router 1. I have to hit no. And I'm running 9.8, I think, the code, and I can run dynamic routing, but I'll be using only static. And also I can have mixed mode of type of firewalls, right? Routed or transparent. So that is not the case with the old versions, right? There was a restriction. So with the new IS code, there is no restrictions like that. So once I'm here, I will say enable, and I will say config t host name. Just for fun, I will type the host name ASA, and then if I see show mode, this is the command with which you will see what mode I am in. Okay, it's not working. I don't know why. Let's see show and then mode. Let me just see exit, and here I want to see show mode. It says monitor. So let me just give a and that mode command, which I should be there. I don't see the mode command. Okay, let's see show firewall. It should not be. It's a router, and yeah. And if I see show mode, okay, I can go config t and say directly mode. Is there that a command? No, there is no command. And I see show version. I think I don't have license for this. That's why that would be the case. So you should have context license here, as I said, right? So if you go security context 0, so that's why that command is not working. So let me just quickly grab the other firewall that is I have with the this is what code. This is 9.8. So I have 9.1.115, which has the the license there. So I will just pause the video and change the firewall. Okay, now I have added the firewall with the version 9.15. Let this boot up. Until then, what we'll do is we'll go to the router 1, router 2, and router 3 and configure those. So let me just quickly go here. And R2 also. Let me bring up R2 and also R3. Let's go and quickly grab a notepad and say this is for R1. Yeah, and I'll go enable config t host name R1, and then I'll go to interface gigabit 0/0 IP address. This is 10.0.0.1/24. Done, and then I'll say no shut, and then I will have a route, IP route, default route pointing towards the 10.0.0. I will keep the 254 as the firewall's inside IP address on both sides, and on the outside I will have different IPs. So if you go here, I have to hit no on all the routers. So I'll do that. So that till then we write the config, and this will boot it up. So this is the one which is IP route 00. So I have the route there, and next what I want to do is I want the telnet. So line VTY 0 through 4. I will go and say login or I can say password Cisco, say login, and transport input all. So that is what I want to do on the R1. Likewise, I will go and do the same for R2 and R3. So if I go here, this is R2, and I will copy this, copy and paste it here. So for R2, this is R2 changes, and then this is what, 20.2, and this changes to 20.254, and rest is fine. And again, I go and do the same for R3, changes to R3, and this is 30.3, and this is 30. So on the R3 side, I would have two routes. So I will not just configure right now anything. Okay, let it be like this. And let's go to R1. Copy this, and let me go to R1. This is my R1, and I'll paste it. Good to go. And then I'll go to R2. This is my R2. Copy. Go to R2. Paste it. Nice. And go to R3. This is my R3. Grab R3 configs. And go to R3, which is this one, and paste it. So now that is good. Now let's go to the ASA. As I said, this is my 9.15 version, and likewise it should have the security context. So we have the license for 20 security context. So now if I go here, earlier that command was not working. So I'll go here and I'll change the host name to ASA. Now if you see show mode, then you should end up seeing this as a single mode. Now to change this, you have to type command mode and then multiple. Once you enter this, it says, it gives you warning. You want to confirm? Yes, I want to confirm, and convert the system context. Once you hit enter, it will create that system context and an admin context. Yeah, hit enter, and you will see that this will reboot into multiple context mode, and it will write this thing. Admin context configure file will be written to flash. You will see, and this is part of the system context once the AC reboots. Yeah, so let me just tell you what I need to do here. So on the ASA, or on the router 3, I should have two routes because I want to reach to 10 and I want to reach to 20 as well. And I will just explain that to you before that. I just want to configure the multiple context on the firewall, and that would make sense after that only. Yeah, so let this boot up, and then we will continue with the configurations. So first thing first, what I need to do, let's note it down and jot it down on the notepad. So on the ASA, yeah, first things first, you go into the enable, and then you say config T, and then you say what you create this context with the command context, and say context 1. Okay, let's keep it capital, context 1. Once you do it, then you go and say allocate interface. So I have for context 1, I have gig 0. I don't have gig here. I have Ethernet 1, and I will go and do the same for Ethernet 3. So Ethernet 3 is part of both the context. Ethernet 3 like this. So let's go to the AC itself and say enable config T. Then if you say show context, this is how you see all the context, and you will be able to see admin context there by default. So you can see admin context with an asterisk. Asterisk means this admin context has access to the system context. So that's why you are able to do. So if you do show interface here, you cannot be
So let's do interface IP brief. So that means all these interfaces are part of the admin context. Yeah, and if you do the this is how you change, right? Change to context like this, and then type the name of the context that you want to go. So let's say I want to go into the system context, which I'm already part of. Sorry. So if you go and say show IP, no, show interface IP brief. If you do this, you see that you have these interfaces part of the system context right now. So let's create context 1. Yeah, so that is done. Now what you do next is you allocate the interface to that context. So for context 1, what we had decided is ETH1 and ETH3. Ethernet 1, and then you say Ethernet 3. So this is part of your, and plus you specify the URL, I mean for the what you say, the configuration, right? The running configuration. So that is how you do, and you say with the name, I mean, then you can say the name of the context itself. So for me, it was like this thing, context, no, oh, context.cfg is what I will, sorry, context.cfg. Once I hit enter, it will try to fetch for this configuration file of context1, context1.cfg, and you would receive an error, right? It's trying to fetch, but warning could not find. So that is a good sign, because if you would have found this context, this configuration file on your disk, then all those configurations would be applied to that context. But we are creating a fresh context. That means we don't have that configuration file over there. Might be you can also have backup here, so you can use this to restore the configuration of that context. Yeah, so once you are inside that context, so you are not inside the, I mean, the context, you are just configuring the context, and then you exit. Yeah, to go into that context, you say change to context, or first of all, let's see show context now, and you will be able to see now an extra context which we created right now, that context 1, and you can see these interfaces are part of those contexts. So now we are in system connect, if you do the same command of show interface IP brief, now you see still the all the 4 interfaces are part of that system context. But if you go to interface, say interface Ethernet 0, sorry, Ethernet 0, and go there and say IP address, you will not be able to do that. See, you don't have a command like that, because system context is not going to forward data, right? That is done by the user context. So if you go to the context, which is so you do the command with change to context, change to context, and then name of the context, context 1, and like this. And then if you say show IP interface brief, you should see how many interfaces? Only 2. Show, oh sorry, show interface IP brief is the command on the ASA. I do this mistake every time. So interface IP brief. So you should see only these 2 commands. So that these 2 interfaces. So that means context 1 is a separate firewall, and it is thinking like it has only 2 interfaces. So now you can see that the status is showing down. The some of the, I mean, features are controlled by the system context, and some by the user context. For example, one of the features is the actual status of the interface, right? So if you go into the interface here and say Ethernet 1 and type no shut, this will not have any effect unless you do it from the show from the system context IP interface, show interface IP. So still you see it says down. So I need to go to change to system, and then I have to go to interface Ethernet 1
no shut. Like that, I will unshut all the interfaces, and you only see, and then exit, and then I will go to change to. Somebody was asking me about the if I do like this, will that work? No, it is case sensitive. Okay, so you have to type the name of the context as you have created it when you create it like that. So now if I do show interface IP brief here, I should see the status is up. Yeah, now I can go inside the interface and as I did, I can just configure the IP addresses there. So interface Ethernet. So let's do with the this context one first, interface, and say first of all name if Ethernet one is my inside, right? So let's configure this as name if inside. Name if inside, and then I can say security level is not needed. I need the IP address of 10.0.0. As I said, I will keep it as 254. Okay, for the inside. That is done. Exit. Then I need to go interface Ethernet 3, and I'll say no shut IP address. So this will be on the 30 side 00. Let's go for 101 for this one. I'll just explain to you. Just remember. Did I say the name if? No. Name if outside. Oh, sorry. Yeah. Okay, fine. So that is done. I'll go exit and say show name if that command is working fine, and I'll say show IP. I should see the IP. Now from the ASA, if I go and ping 10.0.0.1, which is part of this context, it should work. Yeah, and also the outside, which is 30.3. It should work. Yeah, that's great. But if I go and ping 20, it will not work. For that, what we have to do is first of all change to system, and then change to context. No, we have to create the context 2 first. So context 2, remember, and then allocate the interfaces. So for this one, I have Ethernet 2, yeah, and Ethernet 3. And then your config URL for the startup config, running config, name this with context2.cfg. Yeah, so that is done. I'll say exit, and then I'll change to that context. Change to the same context, which is context 2. We'll change to context like this, and if I say show interface IP brief, I should see 2 interfaces, and if I say show run on this, you should see that it thinks I have only 2 interfaces, Ethernet 2 and Ethernet 3. Yeah, that is how it should be. Now let's go to the interfaces and configure the IP addresses there. So let's start with the inside interface Ethernet 2. No shut is already there. No, not necessary. I need the name if. So this is my inside, and IP address is 20.0.0. This should be 254. As I said, I will keep 254 on the inside. Yeah, and then that is done. So that's what I need. And then I'll go to the other interface Ethernet 3, name if outside, IP address is 30.0.0. This one I'll keep as 102. Great. If I go exit and say show IP, should see the IP addresses and show name if. I should see the name ifs and the security level. So that is great. That is what I needed. Now if I try to, now I'm part of the context 2, so I should have access to the router 2 20.0.0.2 yeah, and I should have access to the 30.0.0.3. so both the context has access to .3, right? But I cannot go and ping 10.0.0.1. That is not possible, because if you go and see, the context 2 doesn't know anything about context 1, and that is the main purpose, right? To segregate the access. That's what we have done. So if I want to go to context 1, I would say change to context 1 with the capital context. Yeah, context 1. So you can see on the left side after ASA, you can see what context you are in. Yeah. So now if I go here and say show route, I should see my 10 and the 30. So that is how it is. So you can change to system from here, and you'll see that the context part is not there. One more thing, when you will be doing the what do you say, in the next classes, you will be doing the high availability part, which is active standby routers, right? So in the active scenario, you have to use the multi context. So there you should use a command, which is I think the command is prompt let me just check, prompt context, and okay, prompt host name. So with the host name, you will have which one is active and which one is context name state. Yeah. So once you do that, since we don't have the failover, but it will show you the box state. If it's the active box, it will say active. If it's the standby box, it will say the standby. Yeah. So this is one command which is very handy once you are doing the active standby, and to just verify which box you are in, right? So that is one just tip for you guys. And now let's do the main thing that I wanted to do is I wanted to ping from R2 to R1, which is in this case, I'll go to R2, and if I see enable the C show IP interface brief, I should have a show IP route. I have a default route, yeah, and if I do a telnet from there to 30.3.3, this should be passing through the firewall, and it should be reaching the ASA. But since the R3 does not have a reverse route, if I go here and I see enable, and if I see show IP route here, R3 doesn't know how to reach 20. So that is the main issue. I can just config T here, and I say IP route. So you need to understand this thing here. So there should be a mechanism, right, for the firewall to know when to, for example, I'm doing a telnet from there to there. Yeah, this is a telnet. So now that this guy receives a packet from say 20.0.0.2, now he should know where to forward the traffic back. So that's why I have two IP addresses here with the 102 with the same subnet. Yeah. So what I'll do is I'll point this R3 if with a static route, that if you want to go to 20, go to .102, and if you want to go to 10, yeah, then you should point to the next the gateway as one, next to a hop as 101. but still then we would see have some problems. Let me just show you. Clear. Some of this will work and some may not. So I'll go to R3 and I'll say IP route 10.0.0.0, and then I'll say 255.255.255.0, where we'll go to 30.0.0.101. That is for the 10, and for the 20 I'll go to 102. So that is there. Now let's go to R2 and do the telnet again. So I'm going doing the telnet from inside to outside, and this should work now, but it will not. Debug IP packet details. So I can do the same from R1, and let me just do the same telnet 30.0.0.3. Yeah, I am receiving the packets from R1, as you can see, and also I should receive packets from R2 if I do the same thing here, and yeah, I'm receiving the packets, but it's not working. So let me tell you the problem. Let me just undebug this. Yeah, when I see show ARP here, now for 101 and for 102, look at the layer 2 address. Yeah, so what happens when you cross through when a router passes through one subnet to another? It does the layer 2 macros, the MAC address rewriting. So there's the issue lies. So the ASA doesn't know if I'm receiving this packet on this interface, where do I need to forward it? Which context I need to forward it? So because of the same MAC address. So to overcome this, you have three solutions provided by the Cisco. One of that is you should have dedicated interfaces. So you should have it Ethernet 4 here, then the problem will be solved. Or you have to assign a unique MAC address. And thankfully, we have a single command which does this for us. And the command is MAC address auto. And the third is you can do NAT, but that is not a common way. The most common way is this one. And obviously, if you have a dedicated interfaces, obviously. But the whole purpose is to have unique MAC addresses. So let's go to the ASA and type the command MAC address auto. Yeah, you need to go to change to system and say MAC address auto. No, it's not working. I think should be in the configuration. So if you let's quickly check this configuration command MAC address auto in Cisco ASA. I don't remember back of my head till the time we can go to say change to context 1 and say MAC address auto it's not working, right? No. So see, let's go here, command reference, and I have a command reference here. So this is the one which I was talking about. So automatically assign private IP, a private MAC address to each shared context interface. Use the MAC address command in global config mode to disable automatic. So what was the command? MAC address auto. Okay, in the global configuration, that's what I did. I have to go to, so I'm into change to system. Yeah, now if I see show context here, you can see both the context, and I think I am in, I was not into the config mode because of that host name, right? So what was the command? The prompt, I think host name. Yeah, prompt host name context state. That was the command that enabled this. I'll just disable this for now. I cannot do a no on this. Yeah, I cannot do that. Anyways, let's stick to the plan. So the command was MAC address auto, right? Once you do this, convert it to MAC address auto 560, done. Now, if you go to your R1 and do the same telnet again, you are able to go, and also on R2, if you do the telnet again, you are able to go inside the, so you can see you are inside R3. Also here, if you go, it's Cisco, and you are inside R3. Now, if you go to R3 and do the same ARP command, now we'll see the MAC address has changed. These are like virtual MAC addresses, and that is how it is. Yeah. So now, if you want to go from R3 to R1 to R2, so the let's go to R1 first here, exit, and now if I tell it to 10.1.1 or not 10.1, it's 10.0.0.1. This should also be working, provided have, yeah, I don't have that. Yeah, I need an ACL now. So just imagine what I did. I went from R1 to like this. So I need on context 2, right? So on context 2 outside, I need an ACL which says that this traffic is allowed. So if I go here on this and say change to context 2, yeah, then I need access list out permit TCP from host 10.0.0.1 to host minus 20.0.0.2 EQ23, because this is telnet. Yeah, then I have to apply this access group out in interface outside. So this should be enough for that from the R1. From R1, if I do the same thing again, no, exit. Did I do it from R1? Yeah. If I do a telnet from R1 to 20.0.0.2. So from, if you just imagine what I did again, R1, I did a telnet. So this is like inside to outside, this should be allowed. It will go to R2. It will see the destination as R3 will see the destination R2 and forward it to this 102. And the ASA should have an a rule that is allowing that traffic. So that I already configured here. And then the return traffic is also not an issue from the R2 side. So if I go here and I'm on the context 2, right? Yeah, and I say show access list here. Do I see any hits? And show IP access. No, it doesn't work like that. Show access list. Should see some hits, and I'm not able to see the hits here. Again, let's do a login on that. Logging on, logging console 7, logging enable. Now I want to see that am I able to see this traffic coming from this R1 and leaving R2? No. R1 should be able to go to. So let's just change to context 2, and now if I see logging on, logging console 7, logging enable. If I do this and if I again do the same thing, I should see some. No. And what about con? Show con. have no traffic passing through this. So this is strange. I need to go to R3 and do a debug here. Debug IP packet details to see, am I receiving this traffic? Maybe I have some. So if I go here and do this, I'm not receiving this packet at all. So let's try to do a ping. Let's try a ping instead of telnet. Let's try to ping 20.0.0.2. Yeah, I see that. I mean, strange. I don't know. So this is what. So I can see that outside interface is. So from 30 to 20. So I am in R3. Okay, that's the wrong one. So from R1, if I ping 30.0.0.3, not 30.0.0.3, I have to ping all the way to R2, so 20.0.0.2. So now instead of so from the context one, that is not an issue, right? So I'll go here and say no logging. Sorry, no logging on, no logging enable, no logging console 7. Instead, what I'll do is I'll go to change to context 2, and here show an access list. Yeah. So I'll say no to this access list. I don't want this. Instead, what I want to hello access list out permit ICMP from host. That is the 10.0.0.1. I'm going to host 20.0.0.2. Yeah, and then what I say is access group out in interface outside. Now, if I do this, this should be sufficient to take it to. Let's try this once more. Now I want to see where this traffic is getting. Then I logging console 7 logging enabled, logging on. If I do this and I do this, I want to see that I am able to see this traffic on R3, right? Yeah. So I'm able to see this traffic on. If I go to R1 again, on R3, I'm not able to see this traffic. Let's try to think this. So what I'm doing here is from R1, this one, I'm doing a ping with the source of 10.0.0.1 to destination 20.0.0.2. Now I have a default route. I will point to 254, give it to 254, and okay. What a silly mistake. I don't have a route on ASA. Okay, so happens. Let me go to our. Okay, I have to go to both of the no logging. So that's why the the telnet was not also working. No logging enable. No logging console 7. So this is my context 2. I'll say IP route. So if I go here and see show route, I don't know about 10. So I need to have a route with outside 10.0.0. what any network for 10. So I have to point this to the 30.0.0.3 and also change to context 1. Now if I see show or route here, I don't know about 20, so I have to say show route outside 20.0.0.0 255.255.255.0 pointed to R3, because R3 is the one who is going to be the next hop. So now if I do the same thing now, yeah, now the traffic should go to R from context 1 to context 2. Now if I see show con here, should have yeah, I have 20 going to 10.1.1. This was timed out. Now I need that access list on change to context 2. If I go here and say logging on, logging, enable logging console 7. Okay, sorry. Sometimes I'm too fast. Huh? Logging console 7. So now if I do this, I need to see. So inbound ICMP connection is fine. Okay, now from my, I'm going to R2, right? So in R2, if I go and say debug IP packet details, and from R1 again, I ping it, that means I should have, yeah. So what is the issue here? Let me see. Do I have a route here? I should have a route here. Let this to, so I'm receiving, I'm sending it to this guy. And show access list now. I have an access list, hit count. I'm not able to see the hit counts here. Okay, I have the hit count here. So there is no issues with the routing here. Show IP route. If I see, I have a route pointing towards 254. Now then again, it will reach R3. If I see show con here. Now from R1, I mean R1, this one, right? Do this again, and I see show con here on R2. I don't see any connections. So let's have a maybe I don't think so, because the return traffic from R2 would be what, as per our scenario. Let me just cross this, and on R2, this one. So if you see, I'm receiving a packet of 10.10.01 on gigabit from 20. I'm on R2, right? I'm on R2. Okay, this is the one I'm yeah, this is the one I'm receiving, and I'm sending it. 20 to 10.0.0.1 type 040 ICMP. And what about the return traffic on the context 1? Yeah, so I have no access list on context 1. So this becomes very tricky, right? Now I need to go to context, change to context 1, change to context 1. Need to be very thoughtful about this. Okay, so here I need again a return access list out permit ICMP from say this time I'm permitting from host.2. This is from host 2020 to host 10.0.0.1. yeah, and I'll say access group out in interface outside. Hopefully now that's all I need, and this should work now. Okay, not this one, this one. Yeah. So voila. Oh, finally. So that was fun. Yeah. So hopefully you understood the whole idea of multi-context or security context, whatever you want to say, the way it works, why do we need the MAC address auto, and if we don't do this, what will happen, and the whole traffic flow, right? How you have to consider the flow with the context wise. So I hope you liked my video, and if you did, don't forget to press subscribe button and share my video as much as possible.
let's move on to the topic. So the topic today is redundancy or high availability. So redundancy, like everybody wants to have redundancy, right? A backup. So with ASA or any other devices, you want to have pair of boxes so that if one fails, the other one takes over. Yeah, so that is called redundancy, or you can say high availability. But I mean, you have different types of HA. You have active, and you have active standby. Yeah, but this is box level. But today what I want to talk about is a redundancy on the interface level. Okay, interface level. And there are two ways that ASA has redundancy on the interface level. One is having redundant interfaces, and the other one is having port channels. So in this video, we will be talking about the redundant interfaces. How do we configure them? What are the drawbacks? Yeah, and what are the plus points of using redundant interface. So the first thing, why do we use redundant interface? It's for backup. So in case your one of the link goes down, there is another link which will take out immediately, right? So there is no drop of packets. I mean, there will be, but not that much. So it will be like very quickly it will switch over to the backup interface. So how many interfaces, redundant interface you can have? You can have up till 8 interfaces. And this is a quite old technology, but after 8.6 only the ASA started supporting port channel, which does load sharing. Okay, and so there is no load sharing concept in redundant interfaces. But the thing is, even though if you have 2 or more than 2, like till 8, but still only one will be active. Only one, but still only one interface will be active, and forwarding interface will be active and forwarding. So the other interfaces are there just lying for the active to go down, and then they come back. You have the same thing on the box level as well, but today we will be discussing about redundant interfaces. So the first thing is, why do you have it? You have it because you want backup. In case something fails, there is a backup, right? And then why don't you use it? It is, the reason is here, only one interface is active. And if you're running above 8.6, then obviously your option should be port channel. But in case if you are on a lower code, so maybe you will see these configurations there, the redundant interface configurations. So how do you do it? It's quite simple. First of all, you whatever switch you have connected the ports to, they should be in a single VLAN. First thing first. Okay, so we will go to switch 3 and we will configure all this in one VLAN, say VLAN 10. Yeah, and then you need to go to the ASA, and on the two interfaces that we have, or if you want to do it with more than 2, you are most welcome to do it. So go on to that interface. I'll go to E3 and 2 and say no shut. First of all, I'll physically bring them up, and then you need to go and create an interface called interface redundant, and then the number, right? And then say any number from 1 to 8, I guess. Yeah, so let's say interface redundant 1, and then you have specified the member interfaces. So whatever interfaces are part of this redundant interface 1, so you go and say member interface. In my case, I have Ethernet 2 and Ethernet 3. After that, once you have done these two, interfaces as the member interface, then you go into the redundant interface and you are still actually in the redundant interface. And in future, if you want to go and configure something, so these are like behave like one interface, and that is actually redundant interface one. Yeah, redundant. So the spelling, anyways, redundant interface one, right? Then you go to interface one and say name if inside, and then you configure the IP address. In our case, we will go with 10.11.11.10, as you know, /24, and then you say no shut here, and that's it. I mean, on the interface level. And then on our own, we'll go and configure as an IP address of 1, and then we'll do a continuous ping to this interface, and then I'll go and shut down the active interface, and you'll see the switchover, the pings will not be broken. Yeah, so I think you understood this. Let's go and on the CLI and do this. Let me clear this. Okay, let me first of all go and open the ASA. Okay, and then the switch, and then the router. Okay, so I have the router, I want the switch. Okay, so first thing first, I need to go to interface range gigabit 0/1, 0/0, 0/2. Yeah, then I say switch port mode access, switch port access VLAN 10. Done. Exit. If you see show interface status here, you should see the interfaces part of that VLAN 10. Yeah, so you have all these part of that VLAN 10. So switch is done. Let's close the switch. I don't need the switch anymore. Now let's go to R1 and configure the interface there. Config T interface gigabit 0/0, no shut, IP address 10.11.11.1 255.255.255.0/24, no shut, and then I'll go and configure a static route, IP route 0000, and this I will configure as the interface of the ASA, and show IP route. If I see, so I have the static route pointing to 10.11.11.10, and I should also see the show IP interface brief. I should be up, obviously I can see the route, so that means it's up. So that's done from the router and the switch side. Now let's move on to the ASA. It's not working. Let me close this. Let me just wipe it out and stop it, and so let me just reboot the device. I will pause the video till then, and then I'll continue again. Okay, so my ASA is now up and running. So first thing first, you go to ASA and say show version. Should have the license for this. First thing first. So you should have the license. So I have the license activity. I think for the redundant interface, you don't need license, and they should work on any of the versions. Yeah, that is fine. I just thought that, yeah. So it's better to check. So as you can see, I have license for clusters. So you guys might be thinking, how did I get this? So you need to use the version 9.1 for these licenses. It's already there. Just go and find the version, this version, and use it for your labs and all. Yeah. So okay. So for the redundant interface, first thing first, what you need to do is you need to go to the physical interfaces and bring them up. So if I see show interface brief here, sorry. So mine from inside is E3 and 2. So 2 and 3 are down. So I'll go into the interface Ethernet 2 and say no shut, and I'll go to interface 3 and say no shut. That's done. Now exit. Now just to confirm, show interface IP brief, I will say it's up. Yeah, it's up. Now you go and say, let me just change the name of the AC. Now you can go and say interface redundant. As you can see, just if I go back and hit a question mark, you have port channel and redundant. So I'll go and say redundant, and then if you hit question mark, you have 1 to 8. So I will say 1. Okay, then inside that you define the member interfaces that there are member and then interface, then the Ethernet. For in our case, I have 2 and I have 3. Well, if you have any configurations of that on that interface, it will be clear. If you have any IP address and security level, that makes sense because you don't want the physical interfaces to have any configurations, right? So once that is done, exit. And now if you see show interface IP brief, you will see a new interface, which is the redundant interface, right? And if you see interface redundant 1 like that, no, exit. You have to see show interface redundant 1. You will see the member interfaces 2 and 3, and you will see only 2 is active. Yeah, so that is the drawback, that no matter how many interfaces you include in that redundant interface, but only one will be active. Yeah, so now for the configurations, you need to go interface redundant into interface redundant 1. Then whatever configuration you did earlier, right, in the physical interface, now you do it here. As simple. Name if inside, automatically you'll get the security level set to 100 and say IP address. So mine is 10.11.11.10, which I set as the default gateway for R1 in a default route. Now that said, let me just configure a MAC address which we can track when you see the, say this is 10. So I'll just configure a MAC address here. Show interface IP brief. Now I should see IP address in also there, and I see the IP addresses here. So now let's go and now if you try and ping the interface 1 here, R1 here, it should be successful. Yeah, so now if you go to R1 here and just check the show R, the MAC address that it will be showing is not the physical one, it is the logical MAC address, the virtual MAC address that we configured, right? So in case if you go to show interface E2, right, the MAC address would be different, see. But if you go to show interface redundant 1, we just configured this MAC address over here, and that's what you are seeing in the R table here. So it doesn't make any difference if Ethernet 2 goes down, because the MAC address will be taken care by E2. So for example, let's do this test also. Ping 10.11.11.11.10. So this is the redundant interface IP address on the ASA. So I'll keep a key repeat count of this mask, and I'll go to, now E2 is active, so I need to go into interface Ethernet 2 and shut it down. Let's see how quickly it fallbacks. Okay, yeah, as you can see only one packet drop, but after that the traffic was smooth again. So Shift X6, I need to stop this. Yeah, so that was it for the redundant interface. In my next video we'll do the port channel, and then after that we will do the box level redundancy. So in this lesson we are going to discuss the redundant interfaces, redundancy, not redundant interfaces, because we discussed that in the previous lesson. So this is redundancy, and the first thing we discussed was redundant interface. So the benefit was that we had a backup interface, but the drawback was that the other member interfaces were not active. Yeah, until 8.6 code of the ASA. This was the only solution. Now after that we have the port channel or ether channel, you can say, which we configure in the switches, right? So the same we can leverage now inside ASA. So I mean, this is the naming. We will say like port channel 10 on the ASA, and then we'll configure the switch also with port channel. We'll bundle these two and these two interfaces in a single port channel 1 or 10. Then we will then what happens is you have the load balancing capability there. So all the interfaces you can you can include 16 interfaces, but only 8 will be active, load balancing, and 8 will be on standby. Yeah, so that is the thing, and this is why we use mostly we use the port channel concept. And how do you do this? You go to each of the devices, you configure the port channel as is in switch and then in ASA, and then the actual load balancing is taken care by the load balancing algorithm, whether you are using LACP. You have that the you have the selection, right? Either you do it by source or source and destination MAC, source and destination IP, source MAC destination, like that, port number, and also include. So you have different based on the LACP or static version, right? So that is the port channel. Okay, then let's start the configurations. So let's go to switch 4, which is my outside switch here. Enable config T, and let me change the host name to outside switch. So first thing first, I need to configure these 3 ports in the same VLAN. I'll go to switch 4, and I have what? I have the 0, 1, and 2. So I'll first of all go and say VLAN 20, then exit, then interface range, gigabit 0 by 0 to 1 and 2. Yeah, I'll say switch port mode access, switch port access VLAN, then hit enter, then switch port access VLAN 20. That's said and done. Now exit. Now let's begin the actual configurations for the port channel. Again, I'll go to the port channel interfaces that I want to bundle 1 and 2. Interface range gigabit 0 by 1 and 2. Yeah, I'll say channel group any number that you like, 1 through 255. It need not be same on the ASA and the switch, but it's recommended so that it's easy for you to T-shoot. Yeah, 5 mode, and then you have options here on the switch. You have options to use PACP, you have option to use LACP, and you have options to use manual. But on the ASA, it's only LACP that is supported and manual. So I'll go and say active. Yeah, and then no shut. Exit. Now you go to the interface port channel. Port channel 5. And you can also specify the commands here, mode. That is already there, I think. If I show exit and I say do show, yeah, run interface, say gigabit 0/1, I have the commands already there. And also if I say 2, these 2 are part of the same port channel. So if I do exit and show interface, no, if I do port channel, okay, that is like ether channel here, ether channel 5 summary. So yeah, this is down as of now, so that is fine. You can do one thing. I mean, the order of operations is very important. So you can do one thing. You can go to interface, port channel, C5, and say shut for the time being. Yeah, keep it like this and go to the ASA to configure the port channel. So here what you do is you go to the again the interfaces that you want to uh, bundle. This is ETH0, ETH1. Yeah, so you go to interface. You don't have the range here, so you have to do it one by one. So interface ETH0, you say channel group, and then on the switch side I had 5. Let's go for 10 here, so that I want to show you that it need not be same. And once you hit question mark here, you will see you would have only option for active and on. So that's why I configured LACP on the switch. So here also active, and let's say no shut. Yeah, and then again do the same thing for the Ethernet 1, and I do the same thing and say no shut. So that's said and done. Exit. Now you have to go to the interface, port channel 10. Yeah, and let's specify a virtual MAC here so that we can track this on the router. MAC address. So this side I will say 000.000.000.020. Yeah, and then you specify the configurations here on this port channel. So outside, right, and then you specify the IP address, which is 192.1.20.10. I don't need the subnet mask. I can hit enter here because this is class C, and you can say no shut. Once you say no shut here, go quickly on the switch, yeah, and say no shut here as well, and wait for a while so that the port channel will come up. So you can see it's changed to down, and it changed to up now. Nice. So now if you do the show ether channel, here it was 5. Yeah, it was 5 here, and you can see that this is SU. That means S means layer 2 and U means in use. Yeah, that's what I want. This side is layer 2 and this side is layer 3. So if I do here show port channel, and then it was 10, right, and summary. So this shows in use. That's what I want to see. So I will now ping 192.1.20.2. Before that, I need to configure this on the router 2. If I go here, no, this is not configured. So quickly, I need to go and configure the router 2. So we will test a ping, or we will do a telnet from inside to outside. We'll configure the NAT, because from inside I have redundant interface, from outside I have port channel. So let's try that. Let's wait for this to work. The order of operations is very important while configuring the port channel. So make sure that you have the ports shut down on one side until you configure it on the other side. Okay, so I'll enable config T. Let's rename the host name to R2. I will enable telnet here, like line VTY 024. Let's set the password to Cisco and say login and say transport input all, and let's go to the interface gigabit 0/0/0. What's international interface gigabit 00, no shut, IP address 192.1.20.2 255.255.255.0, and I did the no shut, right? Yeah, let's do an exit. Don't want the loop back, and show IP interface brief. If I do with a do on the beginning, I should see this. Now if I go and ping the interface on the firewall, that is this one, it should be reachable. 1.20.10. Yeah. Now if I do the show R, it should be the virtual MAC address. Yeah, so I can see the virtual MAC address here. So that is how you do the port channel configurations. And on the ASA, I said to see the port channel, you can see show port channel. And yeah, and this is what I told you, that we already have 2 ports, but maximum how many we can have? 16, but only 8 will be active, and the maximum number of port channels that you can configure is 48. Yeah, even though it shows when you go and say interface port channel, I think it was on this, or and then hit a question mark. Oh, it shows 1 through 48. On the switch, it's different, right? So if you go to switch and you say interface port channel like this, if you say, then hit question mark, it's also 48 here. Okay, somewhere I saw 255. Anyways, so that is one thing you need to be aware of. And you can see the load balancing method that is used is source IP and destination IP. Yeah, and now from inside to outside, if you want to go, so I have show interface IP brief. If I do, so I should have the redundant interface from inside and port channel from the outside. So now if I want to go from inside to outside, I should have the NATing. So I'll configure the NATing object network INS. Subnet is my 10.11.11.0 255.255.255.0, and then I'll say the NAT inside NAT, not net, NAT inside comma outside, and say dynamic, let's say interface. That's done. Now I'll go to the R1. I should have the default route set, right? So what happened to this? I need to stop and start this again. Let's go to R1. Enable show IP interface brief. I have this, and show IP route. I have this also. So let's do a telnet to 192.1.20.2 from inside to outside, and this should work. Cisco show users, and this should be the IP address of the outside interface of ASA, which is the port channel, right? Port channel 10, I think, yeah. And this should be like .10. Yeah. So I hope you understood and liked the video. The topic today we have is the failover, which is also called the HA. So let me grab my pen. So in my previous video, we have talked about redundancy. And what we did was interface level redundancy, which was called as redundant interface. And then we did the port channel for redundancy. But these two were for the interface level, right? This was for interface. Now for box level redundancy, we have the concept of failover. And we have 2 types, active and active standby. And then you have the second one, active standby. And then also we have the clustering. So these all are license based. So you should have license to work on with the active standby, active clustering. So today what we are going to do is active standby. And let's first of all discuss what is active standby. So in this scenario, just imagine you have, okay, first of all, let's imagine a simple topology. Like you have your LAN here, and you have your
PCs, clients, whatever are connected here on this LAN. And then you have the ASA as the firewall. This one, yeah, going to outside internet. Just basic design. What if this firewall fails? So there's a single point of failure here. So what you do instead of having a single firewall, you can have double firewall like this, and then you can connect these two, and then also you can connect these two like this. So now you have a redundancy with the box level, but as of now what we are doing is active standby. So just to understand, with the active standby, it is just like the redundant interfaces, but it is on the box level. So you do have a backup, but that will not be active all the time. It is called as hot spare, or you can say hot standby. So what happens is it sits there waiting for the active firewall to fail. Active firewall to fail. Once the active fails, this becomes the active. Okay, as simple as that. And with respect to your LAN users, the default gateway will not be changing, because if you just think about it, so for example, you have a gateway of say 1.100, and you just think that 1.100 is this guy, and this is like .200. Just an example. So I have pointed my default gateway to 100. What if this guy dies, right? This person, this F5 goes offline, then what about the LAN users? So the failover takes care of this, as this .100 is not actually assigned to this interface. It is assigned to the interface of the active firewall. So when you configure it, you don't configure on the interface, you configure and point it to the active firewalls inside interface, which we will name it. You will see that. And when this failover happens, the standby that becomes the active will take over as .100. And then he will be answering to the request from the LAN side. So that's how this gateway need not to be changed. And with respect to the client users, the LAN users, this failover will be transparent. So they will not be knowing that a huge failover happened on the firewalls. Yeah, so that's how it is. And then I want you to understand about this failover LAN interface and failover link interface. But before that, I want you to understand some terminologies. One is active, and second one is standby. Third is primary, and the fourth one is secondary. So what is active? Active is the box that is currently forwarding. It is a role. The box that is active is actually forwarding the data. The standby is again a role which is acting as the hot spare or the standby. It's just waiting there for the active to fail. But primary has nothing to do with active or standby. Primary is, if you think about it, it's just a name, or you can say it's a priority. So when you specify in the configuration that this box is primary, that means it's priority, and it will take over as active. Yeah. And secondary, again, name and priority. So whichever box you name as secondary will become the standby. Simple as that, right? So just to again explain this. So this box is primary, this box is secondary. So what will happen when this setup will come up is this will be active and this will be standby. Yeah.
But what will happen when the active box goes down? So this role, right, this box went down, this role will be taken over by the standby. Okay, this will come up as active, and this will be the standby now. But it will still be the primary. So it's like primary standby and secondary active. So there is nothing related to the forwarding related to the name of primary and secondary. So this is like secondary will be the active. And always remember, all the configurations are done on the active firewall. No matter if it's primary or secondary, it should be the active firewall where you have to do the configurations, and all the configurations are synchronized using the failover link interface, failover LAN interface. Okay, so all the configuration synchronization is done over the failover LAN interface, and also the heartbeats, or you can say the keep alives, are shared through the heartbeats or keep alives are shared through the failover LAN interface. And what about this link interface? So link interface helps us in a sense. Okay, so you must have heard about this stateless or stateful. If you have gone through my previous videos, you should know about this. But if not, just to say, what is stateless and stateful? With respect to firewall, it's nothing but connection tables, connection information or connection table. So if you keep the connection information, it is called stateful. If you don't keep the connection information, it is called stateless. So this failover link is used for the connection information to sync over between both the boxes. So if you don't configure this failover link interface, then this would be a stateless failover setup. But if you configure this failover link, then the connections from this ASA 1 will be sent to ASA 2. Yeah. So I mean, the LAN devices that you have here, they don't have to go on and again create the sessions. So that session table will be available on ASA 2. Once that ASA 1 fails, the client can go via ASA 2 without any drops. Yeah. But then again, if you don't have this, then once the ASA goes down in with respect to the stateless, once the ASA 1 goes down, then these LAN devices will be disconnected and they have to initiate the traffic again. So that is the case. I will be demonstrating to you all this, but just to understand that failover LAN interface and failover link interface. The difference: failover LAN interface does the config replication and replication and heartbeats or keep alives. Yeah. And once again, the failover link interface is responsible for connection table synchronization. Yeah. So that is there. And I mean, initially what you do, you go to both the ASA devices and configure the primary, secondary, and the IP address of these interfaces. And then later on, when you have to configure the actual IP address of the inside and the outside and the DMZ, that you have to do only on the active firewall. Once this failover is kind of configured and they are into sync, then you have to do every configuration on the active device, and automatically it will be replicated on the secondary device or the standby device, or the secondary, the standby device. Yeah. So that was the theory part. Now let's go and configure this on. So first thing first, I need to go to the ASA And let's configure the failover LAN interface first. For I have to go, so I have to go to both the ASA1 and ASA2. So let's log into ASA1. Yes, and then ASA2. Okay, let's name them so that we know. Config key, host name ASA1. I want to show something now. Enable config key, host name ASA2. Yeah. So first thing first, the interfaces that we are using for LAN is ETH3 and E3 for the configure application and the heartbeat. And one more thing you need to understand, that for bringing up the ASA into active standby, first thing first, you need to have the same interfaces on both the sides. Hardware wise also this should be the same box, and also you should have the software version as well as same. And remember the interfaces that are connected to on the Ethernet 0, because see, you will be configuring the active box, right? And the configurations will be replicated on the standby box. So for example, ETH0 on active is connected to the outside. If you connect ETH0 on the inside on the standby box, then the IP address will be assigned on the inside on the other box. So that you need to be very cautious, because all the interfaces should be same, and the type of interfaces should also be the same. If it's Ethernet, if it's gigabit Ethernet, so you just look into the nitty-gritty of these things, right? You can just search online, and there are lots of things that you need to know. But just a short idea about this is the hardware should be same, the interfaces should be same, interface type should be same, software version should be same, and there are lots of things that need to be same. So you can just research. Okay, now we are in the ASA1, and we have to go to the Ethernet 3. So interface Ethernet 3, unshut this, physically no shut, and then that's the first step to initialize the active standby. So first thing first, you have to configure the LAN interface. So how do you do it? You say failover, then you say interface, then LAN. If you hit a question mark here, you have the IP word here. But what I want to do is, so before interface, this is for the configuration of the IP address. But before that, you have to specify the LAN interface. So you say LAN. If you just hit a question mark here, you see LAN and you see link. See LAN and link. This is what I was talking about. This is for the configure application, and the heartbeat. This is for the stateful connection replication. And then you also have the key and other things. But for now, what we need is failover LAN, and then you say interface, and then you say the name of the interface. So I'll say that this is my failover LAN, because I'm configuring the LAN, and then I specify the port, which is Ethernet 2. Yeah. So whenever you do this, the configuration is cleared. Okay. And then you go now and say the configure the IP address. So you do the failover interface. Now you have specified which one is my failover link. Then again the same name. So you will be configuring all the IP based on the name, all the configuration based on the name. So you are configuring the IP address of the failover LAN, the fail LAN, which is actually Ethernet 3, but this is the virtual name. So this will be replicated on the active box. Okay, so I will keep this as 100.100.100.255.255.255. Then here only you have to specify the standby. What is going to be the standby IP address? So 100.100.100.200. So whichever box that is standby will have this IP address. And then, as I said, that primary and secondary is the priority, right? So here you go and say failover LAN, and then unit, and then here you can say primary and secondary. So ASA1 is my primary. I want this to be active, Then for authentication, you can also do failover key. So I'll do key and I'll say Cisco 123. Yeah, and then you have to activate this failover with the command failover. So ASA1 is configured. Now we'll go to ASA2 and we'll do the same thing. If you go here, show run failover. So all this is same, just for the failover unit you will specify secondary here. So let me grab a notepad so that I can just copy paste this command there. So I'll go and get a notepad and I'll paste it here, and instead of primary I will say secondary. That's the only difference on the both sides. And IP address also will be configured like this. So Cisco 123 is the key. So first thing first, I will go here, Control X, Control V. I'll copy this to Control X, Control V here. I want the failover after this. Control V here. So I'll copy all of this and go to ASA2. This is my ASA2. Paste it, and you say failover. Once you do failover, it will detect the. I'm not unshuttered the interface. So I'll say no failover here. So if you check here, show interface IP brief, I think interface 3 is shut, right? Yeah. So I'll go to interface the Ethernet 3 and no shut, and that I will say failover. That is what I need to do. Now I should be here also. I say no active made detected. So the the configuration should be done in back to back. So if you're doing ASA1, ASA2 should be on a shutdown state, and then unshut when you have done the configuration on ASA1. Now in this case, what you have to do, you have to just go and say no failover on both the sides, and here also no failover. Yeah, and now again say failover, and again restart the process on both the sides. Say failover. That's it. Now wait for this to detect the mates. It will take some time. It's saying no active mate detected. Now it's saying beginning configuration. So that means it has detected the standby. So now let's see, end configuration to mate. So it has done the configuration. So now let's see. If you say failover, this is the command from which you can see the configuration. So you can say this is your primary and this is your active. So because of that primary keyword, which is the priority, this box has become active, and secondary is my standby. If you run the same command on this standby interface, and first of all, now let's see, you can see the host name was ASA2 here. Now when I enter here, you can see the host name has been changed to ASA1. And if you do the failover command here, show failover, you will see that this has the secondary, but this is my standby, and it's standby ready, and the primary is active. So I'm not the primary, I'm the secondary, and I'm the standby. On the active box, I'm the primary and I'm the active. Yeah. So now whatever configuration you do, you have to do it on the active box. So let's see, let's go to the interface on the ASA. So for my external is Ethernet 0, right? So I'll go into interface. The configuration are same as we did in the previous videos. Just a change is that you have to specify the standby IP address here as well. So you say no shut, and then you say name if. So this is my outside interface. Yeah. And then you say IP address. This is my 192.1.20, 192.1.20.10, and then the subnet mask. 255.255.0, and after this you have to specify the standby IP address. So standby is my 20. So this ASA1 is my .10, this is .2, but this IP address has to be configured on the active box. So I'm going to the active box, and from there I'm configuring the standby IP as well, 20.20. So that is the little difference between your this normal configuration and the active standby configuration. Now if I go to my ASA2, so this is my ASA2. If I say show interface IP brief, you will see that IP address will be reflected here. You can see the one I configured on the ASA1, the active box, is reflecting on the standby box. So that failover LAN link is working perfectly fine. Now I have to go here and say I will also specify a route on the outside interface, a default route which I'll be pointing towards the R3, this one. So I'll keep this as .30, so I'll point it on the .30. So route outside 00192.1.20.30. So this is my R3. So I've pointed the route there. So now I need to configure my inside interface, which is my Ethernet 1. So I'll go here, interface Ethernet 1, no shut, name if is my inside. Yeah, inside, and automatically the security level will be set to 100. And now I have to say IP address, and then this side is my 10.11.11.10 255.255.255.0 and standby 10.11.11.20. So that is my standby on my secondary or the standby box. It will automatically update this on the standby. So if I go on the standby, you can see it's showing the information here that something has been reflected here. So if I go, show IP interface beef, so you can see that the IP address is reflected here. So now after this, what I need to do is I will go on R4 and R3 and configure the IP addresses there, and then we'll see do a telnet from R4 to R3. So no here, and as well as on R3 I need to go and enable telnet as well, right? So I'll go here, no here. So this is my R4, which is my inside. So this will be 10.11.11.40 or say 4. Let's keep 40 because I've kept the outside as 30. Yeah. So let's go here for a couple of more seconds. And so as of now, the HA add to standby is up and running. And now I'll go here, enable, and I will say config key, hostname, I'll say inside. Yeah, like this interface, I think it's gigabit 0/0. Let me just check quickly. Yeah, gig 00. I'll say IP address 10.11.11.40 255.255.255.0, no shut, and then I need a default route, and I'll go exit, and I'll say IP route 00000000, and my active IP address I will give 11.11.10. Yeah, so and here and right, and if I go to R3 on the outside, yeah, this one, enable config key, host name I'll keep as outside, all caps. Yeah, interface again gig 0/0, no shut, IP address 192.1.20.40 on this side, 255.255.255.0. yeah, and then exit. Now I need the line VTY, I need to configure the telnet here, line VTY, login, password is my Cisco. Yeah, and then I'll say login, and then I say transport input all. So my telnet is up. So if I do show IP interface brief, and if I try to reach the IP address on the outside 190.1.20.10, do, okay, I need to specify do here. So this should be successful. Yeah, and if I go and try the 20 on the standby, that also will be successful, but only 10 is the one that is responding, right? So if I go here from the inside, if I ping 10.11.11.10, so it's up, and also 20 is up, but my default gateway is 10, so all the traffic will be going through 10. So let's do a telnet now from here to the IP address on the outside 20. Before that, I need to do a NAT. So let's do a NAT on the ASA. So for that, I have to go to my object network. I'll say INS, that is the inside, and I'll keep the subnet
as okay, let's do what? Oh, am I on the active one? I think I'm not on the active one. So if I go exit here, and if I say show failover, you will come to know. So this is my secondary, and you cannot do here. So I'll go on the active. Yeah, this is the one. So if I go here and I say object network INS subnet, for the inside I have 10.11.11.0 Yeah, then I do the NAT. I'll do a pat inside, comma outside, and then I'll say dynamic, and then I'll say interface. So that is fine. Exit. And if I go and say show run NAT, you will see, I mean, that the same will be replicated on the show run on the secondary. So I mean, that makes sense to you now. And now if I do the telnet from here, that is 192.1.20.40, that is my not 40, sorry, it should be 30 on the outside. This should go through my ASA 1, and it should connect to my which one? Yeah, R3. But I don't think okay, so there should be a NAT that should be working. So on my R1, if I go to ASA 1, if I say show NAT details, and if I say show xlate, there should be a translation. Yeah, I have the translation 40 getting translated to 10. Yeah, so this should reach my R3, and let's do it once again. Sometimes fails for the first time. It's not working. I don't know why. Let's go to R3. Let's check it, and I'll do exit, and I'll say debug IP packet details to see if this is actually receiving the packet here or not. Let's wait for this to time out the telnet that I tried. First of all, let me see if this show IP address interface brief that I've configured here. So I configured the wrong IP address. So this has to be 30. I don't know why I configured 40. Yeah. So on R3, I go to interface gigabit 0 bar 0 IP address 192.1.20.30 255.255.0. Yeah, so that should be okay now. You all, and now I'll go to R4. Yeah, do the connection again, and this is working now, right? Cisco. So now what I want to show you is, so if you see the show user, I mean, this is just the normal stuff. This is the .10 of the outside interface, and that too of the active one, right? .10. Because if you do, if it was translated on the secondary, the backup, the standby, actually, it should be .20. So anyways, that's what I'm not worried about. What I'm worried about and what I want to show you is actually, so if you see here, show con, now the connection table is there, but if you go to the standby and do the same show connection command, the connection is not there. So this type of active standby is called as the stateless active standby. Now if you want to make this as a what do you say, a stateful, so you have two options. Either you can run the failover link on the same failover LAN interface, but it is recommended that you should have a separate failover link interface wherein you will synchronize the connections, right? In order to use the LAN interface as the link interface, there is just one command. So you need to go to the active again and just type one command, that is failover. Then you say link, in this time not LAN, so link, and then you say the name of that failover LAN command, name of that interface of the failover LAN that we configured, right? So and then you say the interface of that LAN interface, right? The first one, Ethernet 3, because we're using the LAN interface to carry the link information, and you hit enter, and that's it. That's, I mean, how you do it. If you see the failover here, you can see it is unconfigured, right? Before.
Now if I go and do the same command, show failover, you will see that error is not there, and you can see this has been configured now. Yeah, and it will show the status. Now if I go to our this one and I say exit, yeah, and I'll do the same thing again. Cisco 123, Cisco, I think it's so I'm inside, and now if I see the show con on ASA1, it is there as usual. But if I go to ASA2 and do the same command again, you can see the connection table has been synchronized. Yeah. And one more thing, so if you want to do it on the same interface, that is how you do it, right? Now if you want to do it on the, so this is the other one. Okay, now if you want to do it on the second interface, you want to have a separate LAN interface and a separate link interface. So let's go to this ASA and just take out this command. So I will go and say a no and paste it like this. Now if I see the failover again, it should show me the same error again. So in case you want to do it on a separate interface, what you do, you go to that interface, first of all, interface Ethernet 2, yeah, then you say no shut, then the command is failover link this time, and then you specify the name. Now we specified failover LAN for the LAN interface, I'll specify failover link, and then the interface Ethernet 2 that I'm using. Yeah, that's done. Now after that, you have to configure an IP address. So it's like you did for the LAN. Again, failover interface IP. Now you specify the name of the interface, name of the interface that you specified as failover link, fail link, and then the IP address. So I will specify a 192 series here, 192.168.1.1 and 255.255.255.0, and the standby as 192.168.1.2. Yeah, that's done now. Now if you see show failover again, it is up. See, now the failover is again up, and if you do the same thing again outside, exit, yeah, and you do the same thing again, Cisco, and you go to ASA1 and say show con, the connection is there, go to ASA2, show con, the connection is there. Yeah, and there is one more thing to understand. So in case you want to in case the firewall dies, obviously this will take over, but in case you want to forcefully change the role, this you would usually do when you are going to perform an upgrade on the ASA, right? So for example, I want to make ASA as the primary, so the command is failover and then active. The box you want to make as active, go to that box and type this command. Once you do this, it is switching to active. And if I go to R4 and see, the connection is still intact. And if I say users, even though I switched from ASA1 to ASA2, the telnet connection is still there. It was not dropped. And the standby will take IP address of the active, right? Now it's active, so it will take the IP address. So this is now a secondary and active. So I can see it from here. If I say show failover, now you can see, even though I'm secondary, but I'm the active box. Yeah, and even though I'm on the other side is primary, but he is the standby. So if I go to R4, with respect to R4, if you check the show R, so I'm on the outside, exit. If you check show R here, let's see what is the IP address of this is my 10, this is the active one. So this is what I am looking for. So 5000.001.001, right? Let's go to ASA, active ASA, and go to the let's say show interface Ethernet 1. And if you check the IP address, MAC address here, so this is the one, right? Now if you go to the show interface failover, okay, no, not here. This is my router, right? I want to go here, interface failover. I don't have the failover here. show interface ETH1, right? Now I'll go to the standby as well. Show interface Ethernet 1. So you can see the MAC address is the same. Yeah, so it has taken over that MAC address so that the R4, right? It doesn't need to do the ARP again and again. I think it is no, it is the 1 and the other side is what? Need to see. Wait a second. Yeah, this is 2. So wow, okay. So I need to clear the ARP here. Clear ARP caching. Now I can see show ARP still there. I don't know why it's still there. Should be cleared. Show ARP. Then I say interface gigabit 0 by 0. Okay, it's the it's learning both the MAC address on that interface. So it has done the R, and now okay, because this is the active standby. Okay, so now the R will be replied by the 11.20. Okay, you can see it has learned 11.20. Or maybe because I pinged on 11.20, it's learning like that. So let's go to, okay, I want to clear this. I want to clarify this thing. What happens to the MAC address? Who is the one, or is the MAC address changed, or it is the, even though IP address has been taken over, I want to see if the MAC address is also taken over by the secondary now. So how to do it? I need to clear the ARP cache here, and okay, I'll clear the IP at 10.11.11.20 and 10. Yeah, so now if I do show ARP here, still it's showing. I don't know, there's a bug or something here on this. Well, okay, why don't you do this? I have given you this task. You go on and check what happens to the MAC address, and comment in the section. Does it remain the same, or does the MAC address change? So this IP, this is not the one you need to look. Okay, this is actually the one you need to look to. So IP address should be the same, but in this case, I am seeing only 001, right? While as if I go to our ASA2, I see that the interface MAC is 00100. That means that the IP remains same, but the MAC address has been changed. So it's, now for 10, for .10, ASA2 is who responds for the ARP. Before that, ASA1 was responding to the ARP request for 10.11.11.10. Yeah. So I think you understood this failover concept of active and standby. We are going to talk about the Cisco failover, which is basically the active failover using the multi-context. Now, in my last video, I have gone through the active standby failover in the Cisco ASA and the limitations of active standby is that one of the box, which is the secondary or the primary, depending on the failover, will be staying as a hot spare. That means this hardware, this resource is sitting idle right there. Yeah. So this costly piece of hardware is sitting without being used. But that is again, a good option. In case of failover, it will be active and the traffic will be redirected from this hardware box. But then again, you have better
technologies or features, you can say, which you can utilize to use the hardware in a better way. So now today, one of the technologies that I'm going to talk about is the active failover, wherein what we will do is both the boxes will be actively forwarding. But there's a caveat to this, that this is not like the clustering, which is another feature in most of the firewalls nowadays, and also in ASA, but in code 9.x and above. Now, I will not be suggesting you to use active if you are running on code 9.x and above, but somehow if you end up using a code which is below 9.x, then you have to use this active failover using multi-context. I mean, this in a sense is not 100% active. This is kind of, if you guys are familiar with MSTP, then it is something like that. So in MSTP, one VLAN, right? One VLAN is going to be forwarded through one root bridge, and the other VLAN is going to be forwarded through another root bridge. In the same fashion here also, what you will do is you are going to divide these firewalls into, again, the logical firewalls, which is called the multi-context. So for example, I have two firewalls here, ASA1 and ASA2. Yeah. So you will be dividing these two firewalls again into two contexts. So this is context 1, and this is context 2. Again, this is context 1 and this is context 2. Now, what will happen is, so you have a VLAN. There will be multiple VLANs in your infrastructure in the LAN side. So, for example, you have VLAN 20 here and you have VLAN 21 here, which is my case. Okay. Then what will happen is you have a switch in here which has all those VLANs here. But what will happen is VLAN 20 will go via this context, and the VLAN 21 is going to take the other context, which is on the other firewall, which is context 2. So that is how what you do, how you achieve this active scenario, wherein both the firewalls are actively forwarding the data. And in case one of the firewall fails, then both the context go active. So in the AC1, only context 1 will be active, and AC2 only context 2 will be active. And one more thing that you need to understand is with multi-context, you only can configure on the active context, remember. So in case you want to do any changes on the context 1, you have to go to ASA1, and in case you have to do any changes on the context 2, you have to go to ASA2 for the changes for the active context, right? So that is the whole idea. It's not kind of load balancing stuff in a sense, maybe because in VLAN 2 you might end up having more traffic than in VLAN 21, but yeah, it gives kind of kind of a feature where the other box is not sitting idle. It is also forwarding some of the traffic that is generated through your LAN. Okay, let me clear this now. Now, how do we achieve this? First of all, you have to be in the multi-context mode. So you change these firewalls to mode multiple. Simple command, mode multiple. And then again, we are using the failover LAN interface and the failover link interface on the same Ethernet 3. We can use on different interfaces as you have seen in the last video. So this will be used for config synchronization and the heartbeat, and this will be used to to synchronize the connection, right? So NAT tables and connection tables, right? So we will be using the Ethernet 3 for this only. And now here what you can see is I'm using only one interfaces for the outside and for the inside, right? But what I'll do is I'll be using sub interfaces, and I'll be showing you how to use the VLANs and how to set up this L2 switch in a sense, because I'll be making these two interfaces as trunk and these two as access on VLAN 20 and this one on VLAN 21, and on the outside I'll be having all the interfaces here as trunk, and I'll be tagging these interfaces with the VLAN 11 and 10 tags. Yeah, so all this configuration I'll be doing from scratch, so you can follow me and go along with the lab. So once you have both the firewalls in the multiple mode, which is the prerequisite, and also you know about the hardwares that I said, right? So you need to have the same model, make it model, you need to have the same version, software version, you need to have the same interface numbers and also the interface types that should be same. There are many other things that needs to be same. You can go to the documents and check about that. And also, you have a better technology that I said, like as clustering, right? So clustering is something that is there in the industry right now, which is being used by every firewall. It is like the stack-wise technology in Cisco catalyst switches, and the VSS in the catalyst, and also the VPC. But there is a difference between these, because also the management plane in this ASA is separate, because for each context you have to log into different context. For each context you have to log into the active context, which can be on the different firewalls, not on the same firewalls. But in case of stack-wise, you have the same, and also in the VSS you have the same management plane as well. But in case of VPC, you have separate management planes. Yeah, so that is something that we will discuss in the clustering classes. For now, you need to understand, once you have this in multiple context, you have to create the context 1 and context 2 on both the firewalls. You can do this, but we will not be doing on the secondary firewall. We will be doing this on the primary firewall. And what I'll do is I'll create the context 1 and context 2 on the firewall 1, and then I will actually configure the failover so that all that settings, right, will be automatically sent to the other firewall, and all that configuration, like the context and the interfaces, all those stuff will automatically be configured here on the secondary firewall. Then we will go to the context and configure the IP address on the sub interfaces. For example, I will have the Ethernet 0.10 and Ethernet 0.11 here, which will be tagged by VLAN 11 and VLAN 10 respectively. Yeah, and then we can go here inside would be 1.20 and 21. Yeah, and you can see, oh sorry, this is 21, so VLAN 20 and VLAN 21 be tagged here. This will be a trunk interface. Yeah, this will be access port. These all three will be trunk ports, and you have to create the VLANs here, VLAN 10 and 11, and here VLAN 20 and 21. That is one thing. Once you do this, then you go and in the failover, what we do, we configure the so for the failover command, you have to do it in the system mode, system context. You can say, you go in the system context on the primary firewall and say like failover LAN interface, failover LAN IP, failover interface IP, failover key, failover what else is there, failover link interface, and then you specify the actual failover command. Yeah, you can do that failover command, and after that you will create a failover group. So once you create the failover group, this is where we actually do the active. So failover group 1, and you will create another failover group 2. Yeah. Now once you create the failover group 2, then inside failover 1 you will say primary. This is my primary. Yeah. So this is like the priority, and this is my secondary. And also there is one more command, which is the preemption. So I will say preempt in both the groups. Preemption means once the active goes, the
secondary will obviously take over, but once this active comes back, it will take the role from the secondary. Okay, so that is done when you have the preemption enabled. Otherwise the secondary will always be active unless and until the secondary fails, and the active again will be will be changed from standby to active. So that is preemption. So once you do create these failover groups, then you go to the context and then you say join failover group 1 and join failover group 2. Yeah, so that means context 1 will be the active in the primary box, and context 2 will be active in the secondary box. So that is how you do the failover, and then you will see on both the firewalls that on this firewall context 1 will be active, and on this firewall context 2 will be active. Yeah, so you can obviously check that by the command show failover. That is the verification command. So let's start with the configuration, right? Let me just start all these devices here. So first thing first, I will go on to the switches and the routers and do the configuration part. So I have to go to the say router, and so let's go to the switches first. Let's configure the VLANs, and let's put the the interfaces into particular VLANs or make them trunk. So if I go to switch 6 first, let's wait for a while until it boots up, and go to the switch 2. It's also booting up, and I can go to R3, let them boot up, and also R4, and then I have R5. I will do the ASA once I have configured all these routers and all. Okay, let me go to the switch 6. Okay, it's coming up now. Let me see. So switch 6 is my outside switch. So let me rename this first. Let's minimize this like this so that I can have the full screen. Switch 6 is there. Yeah. Okay. So this is fine. Now I'm using the VIOS images. Even the IOL images will work perfectly fine. So I'll go enable here, config T, and I'll change the host name as switch outside. Yeah, so that there is no confusion here. So for on the outside, what I do is I have to create the VLANs, which is VLAN 10 and 11 I need, and I'll go exit, and then I have to have the VLAN 11 and also exit. Yeah, that's done. I just need to have the VLANs there, and then I can go to all the interfaces and make them trunk. Interface range gigabit 0 bar 0, 2, 1, and 2. Yeah, and I will say switch port trunk encapsulation .1q. Yeah, and then I can say switch port mode trunk. That's all I need to do on this switch. I can go exit and say show interfaces trunk. I should see all the VLANs being allowed on that trunk port. So that is done. I will just now I don't need this, and also I need to check the VLANs so that I can do show VLAN brief, show VLAN, or also summary is there. Yeah, I can see not with the summary. I can see the VLAN brief command, and I can see I have VLAN 1110. That's it. I will close it down. I don't need this now. Now let's go to the inside switch, which is switch 7, and I will also rename this to switch inside, enable, and then I have to go into the configuration mode, and then let's say host name, and this is switch inside. Okay, now here gigabit 00 and gigabit 01 are part of different VLANs. So first of all, I need the VLAN 20
exit, and VLAN 21 exit. And then now I need the 03 and 02 to be trunk. So let's go to interface range gigabit 02 to 3 switch port trunk encapsulation dot 1q switch port mode trunk, and then exit. And then I need the interface gig 00 interface gig 0 by 0 to be switch port mode access, and this will be part of switch port access VLAN. This is the 20 side, and then interface gig 0 by 1 is going to be part of VLAN 21. Yeah, exit, or I can say and, I can say right, and I need to see the interfaces being part of that VLAN. So for that I can do first of all interface trunk to see the trunk interfaces, which is 2 and 3 gigabit 2 and 3, fine. Then I can show interface status to see the interface 00 is being part of 20 and 01 part of 20. So this has been done, and also show VLAN brief. I need to see, obviously that should be there, the VLANs, yeah. So these are VLANs. So I'll just close it. I don't need it now. Now let's go to router 4. Let's go to router 3 first. Hit no. Router 4. Hit no. Router 5. Hit no to the initial configuration. Now let's go to router 3. So this is my outside router. Here, yeah, this one. So here what I need is I need two sub interfaces, and I need to configure the IP addresses on them. So how do you do that? So first of all, you need to go to the physical interface and unshut the interface. So that's the first thing you do. Let this just boot up. Okay, now it's done. Enable config T. Let's change the host name R3. Now you go to the interface. I'm also inside of configuration mode, interface 0 by 0, and say no shut, and then you exit out of that interface, and then you go to the interface gig 0 by 0 dot. So this side it should be 10. I need one interface, and then I need the other 11. Yeah, so let's go to the 10 first and say encapsulation dot 1q, and then the VLAN. So this is my 10, so I'm using this for VLAN 10. Then I can say IP address 192.168, and this is going to be 10.3. Yeah, and then the /24 subnet mask. Good. Now exit. Now I need to go to interface 11 0.11, and this will be tag bit 11, and then the IP address should be 11.3 this side. Yeah, and I'll say right. So I don't need anything else, just that I need to enable the telnet. So later on I can telnet from the inside to outside. So let's go here, config T, and I go to line VTY 0 through 4, login, transport, okay, password, Cisco, login, and transport input all. So that's said and done. Exit, and now if I see show IP interface brief, I should have the sub interfaces configured up and running with IP addresses. Exit. If I ping those interfaces, it will be successful. So if I go here and do this, ping is successful even for the 11.3. So my router has been set up. The outside router R3 done. Now let's go to R4, which is my inside router on VLAN 20. Let's configure this quickly. It should not take time because I need just the okay. Let's configure the host name and interface gigabit 0 by 0, no shut. IP address is 192.168.20 dot. This side is like 4. Let's keep it with the router number 4. 255.255.255.0, and the did I say no shut? I think yeah I did. And I need a default route which is IP, which will be pointing towards the ASA IP route
0.0.0.0.0.0.0.0. My gateway is going to be 20.10, which is going to be the interface on my ASA. Okay, so I will keep as 10 and so I can keep as 20 and 21. So that's better. I go for 21 as the IP on the ASA. That's it. Now I can just exit here and show IP interface brief. If I do, I should see the show IP route. Also, if I do, I should see the route, the static route pointing towards 20.21. Okay, let's go to R5 now. Enable config T, hostname R5, interface gigabit 0 by 0, no shut. Now this side is like 21.21, right? So on the other side, I configured R4 with the IP address of which one? 20. IP address of 20. Yeah, this is 21. And I think this. Let me see. I can change this later. So right now here I need is IP address of 192.168.21.5.255.255.255.250, and also I need a route, IP route on this side is 192.168.21. Say so I can keep this as 21 again. I will keep that side as 20. So let's do that. IP route, sorry, I have to specify all zeros and all zeros here. This is 21. I need to change this, and I can go to show run and check the static part and remove that and replace it with 20. So I don't need this. Yeah, I can go here and say no, and right click here. Yeah, instead I can go and say 20.20. Okay, that's it and then right. And now I can just minimize these. Now let's start with the ASA. So what you do, first thing first, don't forget to change the mode. Enable show mode. If you do, it should be multiple. Now how to change it? Mode multiple, simple, confirm and done. Do the same on the second ASA. This one. Enable config T. If you see show mode, you should see single, and then you say mode multiple. Confirm. Done. Now let's go to ASA1. Now everything has to be done on ASA until the failover has been set up. So let's wait for the ASA to boot up back online. Now the active needs license, so I'm using 9.1.5, 9.15. So you can find this image. It has license, so that you can practice the active as well as the clustering. So I will show you. Once you do show version, you will see the licensing part there. Let's wait for a while until this is back online. Great, you can see the license here. The licensing part was here. You can see. Sorry. You see the failover active right there. Okay, so here you can see show version, and you will see the licensing part here. So you have the where is the active? Yeah, failover active, right? Usually you see active standby, which doesn't need license, and also you can see clustering enable. Anyway, so that is the. So I'll go enable config T. First of all, I'll change the host name to ASA1. This is my ASA1. Now, first thing first, bring up the physical interfaces. So interface Ethernet 0, no shut. Interface Ethernet 1, no shut.
interface Ethernet 2 no shut, interface Ethernet 3 no shut, 3 no shut. So let's go to a notepad quickly so that I can just type in these commands there, right? Interface Ethernet 0 no shut, interface Ethernet 1 no shut, and then interface Ethernet 2 no shut, interface, even though I don't need interface Ethernet 2, but yeah, just that habit of typing it, right? So I can go copy all this like this and go to ASA 2 as well. So this is my ASA 2, enable config T, and I'll paste it here. So all my interfaces are up. Exit, show interface IP brief. If I do on ASA 2, all the interfaces are up. On ASA 1 also, if I do show interface IP brief, it should be up. So that is done. Now let's start with the context part. So if I see show context, I should see the admin context there only. Yeah, admin context. So I need to create two contexts, and then I have to create the sub interfaces. So let's create the sub interfaces first. So I need to create interface like here. I'll go here and I'll say okay. So what I need to do, interface ETH 0 dot, I need to create 10, yeah, and then I need to create exit, then I need to create interface ETH 0 dot 11 on the outside, yeah, and then I exit. Oh, okay. Before that, what I need to do is I need to say VLAN. Here, how you tag the VLANs inside the interface, and VLAN 11, right? And then again interface ETH 1.20 VLAN 20 exit, interface ETH 1.21 VLAN 21 exit. So this is the command that I need to put in for the interfaces and the VLAN tagging on the ASA1. Okay, okay, interface 21 was not taken because of the spelling mistake. This should be fine now. Copy. Config T, paste it. Yeah, so if I go here now, show interface IP brief, should not see an IP address, but I have the sub interfaces there. Now if I go here, now let's create the context CTX1, yeah, and allocate interface. This is my context 1. I need the 1.10 and 1.20 on this context 1. So I'll say allocate interface ETH 0.10. Okay, so it should be like this, and then I need the 1.20, yeah, and then I will specify the config file disk CTX1 where the config file will be saved. Now that's it, and then exit. Now I'll create the another context CTX2, and then I'll allocate interface. Now for this I need 0.11 and okay, Ethernet like that, and I need 1.21, yeah, and then the config URL disk and CTX2. Great. Now I'll exit from here. Now once I've created the context, right, and also assigned the interfaces to that context, now I need to go and create the this failover groups. So before that I will create the failover itself. So for failover, what I need to do is failover LAN interface, then you specify the name. I will call this at failover, then the interface Ethernet 3, yeah, then you say failover interface interface IP and the name fail, and this is going to be on the 192.168.1.1.255.255.250, and my standby IP on the other side is 192.168.1.2. When you configure the standby, right, this puts the interface on monitor. That means if this interface goes down, then the failover will be triggered. But if you don't configure a standby, that means that interface is not monitored, and that failing of that interface will not trigger the failover. You will see this when I type the failover show failover command. It says this interface is monitored. So if I go here now, if I say show failover, in this case, okay, let me see. So this is the polling and all. Not now. Wait. So I configured the failover interface, failover IP. Now I need to configure the failover key is Cisco, just for authentication. Then I have failover link, and I'll say failover link, and then the name fail, and then interface. This is what I need if I'm using the same interface as the failover link as well. So I've configured the failover LAN IP, LAN interface, then the IP, then the key, then the failover link. Now I need to specify the failover group 1. Now here you say primary group 1, I'll keep as primary, and also I'll enable preempt, right? And then I'll go to the failover group 2. I'll say this is my secondary, and also preemption is enabled here. Now exit. Now here you need to go again to the context ctx1 and say this is member of join failover group 1, and on the context 2 you say join failover group 2. Done. Now you enable the failover command here. Failover. You have to do this before you configure anything on the ASA2, because you want both the context on ASA1 to be active first. Remember, if you do this failover command on the ASA2, which is blank, it may it may not, but it will override the configurations on ASA1, because it will push the configurations to ASA1 if ASA2 becomes the active. Yeah, so remember to make ASA1 as the failover first, and if you check the failover for here, you can see, as I said, wait for these to be negotiated, and this will be active. So I want to show you the okay, once the failover is up, I will show you the monitored interfaces that I wanted to show you with the help of the standby this IP. Yeah, let's wait for this to come up. In the meantime, what we will do is we'll go to the on the notepad and type the command that needs to be so here I'll do show run failover, and let's copy all the failover commands. I think this copy, and I'll go to ASA here. I don't need this. On the top, I don't need this actually. These one. Yeah, I'll keep it on the, and this is my Cisco. Okay, I have to specify this failover LAN unit primary. That I forgot. Here I have to specify as failover LAN unit secondary. Okay, good. So that has been done, and also the IP address, everything is same, just that this needs to be like this. Now on the other ASA2, just remember, so if I see show failover here, now you see, now this box, this primary host, right, is active for both the context, and secondary is not detected yet, so keep it like that. Let's go to ASA2 here. Now this is a blank firewall. If I see show failover, nothing is there, right? Off, failover off. So now I'll configure these, and I'll push it. Done, and then I'll activate failover, and now I'll wait for the active mate to be detected. Now it has detected active mate, so the configuration replication has begun from the mates, and you can see it has received the configuration for the context 1, context 2, and everything else. So if I configure, you can see the host name has been changed. Show interface IP brief, if I do, you will see now that I have the sub interface is created. Even if I do show context, all the context should be there. Yeah, so first part we have done. Now if you do the show failover here, now just see the change. Now For the group 2, this secondary box is active. Now here you saw that it was active for both the groups, right? Now if you do show failover, you can see it is active for the context 1 and it is on standby for the context 2, which is the other host is active. So that is how the active and standby is working right now. So now this is only one thing that we have done. So now to check, because I said like context only the changes should be done on the active box. So for context 1 this is active, for context 2 this is active. How would you know? I'm checking on the host name, they are both same. You should be confused, right? So there's a command prompt host name failover, or you can say context and then say state. You have to do this on the primary and you will see this the active and standby being shown here. Now when you change to context here, change to context CTX1, you will see this is still active. But here if you change to context CTX2, it will say that this is standby because context 2 is active on your ASA2. You go here, you can see this is active. So that means now if you want to do any configuration changes on context 2, you need to do it here, and if you want to do any changes on context 1, you need to do here. So let's start with the context 1 configurations. So now if I go into show interface IP brief here, I should have only 2 interfaces, Ethernet 0.10 and 1.2. So let's configure. So with this, I mean dot 0.10 is my outside, right? So I need to go to the interface Ethernet 0.10 name if outside. So all the configurations will be done in the sub interfaces now. IP address 192.168.10.10 255.255.255.0. If I hit enter here, it's fine, it will be taken. But the problem is this interface will not be monitored. If this interface goes down, the failover will not be triggered. But if I say standby 192.168.10.11, which is the other side, and enter, now this is monitored. This interface is, I'll show you that. But this is one interface. Now I need to go to the other side, which is interface ETH 1.20. If you go to this, yeah, this one, enter. Now name is inside, this one is inside, and automatically the security level will be set to 100. Now I need to configure the IP address. IP address 192.168.20.20, or you can say 10. This should be 10. This side should be 10, and that side should be 11. Okay, that's how we will keep. So I have to change the R4 gateway because I configured as 20. Yeah, I configured as 20. Let's keep this as 10 and the other side as 20 because I mean it's like the VLANs, right? 190. Okay, so I cannot see this here. Let me just expand. 192.168.20.21. Or we can see keep as 20 as well, 20 and 21. That is better. That sounds, because the other side is 21, the VLAN. So let's keep this as 20. Fine. That's done. Exit. Now I need our default route towards the route outside 00, which will be pointing to R3 192.168. I don't need this actually. I'm just going to. So let's leave it like this. I don't need this. But in case you do, you have to point it towards the ASA. Sorry, R3. Yeah, 00 192.168.10.3. Yeah, you can do this. Okay, sorry, I forgot to mention the outside interface like this. Then I need the NAT. Okay, so for this, I need a NAT with from this pool. So for this context, so I'll go and say object network pool, and then I'll say range. So I'll take a range from this IP address, which is 10.50 to 192.168.10.100. Okay, then I'll go and create another object for inside object network, say INS, and the subnet is 192.168.20.
0 with a 24-bit subnet mask. Now here I configure the NAT statement. Simple inside, outside, a dynamic NAT, dynamic, then the pool. That's it. Done. Yeah. Now the context one is done. If I go and say write memory, that's how you write to all the context. Now here I want to see the show failover. Now you can see the monitored, right? Outside interface, normal, not monitored because on the other side I don't think I have the interface there. So I have, for the outside is 11, for the inside is 21, outside is 10, inside is 20. So this is for the active box, this is for the standby box. Okay, so if I go here now, if I say show interface, show IP, you will see the active and standby IPs here. So this is for the system and this is for the current. So that means I'm in the active context. So if I change to context, say change to context CTX2 and I do the same, okay, change to context CTX2 and I do the same command show IP here. Okay, so I'm not configured for the context 2. I have to go to the other box. So that would be different. If the IPs are same, that means I'm in the active context, right? Okay, let's exit from here. So this is done. Now if I go to okay, now if I go to show interface IP brief, now I should be able to reach the the R4 and also the R3 from the context. So now if I go and change to the context CTX1, which is active on my this show interface IP brief, if I do, yeah, so I can ping 192.168.20.4, which is my R4, and also I can ping the external 10.3, which is my R3. So the context 1 is working right now. Okay, so let's go to the context 2. How you can go? You have to go to the active box, which is my ASA 2, to configure the context 2. Now to configure context 2, I need to see here. Okay, so for this side I have, okay, I'm in the context 2 already, and if I do show interface IP brief, I should see 2 interfaces. So let's start with interface Ethernet 0.10, 0.11, yeah, and nameif is my outside here. Nameif is, let's say, outside, and the IP address is going to be 10 192.168.11 dot, this side is 11, 192.168.11.11 255.255.255.0, and the standby is 192.168.11.10. So now if I go to the other this one, and I do the show IP that I did on context 2, but I cannot do this on the context 2 because that is not active context. Yeah, so I can do it here on this active box. I mean, I can go and specify the context command. If I go and say change context CTX2, I can do that, but this should not be done. So I can do the show IP command, and it will you will be able to see the IP that we configured there. Now let's go to the other interface, which is 21 1 dot. So you can see when I configure this here, nameif, you will see this on the secondary box. Has been assigned to interface 0.1. Sorry, this was inside. This is inside IP address. So now this side is like 21. So 192.168.21.21 255.255.255.0, and the standby is 192.168.21.20. Yeah. So if I go again here, you will see that the IP has been reflected here. Okay, so that's said and done. Now I need again a route. You can have a route, or you don't need a route. Depends on the testing you are going to do. So route outside 00, and my next hop is 11.3. So if you ping 192.168.11.3, which is router through 3, it should be pingable. And also if you ping inside router, which is 192.168.21.5, that should be pingable. Yeah. Now I need again NATing from the secondary box, which is done by the object network pool, and the range here is from the 192.168.11.50 to 192.168.11.100. Yeah. Then I go again, I create the object network for the inside, and then I'll say subnet, which is 192.168.21.0 with a 24 bits subnet mask. Yeah, and then I say the NAT statement: inside, outside, dynamic, and the pool. Yeah, and if I show NAT details, you will see the NAT there. Show X-Late, you will not see any translations because this is dynamic. That's said and done. So now if I go here and see show failover, I can see that my interfaces are here, inside, outside, and this is the active box. This is the secondary box for the context 2. This is the active one. Okay, so if I go to my change to context here, change to context system, I want to go to the system and say say show failover. Yeah, context interface, all these interfaces are there. Now let me show you something to you guys. So let me be again into context here, change to context CTX2. So on firewall 2, I'm on context 2, and on firewall 1, I'm context. Let me go to change to context CTX1. Yeah, so when I see here now R4 to R3, I will create a telnet session. Sorry, is this, and now I need R4. So let's go here, enable, and then I'll say a telnet to 192.168. Sorry, 10.3. Yeah. Now here, if I see the show connection, there will be a connection there, and here it will not be any connections, because this traffic R4 is going from the context 1 of the primary box. You can see that here, even if you see the show X-Late, there is a translation for 20.4 going to 59. I mean, it has been translated to 59, but the concept is that you can see it will not work, but I will when I try again, it should work. Yeah. So if I go here, Cisco, so now you see that this traffic has gone through the context 1 on ASA 1. Now if I go on R5, this should go from this context. Yeah. So if I go here and say enable and telnet on 192.168.11.3. Now if I go here again and say show con, you see 11.3. Yeah, and the inside is 21.5. You can see show X-Late, so there will be a translation of 21.5 to that pool. So .91 has been taken. Yeah, again I have to work. I mean, the first try doesn't work, and this will work. Cisco 1, 2, 3. Only Cisco, yeah. And show users. If I see, it will be the .91 that was translated here, right? This one. And here also on the R4, if I go, I mean R3, so exit. So on the R5, if you see, the 59 is the other one. This is the one that we are using. Okay, so that's said and done. I'll exit from here. Now I want to show you the failover.
So for that, what I'll do is on the active context on both the firewalls, what I'll do is I'll create access list out permit ICMP any echo reply only. Okay, yeah, and then access group out in interface outside. So I need this on the other ASA, which is this one, and then access group out in interface outside. Now any so R4 and R5 will be able to ping the outside mode 192.168. Say this one is 10.3. Yeah, this is successful through the firewall. And also on R5, if I ping 192.168.11.3, this will be successful because of the ACL. Now what I want to do is I will create continuous pings. So I'll keep a repeat count of, say, something like this, some crazy number. Okay, fine. Here also I'll do the same thing. Repeat some crazy number. Fine. Now I go to this box. Okay, and I go to the system context, change to system. Yeah, and I say failover active, and the group is 2. Yeah, now I see show failover here, and now it's active on both the groups. And if you go here and see show failover, now it's not active on the wait a second. Yeah, you can see in the name itself, you can see it has changed, but you can see the ping was not, I mean, dropped, right? It was continuous. Now that was the failover. It was very quick. Now let's imagine the whole box going down. So if I go here and say failover active, no, I have to go to the system, change to context system. Yeah, now I say failover active group 2. Now I've taken a back from, if I see change to context CTX2, it will be back to active. Yeah, you can see active here also. If you go and say again the failover command, you will see this has gone to standby. Now let's imagine that the whole box fails. This ASA 1, which is R4, is using, right? So let me do one thing. I'll just go and reload this box. Yes, and yes. Please try again with a yes. Confirm. Shut down. Gone. Now you can see there is a drop of packets, but after some time, the ASA2 here, this one, should take over as active. I see right now it's on the standby. No, not like this. If I go to change to, see the I mean, ping started again. Now if I go to change to context system and say show fail over, I will see that this is active for both the box. But now when this box boots up, this will preempt, and again the ASA1 will be active for context 1 and ASA2 will be context for active for context 2. So let's wait for this to boot up, and you can see the pings are continuous, and there was a drop when the whole box, I mean, there was a major failover, right? The whole box went down, but still your network was I mean, had resiliency to heal by itself because using the failover, right, feature. So let's wait for this to come up again on this part. Let's space. Okay, wait. Do show failover, still there. It will take some time to boot up, right? So let's wait. You should take the failover for the context 1. Yeah, it is going to take it. Wait a second, and after some time you'll see that the secondary for put 1 is standby, and the pings are still going on. There is no disruption for the pings there. Still, you can see active, failover active. If I go here, say show failover, this is on standby both. It will take some time to preempt. Yeah, now it has gone to standby. Now this will be active. Yeah, so this is back to the state that it was. So yeah, so that was it for this video. Hope you liked my video. I mean, this is a major concept, and it is hard, but if you try, practice yourself, and watch this video again and again, and read books about this topic, you will surely get this topic done. Just to recap, in my last video, we have seen the failover, which was the active and active, and before that we have seen the active and standby as well. So now that we know both the features or the technologies, you can say, so let's go through the advantages and limitations, right? So in the active standby, you know that the limitation is one of the firewall remains as a hot spare, and the hardware is not utilized properly. And in the active again, we do have that active forwarding, but then again the whole there is not a proper load balancing kind of feature there, right? So it's like only one context on one firewall is active, and the other context on the other firewall is active. And what happens is you have one firewall with two contexts, and then there is another firewall with two contexts. So this is context 1, context 2, and again context 1, context 2, and then this connects to the ISP. This goes to a LAN, and then you have a switch here, and then it connects to your users, right? But then what happens is for a particular VLAN or particular subnet, you can say that one context is active, and for the other subnet or the VLAN, the other context is active, right? So this is the traffic pattern. So this was active. Now this active was the only solution until the 9.x code of the ASA. Yeah, so if you have a code which is above 9.x, then your option the best option to go for is the clustering. But 9.x below, you had only option for the active standby. So what is the active or the clustering feature in the Cisco ASA? So basically what happens is the Cisco ASA, right, with respect to the clustering. So you have two boxes. Now you combine these box logically into one single box. So like you have ASA 1 and you have ASA 2, but logically, so physically you have two boxes, but logically it looks like you have only one ASA. So people, if you know about the stackwise technology in Cisco switches, it is something like that, or VSS, you can say, or the VPC. But the difference between VPC VSS is that the VPC has separate management planes, but VSS and stackwise has single management plane, right? Single MGMT. And the same is the case with the clustering in here. So in clustering, you have a single management plane. So the master, right? Master or the primary box that you configure as the active box, So you go there and configure every policy, every rule, every change in there, and it will be synced to other firewalls in the clustering group, which was not the case in active-active, wherein you have to go to the active context of that firewall, right? So management plane was separate in active-active. So there you have the first difference, that the management plane is single, and then you can have in active-active there was a limitation of 2 firewalls, right? So but in the clustering you can have a minimum of 2 and a maximum of 16 firewalls in one group, depending on the hardware model that you have. And also the code should be like above 9.x, and also licensing. So you need licensing, you need the hardware, and you need the code, which should be 9.x, 9.x above, right? So that is the the feature or the add-on compared to active-active. So you can have more physical firewalls into one logical grouping. But then so this is the third one. But then one more feature is that all the firewalls will be actively forwarding the data, right? So it's not like that one firewall is waiting for the other to fail, or like the whole resources are not utilized properly. You know, it's not like that. All the firewalls in that this clustering group will be actively forwarding for the data, the data plane, right? So how does this work? I mean, with case of active-active, you had the failover LAN and failover link. So this is your ASA 1 and this is your ASA 2. So you had the LAN, failover LAN interface, and you had the failover link interface, if you remember. And failover LAN interface were used to synchronization of the configuration, and also the keep alive, the heartbeat, right? And the link interface was to synchronize the connection table and the NAT tables and the routing tables, etc., right? But in case of your clustering, now what you have a interface, a single interface, which is called the CCL, which is cluster control link. And in the CCL, you do everything which the LAN interface and the link interface does. So you forward the config replication, you do the synchronization of the connection, and also in the case of asymmetric routing, the data will be also passed through the CCL, cluster control link. I will explain that in a short moment, but just to just for you to understand, so we have a cluster control link, and we can have multiple links for this, and you can bundle this into one port channel group, right? So how does this work? As you have seen in the previous lessons where we had the redundant interfaces, yeah, you have seen the port channel there, right? So kind of that you create the sorry, let me take this interface. Yeah, now we had the port channel as well. I've shown you the video. You can go back and check the interface redundancy section. So in that, what we do, we created port channels with the switch, right? So here also it is the same concept. If you know about MLAG, multi-link aggregation, multi-chassis link aggregation, you have 2 boxes at the uplink, and then you have a single firewall here, switch here, and then you create this port channel here like this, and a port channel like this. So this switch doesn't see 2 different boxes. It thinks that I am connected to a single box which has the 2 links in a port channel. So that's how you do the clustering. And also for the upstream, you also have the switches here with the port channel. So logically this is one firewall, but physically there are 2 firewalls inside it, and they're behaving like one, and they are forwarding the traffic actively. And the load balancing actually is taken care by the switch here. So the LACP algorithm takes care of the load balancing. So it's Again, in your control, you want to do it based on source IP, destination IP, source MAC, destination MAC, source and destination IP, source and destination MAC, like that. So you can control it on the switch itself. So that was one thing based on the cluster control link, right? The cluster configurations. But here in this case of Cisco ASA, you have two modes for clusters. So I will go through that. One is your span mode, and the other one is your individual interface mode. Okay, so this will be individual interface mode. Yeah, so these are two modes. So let's go through the span mode. In span mode, what you do is you have, with the design is just like I showed you, you should have a switch upstream that supports ether channel, and then you have the ASAs here, two boxes, and also on the LAN side also you should have the switch which connects to the ASA like this. Okay, now what you do is you bundle these links into an ether channel, and the traffic is taken care by the load balancing algorithm on the switch, which is the LACP. So this mode, this configuration is called the span mode. So you have to change the mode in case of when you are configuring the ASA here. So this is like a single firewall here, and the actual load balancing is carried by the switch here. Yeah, so that is one thing to know. And by the way, this is the most common method which is practiced in the corporate net sector, right? And the next mode is your individual interface mode. Individual interface mode. So how does it differ? So in the case of individual interface mode, what you do is you have the routers instead of your switches which connect to the firewalls. You have, say, 3 firewalls we can have, and then these are connected to the same LAN like this. And then you have in the LAN also you have a router. You should have a router. It's not like instead of the switch you should have the routers here. But then what you do is you have a subnet here, say, and here say 172.16.1.0. So so just imagine this is your inside and this is your outside interface. So now what you do, you basically, so these are the firewalls 1, 2, and 3, and these are part of the cluster group, of a single cluster group. Then what you do, you assign IP addresses from, say, this is 1.1.2.3 and this is, say, .4. Now you assign the IP address from the same subnet to each firewall. In the case of span, you had the IP address on the port interface port channel, okay, and there was a virtual IP there. So here what you do again, 1, 2, and 3 from the local subnet, like that. So you have the subnets like this, and then what you do is you run the routing protocols here on this leg, routing protocol, for example, say OSPF, and also here a routing protocol on this leg as well, OSPF. Now what happens is, in this case, the actual load balancing is taken care by the ECMP of the routing protocol, equal cost multipath. So the router is going to decide whether to forward the traffic to .1, .2, or .3. So like that, this is the individual interface mode wherein you configure the routers. And because of this design requirement of having routers, this makes it a bit expensive and people don't prefer this. Instead, they go for your the span mode, wherein also you can have redundancy on the switch level. You can have the stackwise running on the switch, or you can have VSS running on the switch. So you don't have that single point of failure on the switch level as well. and then we are talking about the high availability on the firewall, so we have the option of clustering here. So one more important concept that I want you to understand is the packet forwarding, right? So in this case, if the just think, so this can happen that there's a traffic, and the first traffic goes through R1, right? This, and then goes to the whatever resources over on the internet, and then there will be a reply for that, and that reply can the return traffic, because the router is responsible for the load balancing, it can forward it to other firewall on 3. So now here you have the CCL. So CCL should be on the same L2 domain. Okay, they should be on the same subnet and also on the same L2 domain. Okay, same subnet and same L2 domain. So you have to assign an IP address schema here. So I'll show you. Now what happens? What happens when these things happen? This is called asymmetric routing. Yeah, asymmetric routing, because the traffic went through one direction, and the return is coming through a different direction. Now in this case, there is a very good logic inside this design. Is you have concept of the manager. Basically it's the flow manager, and then you have the flow owner. Okay, so this is based on the load balancing, the firewall, right? It does share the traffic based on flow. So for one flow, one firewall is going to be the owner, and for other flow there is going to be another firewall who is going to be the owner, and for the third flow there is going to be another firewall who is going to be the owner. Yeah, so that is like that. But now the details for the ownership, right, who is the owner for that particular flow, is maintained by the flow manager. And these owners, right, they can come to the flow manager and check who, if they don't know who is the flow manager, then they can come to the flow owner. They can come to the flow manager and see who is the flow manager or owner, and then forward the packet to that particular owner through the CCL link. For example, in my previous case, what I was doing is, well, I had this green flow, right? Let's go for the green flow. So we had this green flow that was passing through the ASA1. Now the flow came to ASA3 here, landed here. Now ASA3 is not the owner, obviously, because the owner is ASA1 for this flow. Now what it will do, for example, just imagine this is the manager. Now it will do a query to the manager asking for the owner of this flow, and this will reply with the details of ASA1, and then through the CCL link, this data will be forwarded to ASA1, and then the return will be again forwarded to the particular host. So this is called the this is the actual data flow. So you have to understand the flow manager, flow owner, and the importance of CCL link. So this is how the asymmetric routing is being taken care inside the cluster. So one more thing that I want to explain to you is, there can be 3 possibilities, right, for this flow, right? One thing is when a return traffic is received on that member of the cluster, either it can be the owner, yeah, in which case it will forward the traffic, to the source, traffic forwards the traffic to the source, right? That is one possibility. And there is another possibility that it is not the flow owner, then it is going to not the flow owner. Then in that case, it is going to query to the flow manager. Yeah, queries to the flow manager, sorry, queries to the flow manager and forwards the data through through CCL, right, to the flow owner. Forwards the data to through CCL to the owner. Yeah, that is the second possibility. And there is a third possibility wherein there is no owner. Okay, I don't know, this will go yellow. Okay, so now the third possibility is it did query and found no owner. Then in that case, what it'll do, it will create a flow. Yeah, if there is no owner, then it will create a flow and it will become the owner. Yeah, so that is the whole process. So this creating owner is when you have the traffic from in to out, not from out to in. In that case, it will drop, right? So you should have that connection there. Yeah, so that is the whole idea about the CCL or clustering. That is the whole idea about the clustering in the Cisco ASA. Yeah, how do you configure this? I will be going through the the configurations. Now, so basically, with respect to this cluster, configurations, you do the cluster bootstrap commands on the primary. Yeah, so on the secondary or the tertiary firewalls that you have, you have to also do the bootstrap commands. Bootstrap only, the bootstrap on all the firewalls, cluster bootstrap configuration. And once that bootstrap is done and you have the cluster up, which you can check with the show cluster info command. And if you see all the members are there in the cluster, then you can go to the active member or the master, which is set as the master. You can go to the master and configure anything that you like, and all the configurations will be replicated to the members. Yeah, so so that is one thing. So the management is pretty much simplified, and the inside the bootstrap, you do what you do is, the first thing is you say the group, right, cluster group, and any name. This is just a name. Say my cluster. Okay, my cluster, for example, my cluster, and then you specify the actual the LAN unit. This unit as what? LAN unit, and this is just a name, so I say primary on the first box. You can have anything, ABC something, right? And then you have the priority. This is what confirms the box is going to be the master or slave. So the lowest is preferred, and 1 being the lowest, so you will be the master, right? Then you can have a key for authentication also, right? Then you can have the cluster IP configured for that particular interface, say E2 in my case, and then the IP address, right, of that particular link, say for 172.16.1.1, and then the subnet mask. .0, and then you enable the cluster, and it will prompt you, and you have to specify yes. Before that, what you have to do, you have to go to the interface E2 and say no shut. First of all, this is mandatory, and then you have to change the mode, right? I think that the command is cluster mode or something, cluster mode, and then span or in individual interface, whatever you like. Okay, so that is the whole confusion, and let's now see this on our lab, right? Once I do this step by step, you will understand more clearly. So let's go to the lab. First of all, in this lab, I'll be having 3 ASAs, and I'll do the clustering with 3 ASAs. So I will have ASA 1, and then ASA 2, and then ASA 3. So I have 3 firewalls. And then what I'll do is I'll connect these firewalls. So basically, in the lab, what I want to do is I want to connect all these firewalls to a single switch, and I want to show you the layer 2 connectivity as well. So I actually need, so let's draw the physical topology and then the logical topology. So all the firewalls will have 3 interfaces connecting to the switch like this. 2 and 3. Likewise, 1, 2, and 3. So I have 3 interfaces, and then I have R1, and then I have R2. Right? Again, connecting to these to the switch. Yeah, I have a switch here. So now in this case, what I want to build is a logical topology that looks like this one. So I have 3 firewalls, ASA1, ASA2, ASA3. Then I need the ETH0 going to the internet. Oh, this is ETH0 of all the firewalls. So you know that in case of active clustering, you need the ASA models to be same hardware-wise, same software-wise, same. Even licensing should be same. And I mean, you can kind of aggregate the license as well, and also the interface type should be same. Yeah. So the interface that I'm using on the outside Ethernet 0 should be the same on the on all other members of the cluster. So this should go to a switch, for example. It's just an and then I need a router here. So the outside is a router too. Okay. So this is what I want. And then I want again this to connect to, for example, this kind of topology I want. R1 and all the interfaces going like this. And this is like ETH1, ETH1, and ETH1. And then I have the ETH2, which is acting as the CCL here, cluster control link. But remember, this cluster control link should be on the same L2 domain, and they should be on the same L3 subnet. Okay, so here you can see what I'll do now. Now let's have the outside VLAN. So here I have VLAN 20, the red one, and then I have the green, which will be my VLAN 10, and then I have the cluster VLAN. Let's take it pink. This is my VLAN 172. Yeah. So now, so I have a red. Okay, let me take the blue again. Yeah. So I have ETH0 here, ETH1 here, and ETH2 here like this. Same ETH0, ETH1, and ETH2. Likewise, ETH0. Center one is ETH1, and this is ETH2. Okay, and then this like gig 00 on the router side, and the interfaces on the switch doesn't matter. We'll see in the lab what all interfaces I have taken. Okay, so what I'll do right now is for VLAN 10. So I want ETH0 for the outside. So that means ETH0 is VLAN 20. So this one is VLAN 20. Okay, and likewise this port is VLAN 20. And this port is VLAN 20, and likewise the green. So this is like VLAN 10, ETH1 inside. So you can see here ETH1. Yeah. So this is the ETH1, same VLAN. And then inside R2, so this is also going to be the same VLAN. Then after that, I need the ETH2, and also the outside, that is R2. This has to be in the VLAN 20. Then for ETH2, I need these 3 links, which are going to be the CCL links, to be in VLAN 72. So here I need 3 VLANs on the switch, which is VLAN, all these VLANs, right? All these VLANs I need to create on the switch. So that is the configuration, one of the configurations. Then second configuration, what I need to do is I need to do the ether channel on the switch. Yeah, so what I need to do is I need to have the red ports in one ether channel, say ether, see port channel 20, and then the green in port green ports in port channel 10. Yeah, and yeah, that's it. That's the configuration on the switch. And then the ETH zeros would be part of one channel group, and ETH1 will be part of one channel group, right? Like we did in the port channel configurations related to interface redundancy. So that is the same. Once we do this type of configuration on the switch, then we have the logical topology like this with us. Yeah, so without wasting the time, let's begin with the configurations. Let me clear this. So the topology that I have is here. So this is the logical topology that I was showing, and this is the physical topology that we have. So let me go on first of all and turn on the devices, more action, and start all nodes. So I need to start this one, need to start this one, need to start the switch, need to start the router, need to start this router, and need to start the ASA. So you can see we have these three ASAs that these three ASAs, and I have a switch here which is kind of the ETH2, which are the CCL ports, right? They are in the same L2 domain. This can go to the same, like here I have the same switch, but then you have to segregate those with the VLAN, and they will have the same IP subnet 172.16.1.0, 1, 2, and 3 respectively from that subnet. So that is one thing. As you can see, this will be in a cluster group, say in CG1, cluster group 1, and then that is just the name, cluster group 1, right? And then you have an ether channel here. Then we will build an ether channel with these ETH0 ports on the ASA, and likewise ETH1 ports on the other side of the ASA, the LAN, right? So as you can see, we have the subnets. For the outside is 192.1.20. So 20 specifies the VLAN number, that is for outside, and then 10 specifies the VLAN for the inside, 10, 11, 11. And the interfaces would be .10 on both the sides, inside and outside, right? Yeah, so let's start with the configurations. So first thing first, what we need to do, we need to go to the switch and wait for the switch to boot up, and then we have to configure the switch. Yeah, so let me take a notepad. Here we have the notepad, minimize this, and what I want to show you is, so first of all, how to build the ether channel on the switch. Let's go to the switch and say enable, enter, then config T. Then you have the interface range. So you can see the ETH0 is going to the gig 00 here, and gig 01 and gig 02. So I'll take interface gig 00 to 2 as the range. Then I'll say channel. Okay, let's go to the this itself. Switch, that would be better. Yeah, enable. First of all, let's create 3 VLANs, 10, 20, and 172. Okay, enable config T. Yeah, VLAN 10, exit, VLAN 20, exit, VLAN 172, exit. So we created 3 VLANs. Now let's go to the interface range, gig 0 by 0 to 1 and 2. So here what I want to do is channel group. So that side which goes to ETH0 is my outside. So each 0 is my outside here, you can see. So that is VLAN 20 channel group. Then the channel group number, this can be different from the VLAN, but I want to be, just for the configurations to be synchronized in the sense for troubleshooting and all. Then you specify the mode and the active. So this is the mode, and to make them part of the same VLAN, you can go to the interface port channel. Yeah, interface. So exit interface port channel 20. Then here you specify, first of all, I'll do a shutdown to this. So this is very important for the order of operations. You shut down one side and then you configure the other side, and then no shut both the interfaces. So here what I'll do is switch port mode access and switch port access VLAN. This is part of the outside interface, so 20. Now I'm using the iOS. If you are, if you end up using the IOL, so you might have to go to the interface range and type these two commands. But if if you check here, do show run interface, interface gigabit 00, you will see the switch port commands are already there because I went on and I configured this on the interface port channel. But in case of IOL, this doesn't happen. Then you have to go to the interface and type these two commands. Do remember, because I will have these configurations on all the three interfaces automatically. Yeah, so that is the I have created the, if you go here and check the show channel group or port, ether channel here, ether channel summary, you will see that the 20 is there, but it is in the S and D. D means down, S means your capital S, right? Layer 2. So I have a layer 2 port channel here. Okay, so this part is done. This is my outside. For R2 also I have the outside. So the interface that goes to R2 is gig 3 by 1, right? So I'll go to interface gigabit 3-1 and say switch port. I'll make that switch port mode access, and I'll make that part of the VLAN 20, which is the outside, so that they are in the same L2 broadcast domain, right? Then I need to do the inside one, right? The ETH, which one? The ETH one side. So ETH 1 goes to the inside. So ETH 1 connects to 10, 12, and 11. So now go to interface range gigabit 1/0 to 2. Covers all the interfaces. Then you say channel group. This is 10 mode active. Then exit. Then go to the interface port channel. Which one? Port channel 10. Yeah, 10 is inside, and do a shutdown there first of all, and then you do the switch port mode access and switch port access VLAN 10 for the inside, and also you go to the interface for R1, which is G3 by 0, interface G3 by 0, and do a no shut. No shut is not required. Okay, I forgot the G. No shut is not required because this is switch. All the ports will be up anyways. Then what I'll do is I'll make this access port, and I'll assign this to VLAN 10, which is the inside. So that is it on the show VLAN brief. If you see, I want to do show VLAN brief. This is the configuration on the switch side. So I have the gig 1, 1, and 1, 2. Gig 1, which is the ETH 1, should be going to VLAN 10, and this is to VLAN 2. And okay, what I did something wrong. Okay, I didn't do the configurations for the VLAN 172. So the ETH 2, which is going to be the CCL link. So I have gig 2.1 and 2.2 and 2.0. Okay, 2.0. So I'll go to the interface range. Gigabit 2/0 to 1 and 2. Yeah, 3 interfaces covered. Switch port mode access, switch port access VLAN 172. So this is my CCL link. So they need to be part of the same L2 domain. So I made this configurations here. Now, what I need to do later, I have to come back when I configure the port channel on the ASA side. Then I have to come back and do unshut on the port channel on the switches. Yeah, so you can see these two are administratively down for now. Okay, great. Let's keep it like this. And now is the time to go to the ASA. Or before that, I can go to router 1, say no to this, and router 2 as well, say no to this. Now let's go to ASA 1. Here, what I need to do, I'll config T, and let's have a host name of ASA 1. Yeah, so this is my ASA 1, and I have the ASA 2. Enable config T just for the confirmation sake. I am going to change the host name. This will automatically change later when I do the cluster. Enable config T, host name ASA3. Okay, great. I have all the ASAs up now. I want my ASA 1 to be the master. So how do I do it? First thing first, to go to that particular interface, which is our ETH2, that is going to be the CCL. You go to that interface. Okay, enable config T, and you say ETH2 no shut, right? So this is the command. You have to go into every ASA and put it down. First thing first. Yeah, no shut ASA 1, and then you have the ASA 2. Okay, interface ETH. Why you don't have ETH2 here? ASA show interface IP brief. If I do, you don't have the ASA2 is having some issues. Let's go to ASA3, show interface IP brief. I see it's also having some issues. So let's close this. And for the time being, I just want to do is I want to stop these two and wipe and wipe. If not, then I have to again do what? Delete this and add new nodes. Let's start again and hope that this works now. Okay, till the time being, what I want to do is on the ASA, now that show interface IP brief, you see that the which one? The interface is up E2. Now, first thing first, what you do is you go and configure the cluster interface mode. Say spanned. So we are going to the spanned, or if you want to go to the and do the individual interface mode, you can say individual and enter. But what I want to do is span. Once you have done the span mode, it will automatically, even if you write areas or something, it will stay in that mode. How do you confirm show? I think cluster mode, cluster interface mode, yeah, like this. So this is the command that you type to see the current mode. So my mode is right now is span, right? So that is one of the verification commands that you can use to verify what mode your firewall is in. So I want to do the span, right? So I've done the span command mode. Now, next thing, I need to go to the interface ETH2, or what you can do is you create the cluster. First of all, say cluster group, then -CG1. Inside the cluster group, what you do? First thing first, you have to get the key. You can give the key, but let's go for the LAN. LAN unit, I think. Local unit, yeah, local unit. Then I will say this as primary. This is just a name. You can say ABC, something like that. This will come on the after the host name. Yeah, primary, just for the configuration sake that I know this is the primary, secondary, the tertiary, right? So that is one thing. Then what you do is cluster interface command, and you specify the E2 is my cluster interface and the IP. Then you give the IP address. 16.101 is my IP address for the ASA1. Likewise, I will have 2 and 3. So that is clear now. Now you give the priority. Lower the priority is preferred. Okay, so 1 is lowest. If you go here and head like that, so 1 to 100 you can configure. 1 is the lowest and the priority. So this will be my master. Yeah, then you give the key Cisco. So what I have configured is, if you go here, I've configured the cluster interface. I've configured the key, local unit, priority. Now I need to enable it. Cluster interface I configured, right? And then at the last you will say enable. This is how you enable the cluster, and you confirm with a yes. Now to check the cluster, the command is show cluster info. This is the verification command. Now you can see that this is in a state of election, and as there is no other firewall participating in this cluster election, this will become the active. So wait for this, and let's for now go to ASA2 and see if that has been resolved. I mean, was having some issue, right? ASA2. No, doesn't seem to work. Now let's go to ASA3. This has booted up. Go to ASA2. No, close this, stop it, and I need to go to ASA1 again and see. So you can see now that from disabled it has been transition to master. So now if you again do the verification command, you can see this is the master. So the best part about the cluster is that all the configurations will be done on the master, and then it will be replicated to all the slaves or the other member groups. Yeah, so now to make the other firewall as the members, you need to go to the other firewall and just do the bootstrap commands. Okay, now that we have the other ASAs running successfully, ASA2 and ASA3, they're here, and as you can see here, our ASA1 is the active member of the clustering group, that is CG1. So in order to make ASA2 and 3 part of this cluster group, you just have to type in the bootstrap commands on the secondary and the tertiary ASA. Likewise, you can have up to 16 ASAs, right? Depending on the hardware and the license. So what we will do on the primary ASAs, we will check the show run cluster, and then I need this whole of the config here, and I will copy it here, go and paste it here. Now here what I need the key, that is Cisco. I need the local unit, this is my secondary. I'll go for the secondary firewall, and this is going to be 1.2, and priority is going to be 5. I don't need these two, and then enable. Good. So this is the whole and also the mode, right? So let's go first of all do this on ASA2. So ASA2 is this one, enable. After enable, I had type enter. So this should work now. Yeah, no shut. Now after this, I need to check the show interface cluster mode. I think show cluster interface mode, something like that. Cluster interface mode is there, so that should be span. No interface mode. You have to make the cluster as the interface mode span, because we are doing the span mode. So this command needs to be added here for the third ASA. I will paste it here and a couple of enters. So after that, I will go and do these configurations, and That's said and done. Now I will enable. Once I enable, this will start looking for this will start joining the cluster group CG1, and it will find that I already have a master, so I need to change it to slave. So you can see it has, you will find some errors. It's because of the iOS version and the limitations on this. Just ignore it, and now you can see that the cluster unit transitioned from disabled to slave. Now if you check here, show cluster info, you have this is secondary. As I said, this is just a name. You can have any name. This is secondary and in state slave. And I have the cluster IP here. I have the serial number. I have the version of the code that I have installed in this. And then I have the CCL MAC. This is the MAC address of your cluster control link, which you will see it's same for every cluster member. And then the joining. Yeah. So if you go on to your ASA 1 and check the clustering, not this one, this one. So you see, I am the primary and I am the state of master. But how will you? You cannot just go to the ASA and again do the show cluster info and check if it's active with the master or not. Then you do the configuration. Yeah. So there's a beautiful command which you might have seen before in the active classes. So the command is prompt host name, and then you go and say cluster unit like that, and you can say also state. So now it says that the unit is primary and the state is master. And if you go to ASA 2, which is this one, and now you see it's secondary and it is slave. Yeah. And now you are inside the cluster configuration, exit from there. Now you don't have to do any configurations on ASA 2. I will just minimize this. And now let's go to ASA 3. What all configuration you need to do? You need to do the same configurations until here. So I'll just again copy. Okay, I don't need to copy. I just change the name to tertiary and the IP to 3.3. That's all I want. Or else I can also do the 6 so that it is going to be after ASA 2. So I need to go to ASA 3. This is my ASA 3 and paste everything here. And yes, now once I do this, it's also going to join that and pull the configs. But as of now, I don't have any configs. If you go and check the info, you will see now 3 members. Yeah, so you have the primary, which is myself. I have the IP address of 1.1. Then you have the secondary, which has 1.2. Then now you have a tertiary unit, which has the 1.3. Yes, it's also in slave mode. Now after this, once this is done, everything is smooth now. Now, first thing first, what you need to do is you need to go to the Ethernet 1 and Ethernet 0, which is inside and outside respectively, and bundle them in a channel group. So for that, what you do? Interface Ethernet 0, which is my outside. I'll say channel group. What is the group? Outside is 20 mode, and I'll say active. So I'm making that part of that ETH0 part of that channel group 20. And then I say exit and interface port channel 20. Now here, first of all, I'll do a shutdown. And here what I need to do is a command that is like expand or port channel. Yeah, port channel. Let's just span or span cluster. Yeah. So you need to specify to this port channel that this belongs to a cluster. Yeah, and then also it's recommended to have a MAC address, a virtual MAC address, say 001.1111.1.111a, or you can say this is outside. So I'll keep all ones on outside and all or twos on the inside. So you have a virtual IP as well as a virtual MAC, which you define on the ASA, which is the master. So once you do this, then you go and specify the name if. So this is the outside and IP address 192.1.20.10 with a, you don't need this, but yeah, like that. You have done this. Now you have to go to the switch and enable the interface port channel 20. So let's go here, enable port 50 interface port channel. Port channel, okay, 20, and say no shut here. And also no shut here. Now wait for the port channel to come up. Yeah, you can see the port channel has changed to state to up. So remember this to keep it shut and unshut at the time of. So this order of operations is very important. Now to check this, I can go and say do show ether channel summary, and I will see that this is up. The 20 is up, which is the outside. The 10 is still down. But if you go here and say show interface IP brief, now you will see the 1.20 there, and also if you see show name if, you will see that this is the outside. Now I need to go to my outside router, which is going to be my R2. I think I have already R2 there. Yeah, this one. I think I have not configured the IP address here. To show IP interface brief. If I do, no, I don't have. So I'll go to the interface gig 0x0 IP address 10. This is my outside 192.1.20.2 and 255.255.255.0 and exit, and I'll go and configure the line VTY 024 password Cisco login transport input all and right. So my outside router is up, and I can ping from my router to the outside interface of my ASA, which is 192.1.20.10. Because my port channel is up, this should be reachable. If I go here, it will take some time. If I go to ASA 1, and if I see, yeah, this is up, and this should be reachable. I'll do exit, and I'll ping from here 192.1.20.2 is the router. Show IP interface brief. First of all, let me see if, okay, this is down from this side. So config T, if I do interface gigabit 0x0, no shut, and again do the ping. There it is. Yeah, this one. So this should work. Now if I do show ARP, I should see that virtual MAC address which I assigned to that port channel 20. Yeah, super. So my outside interface is done. Now let's go to the inside interface. So this is automatically, so if you see show interface port channel 20 like this, you will see that this has the ETH0 of all the so this is related to all the members in the group. So if you see show cluster and you can see the resources here. No, resources usage like that. Yeah, you can see all the details here. I just want to see the interfaces that I have. No, I don't have them. So this is how, I mean, all the three firewalls will have aggregated resources there. So connections, these many, and MAC addresses, these many, VPN sessions, you can have 15,000 like that. So you aggregate, and as of now, the local that has these things. and the secondary and the tertiary as well, you can see. So now what I want to show you is the now we will configure the ETH1, which is the internal. So likewise, you have to go to the Ethernet 1 interface and say channel group, which is the 10, and mode is active, and then exit, and then interface port channel 10, shut it, and then cluster mode, no, port channel spanned, I think mode spanned, port channel span cluster. Yeah, I forget this again and again. Yeah, so you specify the port channel span, then the MAC address again, which is recommended, not necessary. Okay, MAC address 0002.2222.2222. This is my internal MAC address or virtual MAC address. Then you specify the usual commands: name if inside, IP address 10.11.11.10 with /24. Now go to the switch, and now you have the port channel 10 down. Now go to that interface port channel, yeah, 10, and say no shut here, and also on the ASA one say no shut. Now wait for the port channel to come up. I see change to down, and it should be up. No, not as now, and yeah, so that is up, and I'll go exit, do show ether channel summary. If I do, you'll see that the port channel 2 is also, port channel 10 is also up. Now I need to go to the R1, which is my inside router, enable config T, and interface gig 0x0, no shut. First of all, IP address 10.11.11.1 255.255. So this is a /24 255.255.255.0 and right. Let's have I don't need that. Yeah, I need a default route pointing towards my ASA. That is done, and right. So if I see show IP interface brief here, I should have the 10 IP and it's up. So now if I ping on the 10.11.11.10, which is my inside virtual IP address of the cluster, which is reachable. If you go here now, if you go on any ASA, this is my tertiary ASA, and see it will have the same IP addresses as the master. Yeah, but if I go on to my R1 and then I tell it, which I will not be able to tell it. Now what I need to do is I need to have a reverse route on the router 2 towards the inside, which is this one. Now here I'll see you all, and config T. Will not use natting. There is some problem with the natting, I don't know. Let's try this IP route 0.0.0.0 and 0.0.0.0, and I will be pointing towards 20.10. And now I'll go to router 1 and do the same thing again. It should be working. Yeah, there is some bug, I don't know, on this ASA. So users, because of that there was the issue with the. So now if I go here and turn this on, as it come back, it should go into the slave mode. Okay, let me see on the ASA 1 now. I am the master. ASA 2 is coming up. What about ASA 3? AC3 is there, and if I see a show con here, I should see the con. Show X late here, I should see. Okay, I don't have an X late right now, but there's a connection going on. Now let me just do the cluster master here and make this as the master. So now if I go to R1, that connection is still on. This is what I wanted. Yeah. So that con connection table was already synced with the other slaves in the group, right? So that's why the connection is still on. If I do this again, so this is my master now, this is my slave, you see, and then I go do the cluster master again here. Wait for existing master quit, use show cluster info. Okay, T cluster master. Okay. Wait for this too. Okay, now I have another slave. So if I go here, this is a master, show cluster info. Okay, I have three, which the secondary is actually coming up. I want to see, this is my secondary firewall. So if I do a show cluster info here, show cluster info here, I have the two boxes in slave mode, and the tertiary one is my master. So if I see show con here, the connection table should be here as well. That is the reason I was. So now if I do a cluster master here to make this as the master, now if I go to R1, that connection should still be on. So even if I go and do so let's do a continuous ping to R2 enable ping, sorry, enable, and okay, I need to exit and then ping 192.1.20.2. So I'm going through the firewall, which will not be allowed because the return traffic will be dropped. So I'll go to the master, and what I'll do is I'll just configure an access list out, permit ICMP any EQ echo reply, echo, and then reply, access group out, in interface outside. So now that ping should work, and then with a repeat count of say some 10,000 or like. Okay, now I am on ASA. So let's go here and ASA this one. So first of all, what I'll do is who is the master for me? This is slave ASA1, ASA2, no, ASA2 is the master. Okay, let's go to ASA2 and let me see this. Okay, ASA2 stop. Now I need to go here to see nothing. ASA2 is, just stop it. Okay, nice. Nothing is stopped. ASA2 gone. So I see a single drop here, which means it did make the transition. So now who is the master? So I see ASA1 is the master. Let's go to ASA1. Stop it. Now let's go to this. I can see there is drop of packets here. Now this should transition to ASA3. So this has become ASA3. If I see show con here, so this is having some issues here because we did boot it, reboot. That's why. So now if I go to ASA1, okay, ASA3 is the one. Yeah. So ASA3 is having some issues. Let's start ASA1 and ASA2 here. Now for the time being, this router obviously it's going to drop, but you can see this transition right from the master to the slave becoming a master. But there is some issue with the virtual software that we are having. So You can try it at your place. This is how it is done, and you can hope you understood the concept. It's better that you go on and try this on your side. Build a lab like this. If you face any issues, just ping me in the comment and I will try to reply as soon as possible. So that's it for the video, and see you in my next video. Till then, bye bye.